and gentlemen, the first ever SemiconIndia conference is being organized by India Semiconductor Mission in partnership with industry and industry associations under the visionary leadership of Honorable Prime Minister Shri Narendra Modi, with the aim to make India a global hub for semiconductor design, manufacturing and technology development, which will of course help propel the vision of India Semiconductor Mission. On behalf of the entire organizing team, I am Shankar Prakash. I would like to welcome all the delegates who are present here. A very hearty welcome to all of you, ladies and gentlemen. Yes, indeed. At the same time, we would also like to welcome more than 9,000 delegates, ladies and gentlemen, more than 9,000 delegates who have joined us globally, virtually right through the world. And it's indeed a confluence of best and brightest global leaders from industry, research and academia. But whatever it is, how much ever we are knowledgeable, how much ever we are updated, we believe and know that our traditions are indeed the strong foundations for our growth and development. The traditional auspicious lighting of the lamp signifies that the darkness of ignorance be swept away by the dawn of self-realization to give us wisdom, ladies and gentlemen, to make the world a better place. At the same time, it represents the ethos of our long cultural upbringing, strongly rooted in our philosophy. In today's knowledgeable world, we all know it's the wisdom, the knowledge, Goddess Saraswati. And if we have this, we will of course be blessed with wealth, Goddess Lakshmi. And if we have the Ashirvad of Goddess Saraswati and Goddess Lakshmi, we will be blessed with the power, Goddess Durga. To symbolize this, it's indeed a matter of great pleasure for me to welcome on stage Mr. Jaya Jagdish, Country Head AMD India. Please put your hands together. Chitra Hariharan, Engineering Strategy Head, IOTG Silicon Products Intel. Ritupurna Mondal, General Manager, MediaTek Bengaluru and Director of High Performance, Technology. And the august presence of the Honorable Ministers says it all, ladies and gentlemen, that the government is with the entire fraternity. And before inviting the Honorable Ministers, I would request Shri Vinod Dham, the founder of Indo-US Venture Partners, better known as the father of Pentium, to kindly come over. And I would also request the Honorable Minister of Electronics and Information Technology, Communication and Railways, Government of India, Shri Ashwini Vaishnavji, Shri Rajiv Chandrasekhar, Chairman of the Steering Committee of SemiconIndia 2022, Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India, to traditionally light the lamp to signal the beginning of a new era in the history of India. Ladies and gentlemen, SemiconIndia 2022, the traditional lighting of the lamp. Catalyzing India's semiconductor ecosystem, and the vision is to position India on the semiconductor map of the world and build a vibrant semiconductor innovation and manufacturing ecosystem. We would like to thank all the dignitaries for traditionally lighting the lamp. I request all of you to kindly get back to your seats. Well, let's hear it for the friends from the print and electronic media also. They have come here in large numbers, and millions and millions of people around the world will be known through the media. So let's have it for the media friends also, ladies and gentlemen. Thank you very much. Well, all of us have understood what SemiconIndia 2022 will be all about, but to know more about SemiconIndia 2022, sit back for the next 3 to 4 minutes and let's watch the video. Video, please.
is united for good, something magical happens. Whenever great minds have shared a stage, a great future is promised. India is proud to bring together the world to a universe of opportunities in the semiconductor sector. Welcome to SemiconIndia 2022, catalyzing India's semiconductor ecosystem. Remembering Professor Jagdish Chandra Bose.
देश में आज एक तरफ इनोवेशन का जुनून है तो दूसरी तरफ इनोवेशन को तेजी से एडप्ट करने का जज्बा भी है और इसलिए डिजिटल इंडिया भारत का संकल्प है। डिजिटल इंडिया आत्मनिर्भर भारत की साधना है। डिजिटल इंडिया 21वीं सदी में सशक्त होते भारत का एक जयघोष है।
Bringing together global semiconductor leaders, India is unleashing its unlimited potential for design, manufacturing and innovation. For the first time since independence, rapid, decisive strides have been made in this space. India's electronics manufacturing is expected to exceed $300 billion by 2025-26. And demand for semiconductors to be $80 billion by that time and $110 billion by 2030. India's semiconductor demand will also be driven by its focus on the future of automotive, mobility and communication, 5G, 6G and compute. The Government of India has approved to SemiconIndia program an incentive outlay of $10 billion to provide financial support to semiconductors fabs, compound semiconductors, silicon photonics, sensors including MEMS fabs, semiconductor ATMP, OSAT units and display manufacturing. With nearly all of the top 25 semiconductor design companies setting up R&D centers and almost 20% of the global semiconductor design talent pool, India is fast building a vibrant semiconductor innovation ecosystem, including helping create the next generation of semiconductor startups. The vision of Prime Minister of India, Shri Narendra Modi, is to make India a global hub for electronics manufacturing and the semiconductor industry. Today, in the post-COVID world, Digital India is a trusted partner to the world for digital products and services, including semiconductors. This is an exciting time for Indian tech, a decade that Prime Minister Modi has named India's Techade. Let us share, exchange and partner ideas at the first edition of SemiconIndia 2022, catalyzing India's semiconductor ecosystem.
Well, ladies and gentlemen, it's going to be India's decade, showcasing India into the world. And Semicon India 2022, of course, will go a long way towards catalyzing India's semiconductor ecosystem. And also, the conference would serve as the formal launchpad of India's semiconductor strategy and policy, which envisions making India a global hub for electronic system design and manufacturing. At this juncture, it's my pleasure to request the Honorable Minister of Electronics and Information Technology, Communication and Railways, Government of India, Shri Ashwini Vaishnav, to kindly come over here and address all of us. Deviya Sajjano, please put your hands together and let's welcome Shri Ashwini Vaishnav ji.
Very good morning to all of you. Today, we are inaugurating this very, very important milestone in India's technological history, India's tech journey. SemiconIndia conference. This conference is going to be one of the major milestones in India's decade. Honorable Prime Minister Shri Narendra Modi ji, who's going to join us virtually very shortly, my colleague, Honorable Minister of State for Electronics, IT, Skill and Entrepreneurship, Shri Rajiv Chandrasekhar ji, who is the architect of this conference, Honorable Members of Parliament, Honorable Minister from Government of Karnataka, leaders from the semiconductor industry, eminent members from universities, research institutions, think tanks, and all the friends from media, I wish you all a very warm welcome to the SemiconIndia conference. My sincere thanks to our Honorable Prime Minister Shri Narendra Modi ji, who envisioned this program, who gave us this guidance, and who asked us to think long-term, think in a very sustainable manner, think differently from what rest of the world is thinking about semiconductors. This initiative is basically built on the strength that India has, and that is the strength of our talent. India is a talent nation. Our engineers, our doctors, scientists, academicians, researchers, students, they are all significantly contributing to the growth of many organizations all over the world. Whether it is IT talent, the tech centers here and many other cities, whether it is design of semiconductors or creating new motors for electric vehicles, every aspect of today's modern world, our talented engineers and designers are trusted by the world to deliver on solutions. It is this foundation on which our semiconductor program is built. We understand that semiconductor industry, developing a semiconductor industry in a country is not a sprint, it's a marathon. And we are prepared for it. We are prepared for the perseverance that is required. We are prepared for a very sincere partnership between industry, government, academia, research, which is really, really required for a sustained development of the semiconductor industry in India. That's why we are committed for the long-term development path. We understand that many countries are offering incentives. We have also offered very substantial incentives, financial incentives, but the big differentiator, when I have spoken to many of the CEOs of global majors, the big differentiator that has come out is that we have committed to create and augment our talent pool by 85,000 semiconductor professionals over next 10 years. These will be industry-ready professionals, and already we have tied up with global institutions like IMEC of Belgium, ITRI of Taiwan, A-Star of Singapore. Many more tie-ups will happen in future. My colleague Shri Chandrasekhar ji is working very actively with many organizations to make sure that the harmony between the skill ministry and IT ministry happens. Almost 100 academic institutions and R&D organizations have been roped in to train 5,000 professionals in research, 30,000 engineers, BTech and MTech, and 50,000 at floor level. So this is a very big commitment to augment our talent nation status. Friends, you are all aware that India is already home to 20% of world's VLSI design engineers. And 250 semiconductor design companies are working out of India. 24,000 design engineers who have designed more than 2,000 chips every year is what we understand from the industry. We assure you from the government that whatever feedback you have given over the last few months, we have taken it very seriously, especially the feedback about developing the supply chain of elements like the critical gases, the special chemicals. We have taken it very seriously, and we are working in a very focused manner so that by the time you decide to set up your fabs in India, we would be ready to provide you the entire ecosystem which is needed. We, through this conference and through many other mediums, we seek to engage with you, with the industry, and create a global semiconductor ecosystem in India, riding on our sincerity in execution. Prime Minister Modi ji's hallmark in his entire public life is whatever he promises, he delivers. And his team is here with you, committed to participate in your journey, committed to make the difference that is needed in this world, committed to make a very reliable supply chain in all these uncertain times of geopolitical uncertainty. Package of $10 billion plus our sincerity, plus the talent nation and our commitment to increase the talent pool. This is all before you. You have seen our performance so far, and I'm sure the response we are getting is a response which gives a tremendous hope for the future. Regarding the market size, I'm sure all of you are very well aware, we are already $76 billion in electronics manufacturing, on the way to $300 billion. And the way the smartphone usage, the 5G industry is growing, it's going to be a very, very high growth for semiconductors. We will be listening to our Honorable Prime Minister in another 2-3 minutes. I'll close here. I just want to make one small appeal to all of you. Use this conference to give your candid feedback. We are here to listen to you. We are here to understand what you need. We are here to make sure that whatever is needed to make this program successful, we will stand by you. We will make sure that each and every step is taken meticulously, step by step, in full detail, with full sincerity, and the full power of execution that Prime Minister Modi ji's government brings to the country. Thank you very much. Wish you all a very good conference.
Well, ladies and gentlemen, please remember the candid feedback. We need to be ourselves. We need to be realistic. That's been a great call given by the Honorable Minister. Let's give a huge round of applause to Shri Ashwini Vaishnavji. Thank you, sir, for your address at this juncture. Well, the 3-day conference have been carefully curated and conceived with topics related to the industry in terms of making India semiconductor mission successful. There are several sessions about various topics, the emerging semiconductor startups, semiconductor demand drivers. These are the sessions which we are going to be present today. And tomorrow, semiconductor manufacturing session, the compound semiconductor, at the same time ATMP and display manufacturing, and so on. Well, ladies and gentlemen, the time has come. It's indeed a matter of great pride, privilege, and of course an honor to have the Honorable Prime Minister of India, Shri Narendra Modi ji, addressing all of us in just a bit. Let's give a round of applause and welcome the Honorable Prime Minister of India, Shri Narendra Modi.
Namaskar. Namaskar, Bengaluru. Namaskar, SemiconIndia. My colleagues from the Council of Ministers, leaders of the electronics and semiconductor industry, investors, academics, members of diplomatic corps, and friends. It gives me great pleasure today to welcome you all to the inaugural SemiconIndia conference. I am glad that such a conference is being held in India. After all, semiconductors are playing a critical role in the world in more ways than we can imagine. It is our collective aim to establish India as one of the key partners in global semiconductor supply chains. We want to work in this direction based on the principle of high tech, high quality, and high reliability. Friends, I see 6 reasons for India being an attractive investment destination for semiconductor technologies. First, we are building the digital infrastructure to connect over 1.3 billion Indians. You have all heard of India's financial inclusion, banking, and digital payment revolution. UPI is the world's most efficient payment infrastructure today. We are using digital technology to transform lives in all sectors of governance, from health and welfare to inclusion and empowerment. We are one of the largest consumers of data per capita, and we continue to grow. Second, we are paving the way for India to lead the next technology revolution. We are on our way to connect 600,000 villages with broadband. We are investing in developing capacities in 5G, IoT, and clean energy technologies. We are working to unleash the next wave of innovation in data, AI, and other technologies. Third, India is headed for robust economic growth. We have the world's fastest growing startup ecosystem. New unicorns are coming up every few weeks. India's own consumption of semiconductors is expected to cross $80 billion by 2026 and $110 billion by 2030. Fourth, we have undertaken wide-ranging reforms for improving ease of doing business in India. Last year, we abolished more than 25,000 compliances and gave a push towards auto renewal of licenses. Similarly, digitization is also bringing speed and transparency to the regulatory framework. Today, we have one of the most favorable taxation structure in the world. Fifth, we are investing heavily in skilling and training young Indians for the needs of 21st century. We have an exceptional semiconductor design talent pool, which makes up to 20% of the world's semiconductor design engineers. Almost all of the top 25 semiconductor design companies have their design and R&D centers in our country. And sixth, we have undertaken several measures toward transforming the Indian manufacturing sector. At a time when humanity was fighting a once-in-a-century pandemic, India was not only improving the health of our people, but also the health of our economy. Friends, our production-linked incentives schemes offer incentives of over $26 billion in 14 key sectors. Over the next 5 years, the electronics manufacturing sector is expected to see record growth. We recently announced SemiconIndia program with a total outlay of over $10 billion. This program aims to provide financial support to companies investing in semiconductors, display manufacturing, and design ecosystem. We are aware that in order for a semiconductor ecosystem to flourish, it is necessary to ensure adequate support from the government. Allow me to put our approach in the language of semiconductors itself. In earlier times, industries were ready to do their work, but the government was like a NOT gate. When any input flows into the NOT gate, it gets negated. So many needless compliances and no ease of doing business. But we understand that the government must be like the end gate. While the industry works hard, the government works even harder. I would like to assure you that we will continue to support the industry in future as well. We have taken care to see that the SemiconIndia program addresses various parts of the ecosystem such as semiconductor fab, display fab, design, assembly, test, marking and packaging of semiconductors. Friends, a new world order is forming and we must seize this opportunity. We have worked hard over the last few years to create an environment that encourages growth. India has the appetite for tech and risk-taking. We have put the odds in your favor as far as possible through a supportive policy environment. We have shown that India means business. Now it is over to you. Friends, I look forward to practical suggestions from all of you about how we can move towards an India that is hub for semiconductor for the world in the coming years. Through this conference, we aim to engage with domain experts. We will work with stakeholders to understand what more can be done to build a vibrant semiconductor ecosystem. I'm confident that this conference will have rich deliberations which will help steer India into a new future. Thank you. Thank you very much.
Ladies and gentlemen, you would all agree that was indeed a visionary address by the Honorable Prime Minister of India, Shri Narendra Modi. Let's all once again give a huge round of applause so that the clappings reaches him. Thank you very much. At this juncture, I would request the chairman of the steering committee of SemiconIndia 2022, the Honorable Minister of State for Electronics and Information Technology and Skill Development and Entrepreneurship, Government of India, Shri Rajiv Chandrasekhar, to kindly come over here and address all of us. Please welcome Shri Rajiv Chandrasekhar.
Good morning, Ellarigu Namaskara, and for all of those who have come from outside Bengaluru, welcome to my hometown, my home, my uru, my city, and enjoy this. And I request you not to stay too long to leave after those 3 days because we have challenges in the city of traffic and so on and so forth. Anyway, that was just a break, small attempt at humor. My colleague and Minister Ashwini Vaishnavji, my friends, members of Parliament, PC Mohan, Tejasvi Surya, and of course the legend Vindham, who in many ways was a shining beacon for all of us when we were much younger, of course, in the valley, and continues to be a source of strength and inspiration to most people in the semiconductor space. Ladies and gentlemen, thank you all for being here at SemiconIndia 2022. It is on behalf of the steering committee, in my colleagues in the Government of India, the industry associations, sponsors, and most importantly, the Honorable Prime Minister of India. I welcome you all and thank you all for traveling from various places to be part of this first edition of SemiconIndia 2022. It is almost always very, very, very difficult to follow the inspirational words of our Honorable Prime Minister. And he has very beautifully laid out the ambitions and the vision of India in this space. He has talked about the active engagement of the government with all of you who are stakeholders, participants in this space, and the commitment that we would be partners in the journey to catalyze the Indian semiconductor ecosystem. The theme for this first SemiconIndia conference, as you all know, is catalyzing the Indian semiconductor ecosystem. And that statement maybe needs some explanation and expansion. And let me, in the few minutes that I have, lay out for your consideration and thought what this India's ambition means and what our Honorable Prime Minister's vision points to. Firstly, a little bit of a backstory. I think we will all accept and recognize and acknowledge that we are all emerging from the worst ever black swan type event that has been forced on the world in modern history. Every country and all the people all over the world had to deal with this COVID pandemic. Lives, livelihoods, and economies were battered by this unknown virus. And every nation has found themselves operating blind or flying blind. And in aviator parlance, it's flying VFR and an IFR weather, as every pilot calls it. And every nation has traveled through these 2 years differently and emerged, in my opinion, very differently. I don't want to comment on other nations, those who are still struggling with lockdowns and shutting down large cities, those who are struggling with vaccinations. I don't want to comment on which those countries are, but you know who I refer to. But I will simply put this to you, that India has emerged from these last 2 years a very different and a much stronger nation. We, in the first quarter of the pandemic, had to lock down, had to deal with very severe economic consequences of that lockdown, and for that year had to deal with almost $150 to $200 billion of economic losses. And while for large major economies in the West and maybe other countries, a $200 billion economic loss is not a big thing. For India, a growth economy, a $200 billion economic loss is a significant issue, not just in terms of the number it represents, but also in terms of what it does to the trajectory of growth. Despite that, and despite the ominous, all-pervading nature of the pandemic, India in these 2 years has shrugged off that economic loss, is today the world's fastest growing economy, and has demonstrated during these 2 years the things that it can do at scale. 1.8 billion vaccination shots in probably one of the largest, most effective vaccination programs in the world. Those vaccines designed, developed, and manufactured in India. 800 million Indians in one of the world's largest food distribution programs that has lasted over 2 years. That is social security at scale. And creating a momentum and a rebound of the economy post the pandemic, the size and scale and momentum of which the world is in awe of. I personally as somebody who's been an entrepreneur before I entered politics, I have total respect and admiration for in terms of what is going on today. And the Honorable Prime Minister referred to this, the unicorns that are coming out, the extent of foreign investment that is going into our tech economy and digital economy, and all of that. And most importantly, it is showcased to the world that old narrative of India being a dysfunctional democracy where the government doesn't function, citizens are at odds with government, it has in a sense turned that entire narrative on its head and said, India is a country that can do things at scale, take on adversity, bounce back from that adversity, demonstrate the strength of its economy, and government, citizens, state government, national government, science and technology can all be deployed to come out of these serious challenges. And I mention this because in today's social media-driven world, instant gratification, quick news, there is a tendency to forget and move on. And I want to especially bring this point to you in the context of this discussion on semiconductors and semiconductor ecosystem. On the digital economy, our Honorable Prime Minister has laid it out. Minister Vaishnavji has also spoken about it. Our ambitions are very clear. You are all aware that in this post-COVID world, the acceleration in terms of the digitization of the world's enterprises, consumers, and governments are at an unprecedented pace. You can see the tech economy in India has grown last year 16+% on a base of 250 billion. And this is all, in a sense, a continuum. Over the last 7 years, after Prime Minister Modi launched Digital India, the digital economy piece of the Indian economy has been constantly growing. It started with the traditional tech services piece. You can see the great success we have had on the internet economy. Now we are building the AI and data economy piece on top of that. The electronics piece, as you've also heard, is fast growing. And as a natural progression, we are now moving into catalyzing the semiconductor ecosystem. I wanted to tell you this because unlike countries and unlike some other places that think semiconductor is the fashion of the month, the flavor of the month, for us in India, the approach to catalyzing the semiconductor ecosystem, seeking out its growth, seeking out the expansion, is a very, very calibrated strategic roadmap of growing the digital economy into $1 trillion digital economy by 2025-26. The Prime Minister has referred to this as the India's decade, the next 10 years. And recently, one of the most important semiconductor CEOs that I know of visited India and tweeted and referred to the coming decade as one full of opportunities for India. And that is India's decade. That is the future that we are building the semiconductor ecosystem for. I'll just, before wrapping up, just leave this other thought with you. And the details of the semiconductor policy, Minister Vaishnavji has already laid out. The decade in India is being driven, and this is an important aspect of our expectations, is being driven, built, catalyzed, energized by thousands of startups around the country. And it is in this ecosystem of innovation that needs to be connected to the semiconductor space and vice versa, to shape the future of the semiconductor ecosystem for the world. And really, India is now, as the Honorable Prime Minister said recently in the World Economic Forum, India's ambition is to grow and become a significant trusted source of digital products, digital services, and digital talent for the world. Our goal is to address innovation and performance, the entire semiconductor ecosystem, from design to packaging to fabs, to span silicon and compound, and to create prime movers investments in each of these areas. And India's ability to do this will be, in a lot of ways, driven by our engagement in this conference and our conversations going forward. Before I end, the question that I'm posed when we pitch to these semiconductor majors or to anybody who's a participant in this ecosystem is, can India do this? And my answer, and I hope all of your answers at the end of these 3 days will be, yes, we can do it. Yes, we will do it. And it's a question of us working together, and to use a phrase that the Honorable Prime Minister says, Sabka Saath, Sabka Prayas. if we work together and cooperate together and work to this common vision, we can realize that goal. I'll end by saying this: we are living in exciting times. I surely believe it, and I hope all of you do, that Prime Minister Narendra Modi's government is determinedly ensuring that every opportunity in front of India is translated into real opportunities for India's youth and for India as a country. I hope today, with our conversations and over the next 2 days, we will contribute to that goal and the Prime Minister's vision. Thank you all again for being here. Thank you. Jai Hind.
Thank you, sir, for words of encouragement and also giving a new sense of confidence in the entire fraternity. Let's all once again thank Sri Rajiv Chandrasekhar ji for your address. Thank you very much, sir. Well, ladies and gentlemen, we are all now heading towards 3 back-to-back keynote addresses, 2 on the virtual mode and 1 in the physical mode. The first keynote address will be by Mr. Sanjay Mehrotra from Micron Technology. As we are all aware, he's the most prominent techno-business global leader in semiconductor memory technology. He co-founded SanDisk, Fortune 500 company, from a startup, leading Micron Technology since 2017 and guiding it to its glory. Well, before the keynote address of Mr. Sanjay Mehrotra unfolds, we'll get a brief introduction, a brief insight into what Micron Technology's vision is all about. So it will be followed by the keynote address. Let's have the video, please, first.
Newton's first law states that an object persists in a state of rest unless acted upon by another force. Nowhere is this more true than with our data. Oceans of insight lying dormant, still, unengaged. And when idleness is the enemy of possibility, we revolutionize, we rethink, we transform. Because today's data doesn't just reside, it lives.
It's a spark that makes you feel alive. Feel alive. Feel alive. It's a spark that makes you feel alive. Feel alive. Feel alive. It's a spark that makes you feel alive.
Micron is where data lives.
Namaste and good morning. Honorable Prime Minister Shri Narendra Modi ji, Shri Ashwini Vaishnav ji, Shri Rajiv Chandrasekhar ji, center and state government officials, colleagues from the industry, from academia, members of the press and students. It is an honor for me to deliver the keynote address today. Today's economy is unquestionably based on data, driven by the innovative technologies that make that data more accessible, more effective, and more useful. McKinsey projects that data-driven artificial intelligence technologies will add $13 trillion to the global economy by 2030. All that added value is driven by our ability to make better and faster decisions based on the information all around us. Data is the fuel of our global economy and touches nearly every aspect of our daily lives. That fact is driving a technology revolution, and semiconductors are at the center of it. Semiconductors are the brains of modern electronics, enabling advances across communications, computing, industrial, automation, healthcare, education, transportation, every sector that you can imagine. The semiconductor industry is projected to be a $1 trillion market by 2030. It is growing exponentially, and the data economy is the driving force. But let's talk about what is maximizing the value of that data. Memory and storage are now truly essential and can be found anywhere that data is stored or processed: smartphones, automobiles, personal computers, and data centers. Memory and storage technologies have become central to computing architectures and future innovation, meaning they are also critical to the world's core infrastructure. We have seen phenomenal revenue growth from the PC internet era through the shift to the smartphones and on to today's growing data economy. And we see memory and storage becoming more and more central to enabling transformational future innovation. The importance of memory and storage is clear when you look at trends in our industry. As the value of fast data access increases, DRAM and NAND revenue growth are outpacing the broader semiconductor industry. Customers are demanding platforms with higher densities of advanced memory and storage technology. While DRAM and NAND used to be about 10% of semiconductor industry revenues, they now represent 3 times as much. According to Gartner, in 2022, memory is forecasted to account for more than 30% of the $639 billion overall global semiconductor market. And memory and storage account for the majority of semiconductor wafer production as well. Nearly 60% of all silicon wafers produced globally today are for memory and storage. Data-driven applications are creating that growth. Secular drivers like pervasive and ultra-fast 5G networks and advanced artificial intelligence systems are expanding the use of memory and storage across the data center to the intelligent edge and on to billions of connected devices. Part of what makes this rapid growth possible are the dramatic advancements the semiconductor industry has driven in DRAM and NAND technologies. Over Micron's history, we have evolved DRAM from 64 kilobits to 64 gigabits. 1,000,000 times the data density increase in the same tiny package over just 4 decades. NAND has been on a similar journey, but in a slightly more compressed timeline. In NAND, we moved from 8 megabit parts to a die that can hold a terabit of data. We achieved this by moving to complex 3D designs, hundreds of layers deep, with the capability to differentiate 4 bits in each data cell. We made similar progress on cost efficiency. Consider these 2 charts. The development pace for memory and storage has been a turbocharged version of Moore's law, even if we are just considering the last 15 years. The advancements in DRAM have reduced the cost per gigabyte to a fraction of what it was in 2006. For NAND, the curve is even steeper, with a 99% reduction in cost per gigabyte. Those advances have required tremendous innovation at a fast pace. Innovation in performance, density, cost reduction that are opening up new, more diversified markets. Memory really is at the leading edge of semiconductor manufacturing. Data centers, intelligent edge networks, automotive, and industrial devices are all high-growth areas with tremendous demand. 2 of the most critical innovations fueling the data economy are AI and 5G networks. AI, the most disruptive workload class in the history of computing, fundamentally redefines the insights we can extract from data. The rise of AI has been fueled by the combination of massive amounts of data and massive amounts of computing resources, and the industry is rapidly advancing AI capabilities to provide new and greater value. While AI is disrupting the world's applications, 5G networks are unleashing data movement, embracing low latency and enhanced mobile bandwidth, and delivering the same cloud-based scale and capacity that is found in the world's data centers across the communications networks. Memory and storage's share of the server bill of materials already exceeds 40%, and that share gets even higher for servers optimized for AI workloads. This growth is supported by new heterogeneous computing architectures, the increase in data-intensive workloads, and the ongoing displacement of hard drives by SSDs. And the explosion of data is not limited to traditional applications. In fact, by 2025, 75% of data will be generated and processed outside of data centers. Data is being captured and processed closest to where it is needed in order to derive and act on insights in real time. Smartphones, automotive, industrial, and communications are driving some of the fastest annual growth rates in the industry. GSMA estimates that 5G applications will help bridge the rural and urban healthcare divide in India and create billions of dollars of socioeconomic benefit through applications such as telemedicine, precision medicine, and remote surgery. We see growth in 5G devices too. 5G phones today have 50% more memory and double the storage content compared to 4G phones, content that is used to drive increasingly complex applications. The third pillar of the future digital economy is autonomous. We already see semi-autonomous electric vehicles using memory content similar to a data center server. I like to call them data center on wheels. Electric vehicles are rapidly growing in popularity, and we see 100 new electric vehicle models launching worldwide in this calendar year alone. These new electric vehicles include advanced driver safety and in-vehicle infotainment features that have significantly higher memory and storage requirements. In fact, some of these level 3 autonomous electric vehicles have about $750 in memory and storage content, which is 15 times higher than the average vehicle. Imagine how autonomous vehicles, autonomous agriculture equipment, and autonomous IoT equipment will be able to help reduce traffic on India's roads, improve the crop yields of India's farms, and improve industrial productivity across all of India's factories. We expect memory demand in these applications will continue to increase as these advanced features evolve and proliferate. Over our 4+ decade history, Micron has grown into the world's 4th largest semiconductor company and is a global leader in memory and storage technologies. Our innovations have been at the heart of computing systems for more than 4 decades. Our company is driven by the innovation of our 44,000 people located in 17 countries around the world. Together, that team has amassed nearly 50,000 granted patents, which underpin our technology and reflect our deep commitment to developing solutions that shape the world's future. Our global footprint not only allows us to benefit from scale while streamlining processes and operations, but it also brings together some of the world's brightest talent to work on our most advanced memory technologies. That global team has been a tremendous asset as we move technology forward. Memory is now at the leading edge of semiconductor process and design, and Micron is leading the world in both DRAM and NAND memory. Innovating these new cell structures requires the brightest minds in the fields. Earlier this year, Micron introduced its industry-leading 1-alpha DRAM, the world's most advanced memory node. This advance in technology cuts across both our standard compute DRAM and low-power DRAM product lines. In low-power DRAM, or LP DRAM, used extensively in PCs and mobile devices, the 1-alpha node has enabled us to drop power consumption by 15% versus the prior generation and has delivered great performance efficiency in these power-sensitive applications. With 1-alpha node, we are also able to deliver 40% higher memory density versus our previous generation, a key to personal computing and data center customer application requirements. And in storage, Micron is the only company in the world with industry-leading 176-layer NAND technology in mass production. Advancements in new materials were a key factor to help us maintain and strengthen our ongoing leadership. Our scientists have modeled and tested nearly every element in the periodic table as we innovate new material processes. The leadership here is central to meeting customer demand across all our markets and has given Micron a multi-quarter lead in ramping products built on these technologies. Our leading processes play a role in increasing power efficiency in memory for smartphones and laptops, speeding data access in data center servers, and also providing high density and cost efficiency in solid-state drives for multiple markets. Product diversity is also driving memory complexity. No longer is the lion's share of memory industry revenue driven by a single generation of DRAM modules built for consumer PCs. Micron offers a diverse portfolio of memory and storage solutions to deliver optimal performance across all end markets, including PCs, servers, mobile phones, graphics devices, automobiles, networking, and industrial applications. Supporting all of these diverse end market products requires comprehensive expertise from silicon to end solutions and a large-scale fabrication and assembly and test manufacturing to enable all of these individual memory products. Our broad portfolio of solutions requires complex packaging and finishing that make assembly and test facilities instrumental to our production strategy. Given the multiple disruptions of the last several years, there has never been a greater premium on supply chain diversification. Micron has invested heavily in building a resilient supply chain for assembly and testing our products in multiple sites across Asia, which has enabled us to provide business continuity for our customers. The location and reliability of assembly and test is also critical in ensuring we can serve end customers through any supply chain disruption or obstacle. These sites have become a critical component in our value chain and manufacturing ecosystem. An excellent manufacturing network is an absolute requirement to compete in our industry. Micron manufactures more than 6 billion IC chips every year and turns those into more than 3 billion individual products. Micron is a real manufacturing powerhouse with world-class smart manufacturing techniques deployed across our operations to maximize the efficiency and quality of our production. Our industry also requires constant innovation with a sharp eye toward the future. Our advancements won't have the impact they should unless they are paired with a dedication to sustainability, supporting our communities around the globe and cultivating a diverse and inclusive culture for our worldwide team. Some of the ways we demonstrate our commitment to the global communities we are part of are through our people and our giving and sustainability programs. We are committed to improving our environmental and social performance in operations, sourcing, and across all our products. A critical component of Micron's sustainability strategy is a set of clear and bold aspirational goals that strengthen the link between environmental responsibility and business prosperity. We are focused on becoming a global semiconductor industry leader in emissions reductions, energy efficiency and renewable energy, water conservation, and waste reduction. In fact, earlier this month, we enrolled in Malaysia's Green Electricity Tariff Initiative, committing our sites there to source 100% renewable energy in 2022. Through the agreement, our sites will eliminate about 120,000 metric tons of carbon dioxide per year, the equivalent to removing 24,000 passenger vehicles from the road. Micron's sustainability efforts extend across our complex supply chain with over 9,000 suppliers in 42 countries. Over the past year, we have expanded our supply chain diversity and climate performance efforts while remaining among leading companies in our conformance with industry-wide conflict mineral efforts. Today, we see the opportunity for new semiconductor designs to solve problems that were unsolvable in the past. they remain a very exciting field to work in. And Micron's important work is done by teams that imagine and collaborate on new solutions all over the globe, including here in Bangalore. I'm very proud of what we have accomplished in India and the continued transformation that is happening here. We see growing opportunity in India, both as a region driving new design and innovation and also as a significant market. As India continues to advance its rapidly growing economy, the technologies I described earlier, 5G, artificial intelligence, edge networks, and autonomous, will play a transformative role. I'm confident this progress will bring about many new opportunities for Micron to partner with Indian technology companies and OEMs. India plays an important role connecting Micron's proud history to our future potential. Our sites here are a key part of our execution engine. Our world-class engineering, design, and delivery teams in Hyderabad and Bangalore will cross the 3,200 headcount milestone this quarter and will continue growing rapidly. In fact, over the last 3 years, we have probably achieved one of the fastest ramps for a semiconductor company on the subcontinent. We expect to have 5,000 team members at our sites here in the next 2 to 3 years. The quality of Indian engineering talent is remarkable, and Micron is investing in it. Our teams in Hyderabad and Bangalore are a key part of our global talent network and play an important role in our innovation engine in the years ahead. Our teams here developed an in-house controller for our flagship mobile storage devices, ramped leading-edge NAND into our 1 terabyte SSD for laptops, and led high-speed analog and mixed-signal IP for high-speed DRAM interfaces. Our India team is integral to advancing our vertical integration to develop differentiated solutions which are critical to enabling breakthrough customer innovation. I strongly believe that the best innovation comes from a team that is intelligent, tenacious, collaborative, and diverse. Finding a pool of talent that embodies these qualities can be difficult, but it is absolutely foundational to everything else we do. Our University Research Alliance here in India is at the vanguard of our efforts to identify, reach, and nurture talent early. Our efforts cover research collaborations, course curriculum design, scholarships for underrepresented groups, and internships in our labs. Micron has benefited immensely from the abundance of engineering talent here in India, and we are committed to giving back to expand and enhance the talent pool. I wish the India Semiconductor mission every success toward building a vibrant semiconductor ecosystem that would enable India's emergence as a global hub for semiconductor manufacturing, design, and technology development. A special thanks to Rajiv Ji for conceiving and curating the first SemiconIndia conference and bringing us all together to work towards achieving this shared vision. I'm grateful to the Ministry of Electronics officials, industry associations, and the SemiconIndia Steering Committee who have facilitated this remarkable confluence of global stakeholders, which I'm certain will catalyze the development of the semiconductor ecosystem here in India. Micron's vision is to transform how the world uses information to enrich life for all. These data platforms can be truly transformative to the human experience, providing better decision-making, more equal opportunities and access, and a safer, more efficient world. The entire technology ecosystem must work together to build systems that are capable of reaching this great future. I believe the potential ahead of us is nearly limitless. The best and brightest across our world continue to invent what didn't before seem possible, breaking barriers to create technology that will help to enrich all our lives. Our ability to better gather, understand, and make use of the data all around us will provide opportunities that were not available and sometimes were not even imaginable just a few years ago. Together, we can achieve this. and the best is truly yet to come. Thank you.
Thank you very much, Mr. Sanjay Mehrotra, for giving us a comprehensive overview of the semiconductor opportunities in the New World Order and steps needed to be taken to tap the same. We'll now have the next keynote address also on the virtual mode. The keynote address will be by Sri Randhir Thakur, President, Intel Foundry Services, Intel Corporation. He is leading Intel Foundry Services as an integral part of Intel's IDM 2.0 strategy, and he's an innovator and business leader with expertise in global manufacturing, research and development. Sri Randhir Thakur has joined us. Now it's all yours, Sri Randhir Thakur. It's over to you. Take it away. Dr. Randhir, kindly unmute yourself. We are trying to, yeah. Sorry for the inconvenience.
Hear me now?
Yeah, we are getting now. Go ahead.
Okay, great. Thank you. I would like to thank Honorable Prime Minister Modi ji, Honorable Minister Ashwini Vaishnav ji, Honorable Minister Rajiv Chandrasekhar ji for the opportunity to speak with you all today. I'm Randhir Thakur, President of Intel Foundry Services, and I have spent more than 30 years of my career in the exciting field of semiconductors. This is a significant moment as we gather to witness the launch of India's semiconductor strategy and policy. I'm honored to share this stage and screen with so many of my industry peers and colleagues who recognize the potential and the importance of this work to India's future. Today, I'm speaking to you from Silicon Valley, and my aspiration is that, as Honorable Minister Ashwini Vaishnav ji has said, that it is not too far in the future when we will be coming together to celebrate Silicon Himalayas. In today's digital world, a domestic semiconductor industry is critical to economic growth and security. It is also central to geopolitical dynamics. India today is a digital nation with much of the foundation in place to become a semiconductor nation. Intel has been a partner to India for over 30 years, and we are thrilled to be with you on this journey. Today, I would like to share our perspective on the powerful and remarkable commitment that India has made, the opportunity you have in front of you, and the critical steps needed to be successful as a semiconductor nation. Every aspect of human experience is becoming more digital, which is driving an age of sustained long-term demand for semiconductor. We see it all around us, from autonomous vehicles and artificial intelligence to cloud computing, pervasive, always-on connectivity enabled by 5G and beyond. We believe this will create greater than $1 trillion of opportunity. At the same time, the world needs more balanced and resilient supply chains to be successful. Every industry is now a digital industry, fueled by the reliable delivery of semiconductor chips. During the pandemic, we have seen the impact of supply disruptions. That has shown us how entire value chains and economies are so dependent on having a robust and globally secure supply chain. As our CEO, Pat Gelsinger, likes to say, semiconductors are the new oil. in this digital age. Semiconductor manufacturing will become more important than oil reserves in defining geopolitics in our digital future. Unlike oil reserves, where we do not choose the location, we can flourish and lead in semiconductor manufacturing at a place of our choosing. At Intel, we have focused on creating a globally diverse manufacturing footprint to meet the demands of the future. Today's concentration of semiconductor manufacturing in a few localized regions will not be sustainable in the long run. This has led global leaders to look to the policies and investments that will position their economies to succeed in the coming decades. I'm really excited that honorable government in its wisdom has approved a comprehensive program to catalyze India's semiconductor industry. Congratulations to all of you on this important step. You are demonstrating leadership and dedication, making rapid progress while much of the world determines their next steps on semiconductors. Your efforts to develop the semiconductor manufacturing ecosystem and insert public market capital info technology startups is exactly the flexibility and agility that is required to succeed in this industry. The collaborative approach shown in the creation of the policy and the advisory committee, as well as this very conference, is a testament to the partnership focus and open-mindedness that you are bringing to this cause. Reading the details of your mission, it is clear that the policy was thought through by industry experts and it has been met with immediate enthusiasm. Industry leaders have taken notice of this ambitious plan, as shown by the supportive audience and speakers here today, and the positive ecosystem response you have received. Never before has the semiconductor world seen a country coming together with such a compelling vision. Truly, the stars have aligned so well. The Honorable Prime Minister and his cabinet are so clear on the importance of this strategy. And I have to say, in speaking to all of them, they are very knowledgeable about the semiconductor field. Time is of essence. Given the rapidly evolving global political situation and India's significant domestic demand for semiconductors, this approach is positioning India well to move quickly and intentionally. And as the Honorable Prime Minister says, now is the time to invest in India, and it shows. Let us talk about India's journey. And I divide it in all these different stages. India has a long-standing track record of leadership in technology and engineering transformation, which has prepared it well to take this leadership role in the major digital inflection happening today. Honorable Prime Minister has spoken about India's history as a Vedic nation, saying, on one side we invented zero, while we also explored the idea of infinity, laying the foundation for our modern day computing. Post-independence, India progressively became an industrial nation. In the 90s, India successfully established itself as a software nation, harnessing young engineering talent to position the nation as a software, IT, and business process outsourcing hub to the world. This began India's successful history as a trusted supply chain partner, which continues till this day. In the last decade, India has led as a digital nation. India has the third largest startup ecosystem globally and one of the world's largest pools of technology and engineering talent. The scale of digital adoption is extraordinary, reaching mobile connections, internet users, and digital identities of over 1 billion people each. India is now positioned to become a semiconductor nation at this critical market inflection point. The capabilities that India has built in supply chain partnerships, innovation, entrepreneurship, and talent are the right tools for the next step. The world will look to India's leadership and contributions here, and it has so many times in the past. In this context, we see a world of opportunity for India moving forward. Looking at the semiconductor value chain, we see that India has a footprint today in several critical steps in IP, in design solutions and services, and in ODM and board and systems manufacturing. This is solid foundation on which to build. To become a semiconductor nation, India must capture a broader swath of semiconductor value chain. To do this, India can build on the strength of its ecosystem and expand its current offerings. This means moving beyond IP and design into additional areas of focus within semiconductor manufacturing, including wafer fabrication, package, and test. This is significant opportunity for India. Developing a comprehensive portfolio of products and solutions will enable India to drive economic growth and strengthen its internal resilience. Given the track record of developing digital industries, India is well positioned for success in building out this value chain. It will require a diverse set of players drawing upon India's thriving startup community and collaboration with global corporations. And ultimately, this will need to be at scale to address not only the domestic, but also the global market. Again, I congratulate the government for leading India on this important journey. This is a considerable growth opportunity, not only for the nation, but for all the ecosystem players. While India has made a strong start, becoming a semiconductor nation is a long road. And both Ashwini Vaishnavji and Rajiv Chandrasekharji have made it very clear that please not only tell what is good, but also what needs to improve so that we can move faster. As I mentioned, India will need to attract and support a diversity of domestic and multinational industry players to build out the semiconductor value chain. From my experience, let me share what the industry looks for when evaluating greenfield opportunities. We seek a combination of factors: technology partnership with industry leaders who bring expertise in the latest innovation, reliable infrastructure to support the high-performance manufacturing operations, as well as knowledge infrastructure policies like technology parks, access to the semiconductor supply chain for equipment and raw materials, highly skilled labor force to support design, assembly, and manufacturing capability, a regulatory environment that is conducive to business and investment, trade policies that encourage multinational companies to expand capabilities and enable global competitiveness. Some of these areas are stronger today, and some need to be tailored to serve a thriving semiconductor industry. Though it will take time, it is strategically important to consider these factors. At the current pace, and with the momentum created by ISM, I'm confident these challenges will be addressed swiftly. Now, I want to talk a little bit about India, about Intel in the India context. At Intel, we have been at the forefront of the semiconductor industry from the beginning. We have led it through multiple inflection points and technology transitions. We have seen the birth of the integrated circuit with the Intel trinity of Gordon Moore, Robert Noyce, and Andy Grove. Together, they paved the path towards PC, internet, server, cloud, and everything electronic we see today. India's own Vinod Dham, and as Minister Chandrasekharji rightfully pointed out, the father of Pentium, laid the foundation for Intel's revolutionary line of microprocessors. He made seminal contributions to to the semiconductor industry as the lead on Pentium processing. And our journey at Intel continues. Most recently, after Pat Gelsinger rejoined Intel, he launched the IDM 2.0 strategy. Intel Foundry Services is an integral part of the journey where we are providing world-class foundry services to meet the incredible global demand for semiconductor manufacturing. I'm privileged to lead this business and have been energized to see the support from our customers and industry partners. The urgent need for more semiconductor solutions only reinforces the importance of the work India is planning for this. Now let me talk about India specifically. Intel has a long-standing relationship for more than 30 years with India. Just to share with you some highlights, Intel founded one of the first at-scale design center in India in early 2000s. We have now grown to 28,000 employees in India. We have invested more than 7 billion in our sites across India, with campuses in Bengaluru, Hyderabad, and other places. Additionally, India is home to Intel's largest design center outside of the US. Intel India plays a strategic role, and the team has made significant contributions to our technology and product leadership, including cutting-edge work on AI, 5G, and autonomous driving. We collaborate with more than 70 startups across India through multiple programs engaging with industry, academia, and the government. In 2021, we launched the Plug-in Alliance with Sign IIT Bombay, a first-of-a-kind alliance in India promoting the Industry 4.0 transformation. Through another startup programs, we have supported Coconix, a unique company that manufactures IT products under the Make in India initiative. And we have worked together on social, educational, and environmental initiatives, such as our AI for All digital readiness program. Together, Intel and India are creating innovations to impact the life of every person on the planet. And that's Intel's mission. Going forward, Intel is committed to India for the growth of the semiconductor market. We have embraced the open IP ecosystem in India, including recently joining RISC-V International. A thriving open ecosystem is critical to support the entrepreneurship and startup culture that India will require to build out the semiconductor industry. We have already launched public-private partnerships to develop solutions using RISC-V with CDAC, DARVI, and India's outstanding IIT educational system. Our open culture of collaboration and innovation will catalyze the growth. We are working with multiple private sector companies to make Intel Foundry Services India's platform of choice, really the platform of choice. We are accelerating the growth of this robust and growing open ecosystem with a $1 billion innovation fund that is directed towards funding startups we can enable through Intel Foundry Services. The combination of open IP, open source software, our open foundry platform, and our ecosystem investments will exponentially accelerate the growth of semiconductors in India. We look forward to partnering with India on the journey to becoming a smart semiconductor nation. And in closing, today we have all come together to celebrate a decisive step the Honorable Prime Minister and his cabinet have taken. The India Semiconductor Mission is an admirable and important vision to build a vibrant semiconductor industry supported with a resilient supply chain, a robust ecosystem of partners, and homegrown IP. This is a critical step to protect India's Industry 4.0 journey, as well as its continued leadership on the global stage. India's journey to become semiconductor nation will enable self-reliance in the most critical industry of the 21st century. It will further strengthen the nation to become economically stronger Bharat, geopolitically resilient Bharat, and most importantly, Atmanirbhar Bharat. At one time in history, Charkha transformed our nation. Today, chips have the power to do the same under the leadership of Honorable Prime Minister Modi ji and his esteemed cabinet. Jai Hind, thank you.
Indeed, ladies and gentlemen, Semiconductor Bharat, Atmanirbhar Bharat. Thank you very much, Sri Randir Thakur, for your keynote address. After two virtual keynote addresses, ladies and gentlemen, we are all now set for a physical keynote address. We have Mr. Jim Keller, President and CTO of Tense Torrent, all set and raring to go. A dynamic technology leader in computer architecture, processor design, and AI/ML. Jim is currently the President and CTO of Tense Torrent. Before becoming a part of Tense Torrent, he was Senior Vice President of Silicon Engineering Group. So, ladies and gentlemen, let's give a round of applause and welcome Mr. Jim Keller.
All right. Yeah, I was invited to come talk at Semicon, and I didn't know that much about it, and I thought I might talk about AI and processor development, RISC-V, and then I saw the brochure, and it said I was going to do a talk about India leading chip design for the world. And so I threw out my old presentation, and and I started thinking about, what would I say? And a few people know me, and I'm opinionated, apparently, and Ashwini invited us to be blunt. And so I started thinking about that. And just for some background, I've been working with India teams for about 10 years. And it's good to be back. I haven't been here for 2 years. Jay is here. She worked with me at AMD. Some of my friends from Intel are here. And we did some great things, and I think for some reasons. And I just wanted to talk about some of those. Because to lead, you have to win. To win, you have to be great. And you can't just goof around and have a lot of seminars, because that's not going to do it. So I thought I'd hit 3 big points. But what drives our industry is Moore's Law, more transistors. More transistors means more complicated computers, faster computers, more applications, maybe bigger ones, maybe smaller ones, right? And it's been relentless. And it's been declared dead a lot. I've been hearing it was dead for 30 years. And at some point I thought, it can't always be dead in 5 years, right? Maybe they're just wrong. So I've assumed they're wrong, which has been useful. So I'm going to talk about 3 different things. Skills, setting goals, and these are goals to win, right? And then the attitude. I'll just have one slide at the end about like how do you have the right attitude to do the right thing. And whenever I give talks, I've been in India for about a week now. I talked at the IEEE Society in Bangalore. I give a talk to students at IISc. I talked to some industry leaders and some friends of mine. I was up in Hyderabad, and I gave a talk at Invicus, who's been a partner for Tense Torrent building chips, and they've done a great job. And each time I noticed the intensity that people want to learn. And I've talked to some professors, some people who do teaching both in... That was really cool. And we took some photos, and I have them sprinkled in here, shameless promotions for my talks. But what I really noticed when you talk about technology and how to do technology, people really lean forward. And I was talking with one of the professors about this idea of, like, universities often teach too much theoretical stuff. And then training institutes focus on CAD tools and tools of the day. But what makes a great engineer is more than that. And we came up with the 2x2 matrix because I'm an engineer. Like, there are deep things and there are practical things. And then there's real knowledge, but then there's problems, right? So the classic big university teaches deep knowledge, math, chemistry, physics. And by the way, they're really important to be a great engineer. Training institutes and engineering training programs, you start with electrical engineering and computer science, but then you go to coding boot camps, you go to CAD tool training, right? But if you over-index on that in a changing business, the students won't have that deep knowledge to continue. One of the most important things students can do is be in a lab, try to build something, and it doesn't work, and then they have to figure out what to do and debug it. This is really important. And then when that solution is bigger than the local problem, we call that invention. We've been inventing new computers for years. I had the unique opportunity and good fortune to talk to Swamiji yesterday. And he told me a lot of things, but I thought I'd share two of them. He said, please make the world a better place by bringing people together. Maybe tear up a little bit. It's a beautiful thing. I hope we can do that. But the other, he said, be like a bumblebee and go to each flower and take a little bit. So when we teach our students and our engineers, each area, make sure we focus on that. I think this is really important. One of the things we do when we're great engineers is we solve the problem of complexity, right? You don't jump to the mountain in one jump, you have to walk up. You don't learn to be a great engineer by taking the hardest course, you work your way there. And I realized one of the things is, I've solved some hard problems, I work with teams to solve hard problems. You have to reduce the complexity to the point where the engineers can get the work done. And complexity means there's too much crap in one place that they can't solve, and then they struggle. And the architecture of solving from complexity, I saw this network stack in the 80s, and it blew my mind. Because instead of saying, here's TCP/IP as this big thing, they turned it into multiple layers, divided and conquered that, so you could innovate at each separate layer. And that changed the world, right? And whenever we properly apply this lens, and I tell students and young engineers, if your problem's too hard, is this abstraction layer done properly? Do you know which part you're in? Does your team and leadership know what's going on? Because this is a really hard problem. Most projects failed because they haven't refactored this properly and solved it. And you can't just solve it by putting more people on it. All right, I'm going to talk a little bit about goals. So, preparing for this talk, I talked to a bunch of people, and I heard that India wants to be best in class. They want to be lowest cost. They want to have local control and supply chain. They want to train and own and have world-class engineers. These are 4 different things. And if you try to do all of them, you'll fail. Now, maybe this company is world-class, maybe this one's low cost, maybe there's a way to get supply chain. Supply chain is really complicated. Intel, big companies tend to think of world-class technology as leading node, but most of our products don't need that. I was telling a congressman in the US, they want to invest in high-end technology. And I said, what, so we can all have a new iPhone? What about the technology chain that lets us build refrigerators and air conditioners, right? That generates jobs, that generates technology independence. It's a complicated thing. And you have to pick which one you're doing. And maybe, I'm looking at the ministers here. By the way, thanks for inviting me. Make sure you're looking at each one of those different areas. And then the next one is, make sure you know where you're at. Right? This is the iron law of the S-curve of the world. You start in searching mode, trying to figure out what to do. Somebody discovers something like maybe the internet, right? And then there's a ramp. And then that technology matures, and then it inevitably fails. There are no rotary phone engineers anymore. Right? The world changes. If you're going to lead, you need to lead from the pathfinding or the ramp phase. The mature environment, they've already squeezed the nickels out of it. Right? So if you're going to lead and do something new. Now, there's a new way to do something lower cost that we think is mature. Innovation shows up everywhere. But be clear where you're investing. don't invest on the end of the curve. Steve Jobs one time said, this curve is real. To get to the next level, you have to start the next curve. And when you start the next curve, it's actually worse off than the optimized mature business. But from there, you can go ahead again. And we do this in CPU design. You tweak a CPU for 10 years, there's nowhere to go. You make a new one, it's actually worse. But the new one has the opportunity to grow. So I've been working on computers for 40 years. And I knew Gordon Bell, who was the CTO of Digital, and he was a great guy. We also defined Bell's law. He said every 10 years, we have enough transistors to build a new kind of computer. Mainframe, mini computer workstations, PCs, mobile. It's been a fascinating journey, and I worked on mini computers, workstations, PCs, and mobile. And now I'm working on AI. And that keeps fostering new innovations. And what's happening today is there's a new kind of computer coming along we call AI. But there's also a revolution with RISC-V, which is a new computer architecture which gives us a chance to go do new things and not work off a mature base. And it took me a little while. I was thinking about this. All these computers essentially run C programs, and Zen 3 is a great example, right? Mainframes ran assembly in C. So did mini computers. It's kind of wild. I personally spent 40 years making C programs run faster. Sometimes I don't know how I'm going to feel about that in a few years. But that took us from non-pipeline to pipeline to superscalar to out-of-order computers. And each one of these innovations changed what kind of problems we can solve. I want to talk a little bit about RISC-V. And I realize I have your picture right here in my slide. Yay. I think that was from a tweet, must be today. Unless you change your shirts as often as I do. By the way, I was told that this is a formal event, people would be wearing suits, and I got a little nudge, so I went out and bought a new t-shirt. And I think it looks great, but yeah, that's what I'll do for a country as great as India. So RISC-V is a beautiful thing. It's a new computer architecture. It's a great definition. x86 and ARM are slow to change. We're building an AI processor. We asked the guys at ARM, great guys, if they could add some new floating point data types for us, and they said no. They don't see the market need. And I thought, I'm the market need. I just asked you. With open source, you can add things. I know David Patterson and Crystal pretty well. They did this out of passion so students could have something they could go change and innovate, and I think they succeeded past my wildest dreams. And I think change in the next 10 years is going to accelerate, and you want a platform where you can do that. And then these companies here, Sci-Fi, Revos, Tenstorrent, Calico, Etana, they're actually all in India already. And the India government has said they're going to go support this. So this is a fantastic thing. We're designing a new from-scratch processor. We just opened up an office in Bangalore. We got our incorporation final yesterday. So Tenstorrent India Limited is a real thing. Really excited about that. And I've been thinking about this layered abstraction stack, applications, architecture, reference model, performance model, microarchitecture, verification, implementation. This is a hard-won understanding about how to build processors. And with RISC-V and our new team, we're going to go really take a new shot at this to build a better processor. And this is the first processor we're building. We've already hired 15 people here. And we did a little check. It's from 8 different companies, some US-based companies, but some India-based companies. So we think we're going to have a really diverse team, and there's going to be an opportunity to do some great things. The innovations happening in RISC-V are going to be partly at the implementation level. So our team, we're going to build a machine with provable interfaces, really scalable definitions. The modern CAD tool suite lets us build a processor, not just optimized for one thing, but lots of flexibility. We already added new data types for AI, which is going to make performance better. And then we're going to build AI processors and CPUs together in the same silicon where they can talk. And there's 2 papers recently, one from Microsoft, one from Google, which talked about how AI and general purpose computing talk together. This is really exciting, and I think we're going to learn a lot on this. The other thing Moore's Law does for us is unlocks the ability to build the next computer, right? When you had a few transistors, you couldn't build even a pipeline computer. But as we got more transistors, the number of transistors per processor goes up. The first machine I worked on was a VAX 800. It had about 100,000 transistors in it. Modern CPUs, 100 million is a common number. So we went pipeline out of order, GPU shaders where you could run a program on every pixel. And then my multi-core processors, when I first proposed K8 at AMD, we're going to do 2 and 4 processors on a die. People thought that was crazy. They're so big. And would you rather have a bigger processor? Now we think 64 is a plausible number. We're just hitting the number of transistors to unlock AI. Jeff Dean gave a talk last year at DAC that was brilliant, and he said when they first got AI algorithms to work, they thought if they could get from 1 to 64 processors, they could really run it faster. And then they realized it was running 1,000,000 times too slow. 1,000,000 times too slow. So modern big language models run on thousands of GPUs for a month to train it. They're still 1,000,000 times too slow, but they're now fast enough to actually do that, and the innovation space can be really big. We made this slide when we raised money, and I've told people, quoting Andre Garpathy, when you're raising money is a really good idea. So any startup people here, follow him, quote him. But what he said, this is really great. Software 1.0 is when people write programs. They write essentially the way you think. Do this, then do this. If this, do that, right? And software 2.0 is actually take data and information to train a network to make an association. The programs are very, very different. And then I'm not really an AI person. You know, I'm a CTO of an AI company, and for the last year I've been reading a couple papers a week. And I noticed they all write in high-level math, which I vaguely understand from 40 years ago. But the good news is the AI researchers are pushing the envelope of the math to describe the relationships between data. But that translates into simple equations that computer guys like myself know how to speed up. A equal B times C plus D. I'm not kidding you. Almost all the hard math turns into something like that. This math has established the understanding about what the data is doing, but the AI programs themselves are actually kind of small. Hundreds of lines of codes to do a model that runs in thousands of GPUs for a month. The programs make a graph, and then our job as AI companies to translate that graph. So we did the same sequence of events, which is take the architecture stack, and then we translated that into a complicated software stack. So PyTorch and TensorFlow are open source languages for AI. TVM is an intermediate representation which we use. Then we generated something that expands the graph, puts in AutoGrad, lowers the graph, and then finally places that on a large array of processors. And our innovation is you can write the graphs you want, and we can run that automatically. And then we paired that up with simulators so we can simulate at each level and understand it. And here's an example of what graphs mean. So AI is built on a small number of primitives, but when the programmers write the code, there's a huge number of different graphs, and this turns it into a really hard problem. Our founder Luigi said when he started working on it, he knew it was hard, but then we found out it was way harder than that, because the combinational complexity from a small number of operators and a small number of graph operations turns into a huge variety of code. The way our computer works is you write code on the left. That's part of BERT, which is a popular language model. We translate that into a graph, and then we lower that into multiple processors, and then we lay that out on large numbers of AI processors. Our chips have about, shameless plug for Tenstorrent, 100 processors or so in the first generation. We can hook up thousands of those together. So this is an amazing thing. One program through a compiler to go engage 1,000 processors. We're building this today. The first 2 generations is a partnership with a company called Invicus. We designed the AI hardware. They did the back end. Their execution was flawless. This is a beautiful thing in the modern age. Our chips powered up and ran the first time. Right. We've integrated in RISC-V processors. We're starting to use AI to build AI, and there's a picture of our CPU team that we just started hiring in Bangalore. It's really exciting what's going to happen next. Here's a picture of some computers. It's kind of wild with all this change underneath. We're building a 4U server with 8 PCI Express slots, 2 chips on each one. That's the first version. The second version on the left is an AI data center with 2,000 processors in it. We built the first one in Austin. We're now pursuing a plan to try to build the next one here in Bangalore. We started hiring open source software people, open stack software people. Some of them are right here in Bangalore. So this is going to be the next really big step for us. I just want to circle back to the other component of winning. You have to own the goal. One of the big transformations I did when I led teams here is don't treat the resources as resources. Figure out how to give the right size project to the team with local ownership. And what I love working in India is the skills are there, the attitude is there. They really love the ownership and they'll kill themselves for it. And the intensity is super great. Next one is the goal is great products, not huge teams. I've listened with some concern to some of my friends here about the teams growing really fast, and they're doing 6 different things. More people should turn into more teams that are great. Right? And there's so many things to make better. Like our modern CAD tools are really good. I think there's another 10x. Right? And we start to use AI for CAD tools. It's going to change things. And then all the leaders have to think, this world is changing really fast. How do we set up to succeed so that our engineers get the right training, they get the right opportunities, and they get the right ownership? And I saw the trains are starting to run in Bangalore. I've been watching those being built for 10 years. It's actually affecting our decision about where to locate our office because I want that team to be able to get to work quickly, in a clean, safe way. All right. India has really great people. I used to hear, great people, but we don't have the leadership, and that's over. There's plenty of great leadership here. Right? You have the experience to lead. The skill requirements are going to be changing really fast. Look at everybody, I just ask you to look at your teams. Make sure it's not all 1,000 people turning the crank on the old design doing somebody else's stuff. That will not get you to a leadership position. Really have to think about that hard. And then leadership requires working in new areas. RISC-V is going to be really big. It's going to innovate faster than any other architecture because it's open. That's what happens with software all the time. That's what happened with AI software. Researchers do new models, they publish it, and everybody does it. This is going to be a really big change. And AI itself is a fundamentally different kind of computing than general purpose processors. I worked at Apple, and I didn't work for Steve Jobs. I worked for a guy who talked to him every day. We always knew what Steve thought, very fast. He was very direct. And that helped me understand what directness means. Sometimes it's hard, but being direct and winning is so much better than beating around the bush and losing. He said, why screw up 2 things when you can only get 1 thing right? It's a beautiful thing. And then focus on doing the best thing you can. And once you know what that is, only do that. I had a lot of fun this week talking to students. The intensity of wanting to do and know is super great. So I think there is a real opportunity for India to lead. And thank you. Yeah. So I didn't know if we'd negotiated Q&A. Is there any questions anybody wants to ask while we're...
Yeah, since we have some time, We can take a couple of questions, but then sincere request to all of you to kindly ask the questions straight away without any preludes, please. The mic will come to you and you can ask your question. You can just raise your hand, the mic will come to you. Yeah. Ilbani.
Right.
Yes, sir, the mic is coming to you.
With me, what has been the influence of meeting with Swamiji and, how has that inspired you?
Well, the question is, I just met him yesterday. It was a unique opportunity. And as we were leaving, somebody introduced me as Jim, the computer architect. And he said, "You're making things faster. That's very good." And then he talked to me for 30 or 40 minutes. I mostly listened. I'm still processing. I told him I would mention the bumblebee story, because it's the perfect story about how do you take a little from each place and then make the best contribution, which I think is really great. And bringing everybody together with technology, like we need to do that to make the world safe. I'm in India partly because I think it's really great when we have great people everywhere working together to know each other. Like one time I did a flight from London to South Korea, and I flew over the Soviet Union and China, the two countries I was terrified of as a little kid. And it was like changed the world. And I'd heard so much about India and what was going on when I first came here. It was so heartwarming to meet real people and work with them and then understand them, good and bad, and then make a contribution. I think that's really important. Is there another question? There we go.
Thanks for the great techno innovation, technical presentation also. So one of the questions you mentioned that one of the potential areas for India to focus would be RISC-V. Of course, India has great IT talent or coding talent, design talent. So it's easy to merge those two and start a foundation, but it goes beyond that. It says making products out of it, then possibly a manufacturing setup, and also making commercializing those products. So what do you think are the biggest gaps India has to fill, the talents that doesn't exist today in the next, say, 5 to 10 years in RISC-V?
Yes, so the question is, are there gaps in the technology to build like the next generation CPU ecosystem? And I actually think there's not very many gaps. It's really the determination to do it, right? You say, this is a technology where people here can innovate and do new things, right? And then what happens with that kind of platform, it finds its way into all kinds of new products. And then those new products go impact the next generation design. And it goes from server room to mobile right now is kind of locked up with a small number of players. If you want to do a new open mobile platform, you have to go build it on a new technology base, right? And then the other thing, and this is a secret, but I'll tell you guys because I heard there's 5,000 people online, but AI is going to start to write code. That code is going to be much more complicated than the current code people write. That's going to then impact how we build general purpose processors. And the people who are involved in using AI to build computers, to write code, and then build that are going to win. And the talk here today was about how to lead. And to lead, you have to win. So I think it's a real opportunity. The skills and talents are here.
Hi, Jim. So you talked about that we have been working for 40 years in making C program run faster, and that translates to von Neumann typical architecture, right? So now in your new venture, you are using both traditional and AI, right? So how the AI ML silicon has opened the new vistas for new architecture, because we can now break out of the von Neumann and basically have multiple different architectures, whether it's a systolic, whether it's a basically multiprocessor, in-memory computing. So how do you see the whole architecture space open up because of the AI ML?
Yeah, so how will AI change computer architecture? So there's going to be, we're in the experimentation phase. There's 50 AI startups, right? When GPUs first came out, there was 50 GPUs, only a few won. But actually, many startups made valuable contributions. And some of those were acquired or their ideas were copied. Like Raj is here, he worked at S3 and then ATI. Like you see the startups do the exploration, and then there's a consolidation phase, right? And a maturity phase. Network processing the same way, networking the same way. Right? This has happened many times. AI, people say, oh, there's so many startups, isn't that bad? No, that's how we go explore the space. Now, the other interesting thing is processors today do what you tell them to, and we treat AI as an accelerator. Now, imagine the human brain. You have a motor cortex, a sensory cortex, right, and a cerebral cortex, right? When animals were simple, you ran on what to do, what do you want, where to go, right? And we started building a cerebral cortex, evolution, or somebody did, right, which actually is an abstract planning system. And at some point, that system took over, at least for most people. Right? So today, right, it's true. Most people, not everybody figures that out, right? Today, AI is an accelerator to a big computing infrastructure. The future, that computing infrastructure will be in service to the AI programs that we use to run our world. And that transformation is already starting. Read the Pathways papers, read the Singularity paper. And the computers we built for that are very different from a server with an attached accelerator. And when you see that kind of transformation that big, then you say, let's make sure we're doing lots of experiments and projects on the new stuff, not 52 little derivative projects on the old stuff, which again is what I came here to talk about. One last question, and then...
Yeah, the next question is, thank you, Jim. So we see that the RISC-V is rapidly shaping the world right now. It's actually revolutionizing the semiconductor industry very rapidly. What do you think are the succeeding factors, and how do you compare it with ARM?
Yeah, well, I told the one story already. I love my friends at ARM. I asked them for a change, and they said, no, we don't see the need. Well, who am I? I thought I had a need, right? The students can do it. You can download from a number of different, there's the Shakti core, Boom core, Rocket core. They're pretty good. The students can then go do experiments. My team supports the open source RISC-V reference model. We added tracing capability, and we're going to publish some new extensions so people can use that and play with it. More people doing it opens up innovation. And then, this is an interesting thing, the speed is really important. If you want to go faster than somebody else, if you want to beat them, you have to move fast. And many experiments actually accelerate speed. It's not centralized, it'll be a little messy. That's right up India's alley. So it'll be great. Okay. Thank you very much, everybody.
Thank you very much, Mr. Jim. We'll now take a break, and now a little bit of opportunity for all of us to go through the stalls. So feel free. So we'll have some time to, if you have any queries, do not forget to visit the stalls, and thereafter have lunch and do come back by 2 p.m. We will be restarting the session in the afternoon 2 p.m. So we'll have about 10-15 minutes now to go around the stalls. Hope you enjoyed the sessions in the morning. Namaskara, and all of you take care. Have a great lunch.
kills check. Okay na? Audio clear?
Sam, for agreeing to be part of Semicon.
allow me to filter this audio. Sir, am I audible, sir?
such as AI, 5G and 6G, edge computing, autonomous systems, and space exploration. We are experiencing the fastest tech transformation in modern history. As the creators of the technology the world builds on, Intel is innovating faster than ever to solve the world's most significant technology challenges and put that value in the systems, software, and ecosystem solutions you trust every day. Thousands of companies take a faster path to AI at scale using their flexible, Intel-based technology. Our leadership in silicon-based security and confidential computing continues to help you share data with reduced risk. Groundbreaking process and packaging technologies let us build entirely new ways to compute and leaps forward in user experiences and capabilities. And now, we can offer that technology to the world through our foundry. Decades of work in open source software continues with our ongoing initiative to maximize code reuse across any hardware, no matter which company builds it. And we're collaborating with industry and government to move the world to a low-carbon economy. Every day, our world-class architects and engineers do something wonderful. So you can too.
Smart everything transforms product innovation. Software leads the way for differentiation. Speed and intelligence of chips make it possible. The convergence of software and hardware design is the opportunity to rethink our aspirations and conquer our challenges with solutions that unlock a smart future and deliver disruptive innovation to catalyze your ambition. Shatter the impossibility barrier and fuel a new era.
Center for Materials for Electronics Technology, CMET, has been set up as a registered scientific society in March 1990 under Ministry of Electronics and Information Technology. CMET Hyderabad is engaged in ultra-purification of materials and developed 99.99999% pure metals such as tellurium, cadmium, gallium, germanium and zinc, meeting the requirements of strategic sector. CMET has another feather to its cap. The center established a facility for the preparation of hafnium metal sponge, a rare metal closely resembling zirconium for space applications.
The unique pattern of innovations in the semiconductor industry continues to elude the perception of Moore's law slowing down, challenging the status quo. RISC-V instruction set architecture is not only witnessing a quantum leap and unprecedented levels of processor innovation owing to its free and open nature, but also pushing the Moore's law beyond its limits. Now, when the Union Cabinet has approved the SemiconIndia program with an outlay of rupees 76,000 crores to create a vibrant semiconductor.
ಬರ್ತೀನಿ ಅಂತ ಹೇಳಿದ್ದಾರೆ. ಇಲ್ಲ ಅಮೌಂಟ್ I would request all of you to kindly take your seats, please. Hope you all enjoyed your lunch. And we are all set for the post-lunch session to unfold. So I would request all of you to kindly take your seats, please.
आप कर देंगे इंट्रोड्यूस?
लेकिन अभी तो कीनोट है।
अभी की नोट है इसके बाद में,
हाँ,
है ना? ठीक है, और इनका भी आपके पास आ ही गया होगा, अजीत मनोचा का इनके पास।
हाँ, एक मिनट।
ठीक है, आई थिंक वी आर गुड टू गो। अभी कुछ नहीं, बाद में इसके मेन उसके बाद
In the interest of time and hopefully friends will join in, we are all set for the first session in the afternoon, India's Fab Show push for a million chips for billions. We have with us Shri Ajit Manocha, the President CEO of SEMI. And ladies and gentlemen, has got more than 4 decades of sterling career in the semiconductor industry and 5+ years on the US President's committees. Has the rare distinction of being inducted into the Hall of Fame twice. So let's give a round of applause for Mr. Ajit Manocha. I would request Mr. Ajit to kindly come over, research scientist at the legendary Bell Laboratories. So hearty welcome to you, sir. Hope you had your lunch. Yeah. Okay. So in the interest of time, let me not be there between Sri Ajit and you and the audience. It's straight away over to you to take us through this all-important keynote, the first session in the post-lunch.
Thank you. And good afternoon. I hope you all had a great lunch and still awake. First of all, the title says India's fabulous push for million chips. I did not change it. I think it should be trillions of chips, not million chips. So I think there is a typo here, but doesn't matter. So first of all, SEMI. SEMI is an industry association with 2,600 companies worldwide. And we have the founding members who are equipment and material companies, but subsequently we have the entire ecosystem from EDA to equipment to materials to fabless to foundries to system houses and application housings. So for example, some of the automotive companies have recently joined SEMI, Google, Facebook, Apple, they're also member of SEMI. So basically we connect the entire supply chain. So what I like to do is cover very briefly about SEMI so that you get a good flavor of what SEMI is all about. But the most important part of my message will be how SEMI can really follow up on the advice or the request that Mr. Rajiv Chandrasekhar made this morning. Okay, we have done everything. We have the policy, we have the mission. Now, can do, will do. Can do, will require a good sense of collaboration and cooperation. Now, last week or Saturday, we had a session with Mr. Rajiv Chandrasekhar and Vinod Dham and Amitesh Sinha together. And he made a point. The semiconductor industry has been in existence for almost 60 or 70 years. Now, India has to start from somewhere. The 60, 70 years of experience that the US has, the Western world has, the TSMC, the likes of TSMC have, the Samsung have. Now, how do we get India on the same page in next 60 weeks or months, but definitely not 60 years? So that's really the way I'm thinking, that how SEMI can really come and play a role and support India's ecosystem. And then finally, I will have some recommendations for success. So just to give SEMI background, we started 50 years ago. The visionaries at that time felt, this industry requires a lot of nasty materials, silane, phosphine, diboron, all those toxic gases. If every company starts doing its own research, it will take a lot of cost, a lot of efforts, and will never be safe. So let's form an association which will connect all the people together and solve fundamental problems about safety, environmental health, and so on. Also, set the standards so that likes of Applied and Lam and KLA, they don't make unique and niche machines, so that there should be more competition among the equipment makers and material makers. That way we will have more cost reduction and so on. So that's the standards piece came. So SEMI became standard setting organization. We have more than 1,000 standards in place. And thought leadership. Because this was such a new industry, there was a lot of vision, a lot of ideas. People were not sure, how do we go to the next step? So the idea was that bring the thought leaders together. So this was interesting. 50 years ago when SEMI started, the first conference was Semicon West. Semicon West means the western part of California. In San Francisco, actually started in San Mateo or San Jose, in that area. So Semicon started. Now this one, SemiconIndia, it has not been SEMI's, you can say, trademark yet, but hopefully we'll make it SemiconIndia with SEMI's trademark or SEMI's umbrella on top of it. So Mr. Sinha, I'm committing to you that I'll make it happen with you. So there were only less than 10 members 50 years ago. So today, with more than 2,500 members, and SEMI is much broader, much bigger. Basically, what I'm trying to show here is that SEMI has made numerous partners of ecosystem, basically expanded ecosystem. You see the names like TSMC, IMEC, Fraunhofer, Leti, ITRI, these names you heard this morning. They're all members of SEMI. Whenever we have a Semicon event, every single entity is there. Basically, the entire ecosystem is under one roof. So when folks come to meet, they don't have to really go place to place. They meet all ecosystem at one place. And that's how SEMI will bring ecosystem to India and will put ecosystem on a fast track. So again, a lot of messages here. I can say that in Semicon, we totally in a year, we connect about 1.3 million people, basically industry executives. And most of the Semicons, there is a who is who of the industry is there. The next one is Semicon West in San Francisco, July 12 to 14. And again, the who is who of the Silicon Valley and the industry will be in San Francisco. And the SEMI also is focused on the big picture topics, the barriers which are really hurting the industry. And the last column suggests holistic workforce development, global advocacy, and sustainability. I'm not going to spend much time on that, but give you a flavor of that and come to the key point. I think you saw this slide probably from Randhir this morning, similar slide, the ecosystem of semiconductor industry. So from substrate materials to equipment to IP design all the way to applications. And underneath you see the number of initiatives that SEMI has. And actually the next slide even shows a better picture. This slide shows the SEMI's family, SEMI's ecosystem. So these are the 2,600 companies plus many more companies who are part of SEMI's ecosystem. And on the periphery, you see the 4 big initiatives called Smart Mobility, Smart MedTech, Smart Manufacturing, and Smart Data. You heard a lot about data from Sanjay Mehrotra this morning, so I'm not going to spend any more time on that, but that's becoming a key going forward. What SEMI does, we have communities on each of these initiatives, and they meet on a regular basis. Hundreds of people we meet, and what we're trying to do via think tanks, creating intellectual blueprint 2030 or 2040. Basically, we're saying how the future of computing will look like, for example, quantum computing. What quantum computing will be in 2030 or 2040. So the think tank has hundreds of people in that. They're all best of the best brains, and we're creating this kind of blueprint which can be very handy for India to follow that instead of starting all over from the ground zero. And Industry 4.0 is right now everybody is talking about. SEMI is thinking about Industry 5.0. So the Smart Manufacturing Initiative, all the best of the best brains, is a global initiative. It took 100 years to go from Industry 1.0 to 2.0, 90-some years from 2 to 3. It took only 44 years to go from 3 to 4. And that's because of semiconductors. Because we enabled 3 to 4 with IoT, with AI, with 5G, and so on. Now going from 4G to from Industry 4.0 to 5 dot, there will be 6G, 7G, cryptocurrencies, quantum computing, all that will actually enable. And SEMI has really a very complete coverage on these topics in a very structured way. And of course, I mentioned here the common growth denominators are AI and IoT. Actually, AI and IoT, and along with image sensors, you can do wonders. And that's how our lives are changing. And the number of innovations, number of disruptions are just going through the roof. And this morning we talked about growth. It took 60 years to be, our industry ended up at $550 billion revenue last year, IC revenue. 60 years. In next 10 years, it's going to be $1.3 trillion. So whether it's 10 years or 12 years or 15 years max, it won't be 50 years. It's going to happen. It's happening because of the number of disruptions. I've been in this industry 40 years. These are real gray hair. I don't dye them gray anymore. And now I wish that I was starting this industry today instead of 40 years ago. Because the excitement in this industry is unprecedented. It's really exceptional. So this industry and the growth is underpinned by number of analysts, number of research firms. Memory is going to grow in next 10 years by factor of 3x from where we are today. And the non-memory will grow by factor of 2.5x from where we are today. It's going to happen. So it's going to be across the board. It's going to be the mature technologies, the legacy technologies, the specialty technologies, everywhere the growth. This morning, a few minutes ago, we were having a press conference. Somebody was asking for the advanced fabs. You need advanced fabs, and you need the specialty fabs, and you need the legacy fabs as well. You just don't need one fab. You need multiple fabs in India because the opportunities are there everywhere. So growth is there, but it's up to us. Can we capture this growth or not? There are man-made issues, and then there are God-made issues or nature-made issues. Now, first of all, talent shortage. These are kind of mixed bag. Why talent shortage is a problem? Industry is going factor of 2, but the STEM population is going down by factor of 2. In the Western world, the young kids do not want to do STEM education. The enrollment in STEM schools has gone down from 20%, some number, to 10% in last 20 years in Europe as well as US. In Asian countries, when we started this population control here, so hum do hamare do, right? Now the average number of children to couple is 1.3, and it used to be more than 2 20 years ago. So overall STEM population is going down. So this is a real serious challenge. We will not get a $1 trillion growth. We will not capture that unless we solve this problem. So what SEMI did, SEMI started a very comprehensive program. Again, I'm not going through any details. We're addressing these problems at the foundation level, at the elementary schools. We're working with the government also to have government play a role. Maybe they can incentivize parents to say we can get free college education, free admission to IIT or something if you go to STEM education at your entry level. And some kind of incentives to the schools in the US. If you increase the enrollment of STEM education, you'll get more support from the government, something like that. Then we have programs at high school level, university levels, comprehensive programs to basically inspire students about this industry. We bring students, as part of the High Tech U program, bring students to the industry campus, and we show them how we do magic. And we also do some soft skill development, ask them to make a speech, or do a mock interviews. And they get so inspired by 3 days in the campus, and then they think, I want to be part of this industry. So we're trying a lot of things. There's a program, certifications, as well as there's a veterans in US especially. 250,000 veterans are released every year. We're trying to recertify them for the semiconductor education. So again, comprehensive programs. what SEMI will do, work with the Indian academia to have these programs so that students or the kids are industry ready when they graduate. So we recently announced a partnership in US called ASA, American Semiconductor Academy, which is 50 some universities and community colleges with semiconductor curricula. Basically, we're taking that curricula and bringing the industry perspective so that the curricula is very ready for the industry. Now, I spoke with Professor Rajendra Singh at IIT. We should maybe form ISA, India Semiconductor Academy. I'm replicating same thing in Japan, Korea, Taiwan. So basically, we're going to have a problem around the world solving this problem. But we just announced a partnership with VLSI Society and a couple of other institutes which are funded by MITI that will together work with our program and bring this talent enhancement to life here. You heard several times this morning about geopolitical issues. Semiconductor industry has been well-greased engine until 2017. The last time when we had problem with our supply chain was in 80s, late 80s, US-Japan memory dumping issues. Some of you may know it. And that created a big problem. So SEMI got involved. We advised both the governments, please work together and do not create a mess which will hurt our industry. Then 2017, we started the US-China trade issues, and that has really disrupted the supply chain drastically. All the tariffs on the imports from China, so a lot of US companies started diversifying their supply chain, and the big winners were Malaysia and Vietnam. Somehow, India did not play a big role there. Okay, so be it, water under the bridge. But these geopolitical issues will continue to happen. These are, I call, man-made issues, because the egos of the politics and politicians will always be there. The history always comes back. Japan-Korea trade issues happened in 2019. SEMI got involved. We advised METI how to handle the problem, and we advised MOTI with the counterpart of METI in Korea that do not retaliate, and we solve the crisis. So SEMI gets involved with we don't actually take sides of politician or politics. We only focus on policies. And that's what we do. We get the industry together, take the industry voice for the region, for the world, and use that industry message to advise the policymakers how to solve the geopolitical issues. So we focus on 4 T's, tax, technology, trade, and talent. Talent is mostly for immigration. Right now, the US immigration policies are totally screwed up. Anybody who comes to US gets an education, master's, PhD degrees, and then we tell that graduate students to go home and go serve your own country. So it's hurting US. So these are big issues, and SEMI is playing a very active role. Now, those kind of experience that we have, we can also bring it together here in India, because this is not just only India specific, this is interconnected with the rest of the world. This one topic is yet another one called sustainability or environmental control, the climate control or climate change topics. They are becoming very serious issues. Recently, we had freeze in Texas. It shut down the fabs for days. In nanoseconds, shutdown of a fab means hundreds of millions of dollars of losses. I'm sure Sundar Singh will know this from SCL experience. Every fab, no matter how big or small it is, a nanosecond shutdown is a big deal. So climate change is becoming a big problem. There were floods in New York for the first time, fires in Turkey and Greece, which we never heard before. So the whole thing is changing very drastically. The average rise of temperature is going up. Now, SEMI is part of the problem. SEMI industry is part of the problem. Any fab, in general, consumes power equivalent to 50,000 houses per day, and about 10 million gallons of water per day for what? So we consume a lot of power, a lot of energy, but SEMI also provides solution for changing this, dealing with this problem. So we have a major focus called with Sustainability Advisory Council. We have a number of companies who are logos are there. They're part of that. We're developing the roadmap, making definitions, the standards. What does it mean? When we ask people, what does carbon neutral mean? and this you can do this experiment yourself. You ask 10 people, they will tell you something very similar, but there are many subtle differences. We don't even have a common definition. COP26 meeting in Glasgow, same thing. There were a lot of talking. Many countries have different goals. Some countries are saying carbon neutral by 2070, some are 2050, 2060. But SEMI is going to bring everything together. And at the Semicon West on July 13th, we'll have a major summit. And again, we'll bring the industry together. And this is how we actually deal with these various issues and then continue driving this until we are all on the same page. So this is a snapshot of where we are on the ecosystem. I took the USA out from this because USA will probably have dark green everywhere. But just take a look at it. China, Japan, South Korea, Taiwan, Southeast India. Now, we heard this morning also, I'm glad that my slides are consistent with what Randhir presented. India is pretty strong on EDA and IP, and medium or low on materials. And there are other areas we are still open questions. So there are a lot of opportunities for India to excel in the other parts of the ecosystem. And why I'm showing this slide? Because in the past, the one big difference about this policy, in the past we only talk about wafer fabs. In my opinion, anybody can build a wafer fab, but what you're going to do with a wafer fab if you don't load it and don't run it, and if you're not able to run it. So in able to run it, you need all the ecosystem. So this is really the kind of a qualitative view on where the various countries are. Now, again, we don't need to be good at every part of the ecosystem because we are interdependent on the rest of the world. We should try to excel in where we feel we can, and things we feel that make sense for us, let's do that first. And don't try to boil the ocean that we're going to try to fix everything. Now, I'm not going to tell you here that China is doing great and we are behind. Again, that's water under the bridge. We could have done better if we wanted to, but whatever happens, happened. But we can still do it. Now, China has done a smart thing. They started in 2014 a 5-year strategy plan, Make in China. And after 2 years, they realized that people are starting to become very nervous about it. They took that plan underground. Now they have another 5-year plan. They are committed. There's a strong alignment from the leadership all the way to the industry. And I think I see the same thing happening here. There's a strong alignment. The first time I've seen the Minister of Electronics, the State Minister, and Prime Minister Modi ji all giving the same message. I think that's a great start for India. I'm really, really, I will say, excited about this and inspired by this. I think that's what India needed to do, and it's happening. Now it's up to us as the industry leaders, as the academia here, that how do we partner with the government and take this further. I have given a kind of qualitative snapshot where China was 20 years ago and where China is now and where India is and where the blanks are there. So how do we take these question marks into tick marks? And I put SEMI can help. Again, not going into any details, but SEMI can help virtually in all areas wherever India needs help. And we are there, and I'm committed to support India. Now, this morning, we talked about can do or will do. This will not happen unless we decide that we're going to make it happen. Now, India has all the ingredients of success. China did not even have the talent pool at all whatsoever. India has the best of the best brains, the best talent, and that's the number one, I think, say, limiting factor. India has that. So we should take that. India is the capital of the universe from software point of view, which is a very important part for our semiconductor industry. So India has so many things to offer, plus India has the market. 1.3 billion population, that's the market. Some people say, where's the market? What products? Products will come, but the consumers are there. That's the market. That's why most companies went to China, because of the market. 1.3 billion people there. So let's not forget, we have a lot to offer here. Again, I will kind of, other thing I will say, India has pieces of, for success, software capital of the world, talent, startup ecosystem. We heard this morning. Now, my slides were not aligned with anybody. These are independent slides, and everything is very. Number of internet subscribers, 675 million, second to China. That number was only 400 or so about 2 years ago. This number is growing, very good. Make in India, all these focus areas here, and the companies involved in that. And the growth, 8.9% GDP. I mean, all the ingredients of success are there. This is a slide by Handel Jones from IBS. And I think we heard this number this morning. 110 billion market by 2030, the products market. And it's broken down by MPUs, MCUs, standard cells, you name it. Everything is well established here. So we have the market, we have the willpower, we have the mission, we have the vision. Now it's up to us. So I'm not done yet. Recommendation for success. When I showed you the slide that has the ecosystem, I said only 2 green colors. We don't need to do everything. But the barriers to entry, or cost of entry, it shows design software, not too much capital intensive. When we talk about labor supply, it's also not expensive. The most capital intensive is the wafer fab and all other things, but even for wafer fab, this country is ready because the announcements or the policy that we announced by this administration, I think we're ready for everything and all the things. Only thing is, it will not happen unless the audience, the industry in India and around the world understands this and believes this and makes it happen. So, the markets that will really benefit, smartphones, consumer electronics, EVs, PCs and tablets, IoTs, and data centers. These are all the growth areas. In fact, I can assure you, the 110 billion market that we talked about, I think that's understated. If we really get the ball rolling here, 110 billion can go up by a factor of 1 or 2, 1.5 or 2. I'm pretty confident of that. It's up to us. So, again, call to action for India. Workforce development, that's absolutely important. We have the best of the best brains, and we send them to US and other parts of the world. I was at IIT Delhi with some of the friends here in the meeting. There were 3 or 4 PhD students. I asked them, I have a job offer for you. You want to come to US? Now, they were a little bit shy. They didn't say yes, but I got a resume same day from one candidate. I bet you any money, if you offer the students the opportunities outside India, they will run. But please keep them here. President of Taiwan, Dr. Tsai, she told me, Mr. Manocha, please help me bring the graduate students, undergraduate students who, after degree, bring them to Taipei. I'll roll out the red carpet, give them immigration upon arrival and a job. Because Taiwan is losing all the talent to China. China is hiring people from Taiwan at 5x the salary. So again, we are producing the best brains here. I could not get admission into IIT. And I was speaking there and I felt very humbled and honored to be there. But again, if you look at most of the CEOs, they're all IIT graduates in US, right? So we produce the best brains here. Let's inspire them, motivate them, and show them the opportunities. They don't need to go outside India. They can be here, and we can create opportunities here. Again, SEMI can help expand industry, academic. The partnership between 3 is very important. So again, Mr. Kumar is here from MIT, but that's the role I will play with MIT colleagues, that how do we bring this partnership, industry, academia, and the government together so that we can solve these problems and also execute on the plan that we heard this morning, the India Semiconductor Mission and so on. Collaboration with the leading Miami, and you can really get a lot of knowledge from the best of the best brains around the world, and that can get you moving. Again, the increased investment in hardware startups, that's your call. But again, SEMI will actually be the ambassador for India investment in US and Europe and Japan and Korea, so to bring more investment into India. With that, you know that many governments are rolling out the incentive plans. India is, if somebody says 10 billion is nothing, That's okay. Please, let's not criticize that. Rather say, that's a great start. We go from 10 billion to 40 billions or 50 billions, and US is doing only 52 billion, which is nothing. In fact, India, 10 billion looks much bigger than the 52 billions of the US. US was totally away from absent on these things. Now, Korea has announced $450 billion investments in next 10 years. I think we need to really get government, show them the proof that we are going to deliver, so they will actually come with more investments. I'm very confident. All right, so all I'm saying is that semi-industry is going to go to $1.3 trillion, but the electronic industry, which is the entire system houses and applications, that's going to go to $4 trillion by 2030. Again, lot of opportunities, lot of room to grow, and either now or never. Indian industry is going through a tipping point. So we need to really make it happen now. So it's basically, in summary, multiple key applications, global trade tensions. India can be actually a big beneficiary when there are global trade tensions, because India likes to be a kind of very neutral country, wants to really play a good role with many countries. And Modi ji has done a great job making a lot of friendship around the world. So I think India can play a big role and benefit from the other global geopolitical tensions. SEMI offers to collaborate and define a clear vision, articulate, and so on. And I think we need to really we can be a great facilitator and create a robust execution plan with a clear line of accountability to enable the ecosystem. So again, I'm all in for this sport here. I'm a member of the ISM. And whenever the ISM meets, I will play my role to support this country. And the one reason that I'm working for SEMI, I retired twice. I joined SEMI again because I just want to continue to work. Before I worked to live, now I'm living to work. So for me, this is great, and I'm here for you. Thank you very much.
But the minister is waiting over there. He will take it.
Okay.
Thank you, sir. Mr. Ajit Manoj, I am pretty sure he'll be available offline in case of any queries. We'll straight away head towards the next session, which is a panel discussion on India's march towards semiconductor capabilities for future. We have three esteemed personalities to be the participants here and two from virtual mode. First of all, it's my pleasure to welcome the moderator, Mr. Surinder Singh, to kindly come over. Ladies and gentlemen, give a round of applause. I would also like to call upon Mr. Barun Datta from IMEC to kindly come over. Mr. Aries Imberman from Tower Semiconductors. And we are going to have Mr. Rajkumar of IGSS Ventures and Mr. Rajesh Nair of Global Foundries will be joining us on the virtual mode. Just a quick intro about our moderator. Mr. Surinder Singh is leading SCL Vision to build a strong microelectronics base in the country and facilitate development of VLSI and MEMS devices and systems. Several awards and accolades have followed Mr. Surinder Singh. So let's give a round of applause for the moderator and the esteemed speakers. Sir, in the interest of time, I'm straight away handing over the session to you. It's over to you. Yeah. It's on, sir.
On?
Yeah.
Thank you. So, good afternoon to all of you. It's my pleasure to be among the best brains and some of the global stakeholders. And of course, I have the company of some of the world leaders in the semiconductor manufacturing. At SCL, some of you may be knowing, but the others, for the benefit of others, I like to tell that we have a very small scale compared to the global standards, a small scale CMOS foundry, and we are mainly working for Indian space program. Of course, we are supporting academia along with that for all their R&D endeavors. From the morning you are listening about the importance of semiconductors, so I need not re-emphasize the importance to this august audience. I also need not emphasize how big the market India is, but I like to bring to your kind notice that these are the consistent efforts of Government of India that, as you have seen in the morning, that electronic production, manufacturing, that has gone, it has almost doubled in the last 5 years to $75 billion in 2021 from roughly $37 billion in 2015-16. So semiconductors, realizing this, that they are the essential building blocks of this modern smart society. You see, everything is moving to smart, and the more we are going towards smartness, the more SEMI is needed. So this has been in the morning, in most of the talks, you have seen this. So seeing this, so Government of India has taken very big initiatives to bolster the last critical link, which is semiconductor manufacturing. As I said, we are there, and compound semiconductor also in the country in a very small scale is present. But of course, we are missing the scales which are needed to meet what is the demand which is shown is coming in the next few years. So seeing this, there is a lot of efforts, and the Semicon is also a part of these efforts. So taking this forward, I think the Government of India has laid the semiconductor manufacturing policy, and a good response is received regarding that. And as I said, though we have been doing it on a very small scale, but when we are moving forward, now this is the opportunity that probably we have a look at now the way forward, how we have to go so that we can, as rightly said by Ajit sir, that how to shorten the path for the gap which we have with the world. So we have to take right steps. We are taking a small step, but we have to take the right steps so that this gap, we can shorten this gap, and we can move forward for all our needs. So with me, the very eminent, as I said, personality panelists are there who have really a very, very big, good experience in semiconductor manufacturing. First, I'd like to introduce them because it's a virtual, as two of my panelists are joining in the virtual mode, and two are sitting with you. So I'll first very quickly introduce them to you, and then probably we'll move for the panel discussion. I thought that because, as I said, that we have to take the right steps. So the central theme, which is very, very consonant with this our panel topic of India's self-reliance in semiconductors. So I thought that probably the panelists can speak on that how we can establish a very robust and sustainable semiconductor manufacturing in India. Of course, there are many aspects which are related to this, as most of the speakers you have listened, like whether this is they can add in their talk or in their views that regarding whatever the supply chain problems are there, or talent pool. Augmentation of talent pool has been told by Vaishnav-ji in the morning talk, that what are the steps being taken. But along with the augmentation, the one more difficulty is retaining such talent. So if they can, if anybody can take and talk on that. Of course, there are many other challenges Seeing the current global scenario, you all know, so there is a big rush for setting up fabs world over. In fact, by 2024, nearly 100 fabs are going to be set up. And this is just a beginning. So how we have to move forward so that we are not denied the rightful place which we need right now. So along with that, I think the panelists can also elaborate that what are the roles probably of the academia or R&D center or fabs which can play here in having this goal. And over and above, as Honorable Minister said, that we need a very, very candid feedback. Though the policy is well laid, as said by Ajit sir, but still, if the panelists find that there are still certain things they need in the policies or regulatory mechanism or in long-term commitments from the state or long-term goals or any stone they feel is still unturned, they can really highlight that when they are giving their views on this topic. So I'll very quickly introduce all the panelists. On my right side, Barun Datta is sitting. He's Chief Scientist at IMEC. IMEC is a R&D hub for nanoelectronics and digital technologies, and it has established itself as world leader over the last 30 years in nanoelectronics. He has pioneered a novel and unique collaborative model that encompasses the entire semiconductor value chain that combines global talent and world-class infrastructure. Founded the Euro practice, most of the designer and users who are sitting here, they know this. So he's founded the Euro practice IMEC Link, a unique design ecosystem to enable academia and SMEs to assess advanced foundry technologies, designs, and packaging tests. Barun returned to IMEC as chief scientist in 2010 and leads and has led various R&D programs across IMEC semiconductor R&D ecosystem, from new materials, device technology to life science tech and neurotech programs. From 2000 to 2011, he was a venture capitalist and general partner at Rosen Alta Berkeley, and incubated, co-founded, and invested in 14 successful semiconductor and system technology companies. In his earlier careers, he was at Bell Labs and Texas Instruments and was first customer assignee at IMEC in 1994. Take a hand. On my left is Mr. Erez. Erez is a good friend and partner. I must tell the audience here that they are our technology partners. The small foundry, whatever small foundry we have, has been set up along with the Tower Jazz. So Erez was appointed as Vice President of Business Development and Special Projects in 2010 to manage worldwide business, especially in India and China. So under that itself, we started getting the TOT from TSL. Previously, he served as Tower Semiconductor VP, Global Supply Chain Manager. From 2005 to 2010, he served with Intel Corporation as Engineering Department Manager and Fab Establishment Program Manager in Israel. Prior to 2005, he served as Tower's Fab 2 Manufacturing Director, Fab 1 Manufacturing Manager, R&D Director, Productionization Manager, and Test Manager. And prior to which, he was employed by the National Semiconductor in various engineering and management capacities. Please give a big hand. Mr. Rajkumar, who will be joining us in the virtual mode. He is the founder and group CEO of IGSS Ventures Private Limited. IGSSV is a technology investment holding company with with key subsidiaries focused on delivering unique capabilities across three key segments: disruptive semiconductor technologies, IPs, and fabrication; pure play foundry services in specific technologies; and truly unique plant and fab foundry transformation services. Mr. Raj held various senior leadership roles with increasing responsibility prior to setting up IGSSV. In his previous roles, he was responsible for $2.5 billion revenue from 6 world-class foundries with 7,000 employees. Also manage a global business unit of US $1.2 billion. He has also chaired boards of various international semiconductor fab joint ventures. In 2012, he was elected to Singapore National Productivity Council, representing the semiconductor and electronic industries. So our last panelist is Mr. Rajesh Nair. He is the Vice President for AMS and ENVM Technology Solutions at Global Foundries. Raj is located in Santa Clara, California. Global Foundry is a pure-play foundry with a broad suite of technologies supporting mobility, automotive, industrial, and compute applications. Global Foundry has manufacturing facilities in Singapore, Dresden, Germany, and Malta, USA. Global Foundry has a growing footprint in India with over 700 employees at present. Raj has over 25 years of experience in semiconductor industry and is one of the pioneers in the field of smart power technologies. In Global Foundries, Raj is the R&D leader responsible for developing critical technologies that can be found today in many smartphones, electric vehicles, and IoT devices. He has previously led the mainstream CMOS business unit with over $2 billion revenues, and prior to joining Global Foundries, Raj held executive positions at Maxim, ON Semiconductors, and Motorola. So I welcome all the panelists, and seeing the time paucity, I straight away request Barun Dattaji to give his viewpoint on the topic which is there right now: establishing a robust and sustainable semiconductor manufacturing in India.
Hello?
Thank you.
Okay, I'll take a shot. I think that what at least our experience from IMEC has been that the semiconductor has multiple pillars, but what IMEC has focused on has been to establish, I would say, a global R&D platform. And this addresses both the medium-term and the long-term needs of the industry and the ecosystem. I think if you do one thing about what we have learned over the last 25 or 30 years in the semiconductor industry is that the semiconductor ecosystem is a very long-term play. And it's something that needs support across all stages of the ecosystem. You can't, it's very difficult to pick and choose winners or in particular sectors, unlike many other places, because it's a very dynamic industry. It is foundational. What is today's software is tomorrow's semiconductors. That's what it is. Okay, in the classic sense that what paper was to the Renaissance, semiconductors is to the digital age. It's that powerful and universal. So the emphasis on, and I think Ajit raised this, emphasis on talent training is one aspect, which is mainly the resource of the universities and academia. That needs to be strengthened. It needs to be focused. Semiconductor technology and its design side is the most demanding engineering skill that is around. And that is benchmarked by the, if you look at all the benchmarks of the National Academy, they all say that. So it's a question of training, and it's critical not only in quantity but in quality. This is one of the emphasis on quality and programs and modernization is critical. The next part of it is what I would call is the R&D platform, which every country who's a dominant player has. I would say IMEC is one of the few places because of its location and its neutrality. We are a global player, but every other nation has an equivalent national platform. That's true for France, that's true for Germany, that's true for the United States. Might be it's not that well structured, but it does exist. That's true for Taiwan, that's true for Korea, and it's true for every other nation. Okay? And I think the emphasis here has to be that that needs to exist. So at the national level, there has to be, let's call it, whether you call it a national lab or whatever it is, or an extension of how SCL has played. That's a role which is very important. There is the academic role, and then there is the entire manufacturing and design ecosystem. I think the design ecosystem is very well developed here, but I think it also needs to transition from a design services to a product ecosystem. And this is an issue because all the creativity to support the local ecosystem is going to come from people who understand the local applications and demand. And that, I think, is where the next phase of the growth is going to come from. If you have these fabs and other fabs, I think this is just the beginning. You might get a few fabs now, but I think the process has to be that I think you should look at it that every year there should be a new one for the next 10 years or 15 years. Okay? So this is not an event, but this is a process. And the R&D ecosystem will grow to support it. Okay? That, I think, is the purposeful destination, without which I think it's going to be a challenge to sustain it. Okay? And then you can talk about competitiveness, which is going to be local driven, as well as I think one of the great opportunities today is how do you become the most sustainable, greenest semiconductor manufacturing in the world? I think Ajit alluded to that. I think we, for instance, have just had a very new program which started off in sustainability, which has had is having very fast growth and rapidity. And this is the unique opportunity. Today, nobody has a perfectly green or sustainable. They have missions, but this is a long-term process. But this is where the R&D plays a role. Okay? You could argue that since this is a new industry, that it is in 10 years' time, compared to anybody else, it's the most green manufacturing in the world. Okay? So you can think about, I think the sustainability has to be in short, medium, and long term. Talent buildup is the longest term short-term to longest term requirement, and there is a medium-term requirement in pathfinding and pathfinding R&D, which will allow the creation of new applications and new technologies to support the entire infrastructure.
Thank you, Parn. So you said that there has to be a national platform similar to what the IMEC is. Of course, IMEC model is very famous model. Those who are in the business, they know this, and it is not easy to have this model everywhere. But what will be your suggestion? See, as has been emphasized by everybody right from morning, there's a good talent available in India. So what will be your suggestion to us? The few fabs will be coming. Do you suggest to have a R&D fab or center as along with the production fab in first few fabs, or you will suggest that it should be totally separate from the manufacturing?
I think this is a difficult question, and it depends actually on it's all about timing when the manufacturing infrastructure gets built. But what I'm saying is these pieces, if you take a chessboard, you can't be missing the knight and the rook and try to build an ecosystem. Okay? And I think if you go back and look at 30 years ago, and if you ask the two founding directors of IMEC, Vanova Stratton and Gilbert de Klerk, if they'd ever predicted what IMEC would look like today, I don't think they wouldn't have got it right. I was one of the first assignees. I can tell you we didn't know that it was going to work out this way. Okay, so I think it's very important that they are in some way connected. I don't think they should get isolated. I think that's the most dangerous thing. They need to be connected. Potentially they could be co-located, but I think they do not have to. I mean, I think as you can see in an IMEX case, all our customers are all over the world. So we have figured out a model by which it can work. So I think, but what is important is that the steps are made. I don't think you can have the gaps in the ecosystem. That is the critical part. And I think with what you have to start, and you have to be flexible and evolve. And I think that's the important thing. Okay? You have to make the start, you have to move with what it is, and then add on to it, and you have to be open to that. Okay? And I think that's the critical part of it. It could be that you create a mini fab next, that might be the right solution for a 300 millimeter. It might not be the solution for, might be an 200 millimeter platform. It can be extended. So I think it's a mix and match depending on what is the right thing at the right point in time. Okay? But I think the openness and commitment needs to be there both at the national infrastructure level, but also on the academic side. I think as much as you've got a big talent pool, as Ajit said, we need to strengthen it much, much more, because the success of the industry is going to depend on the future students being trained now. Okay, they are going to build this industry. All of us are in our 50s, but when I look at it, I mean, none of us have enough gray hair, black hair left on our head. So we are not going to make this industry successful. The next $500 billion is going to come from the next generation. Okay, and we have to make sure that we build a platform that they can run with it. And it's their creativity that's going to do this.
Thank you, Arun. Thank you for your kind words. And another thank you for keeping the time. Actually, I request all the panelists to be roughly within 10 minutes because we are already running late. So I invite now Erase to express his view on our central theme.
Namaskar.
He's more Indian than...
You know, despite...
I just want to say one thing. Whenever he comes to FAB, I understand half of the Hindi, so we are afraid of talking in Hindi before.
That's what I want to say. Despite the fact that I'm visiting India in the last 12 years, I think 100 more times, the only word that I know is Namaskar. And this is responsibility of Director ACL that he didn't teach me anything despite we working together for the last 7, 8 years, whatever. So sorry about that, but great honor to be here, really. I really appreciate the invitation. And before I give you a few of my views on these things, because I have so much to say about that. But I want to take one step before and talk about the two ministers and Honorable Prime Minister. They talk in the morning and take one theme from what they say. So the Minister Chandra Shankar asked at the end of his lecture, asking, is it possible to do in India? So my answer for that is yes, in one word. If you ask me in 2 words, I would say it's absolutely yes. The theme that I take from Minister Vishnu is he is saying, rightly, that this is not a sprint, this is a marathon, and I totally agree with that. However, I would like to say that the marathon did not start today in India. We are in the middle of the marathon. I don't know exactly if the 5th kilometer or the 10th kilometers, but for sure it started long ago, and right now we are accelerating toward making more progress on this marathon. And third, and not least, of course, Mr. Modi, which is initiated all this program and all this slogan that we see here, the Make in India, Digital India, Skills India, and all these things together, for sure, this is a great initiative, and I think this is an excellent program that very welcome in India, and I'm personally, as an outsider, really excited to be part of it. Now, also Prime Minister Modi talked about 6 points from his point of view. I have my 6 points separately. I assume they are quite having some in common, I assume. But I'll tell you in a second what are my points in this view of making semiconductor manufacturing in India. But before that, I want to tell you that first, as I said, I'm very honored to be invited to here on behalf of Tower Semiconductor. And also, if you look closely, you can see that I'm wearing a pin here that has Israel and India flags together. And this is celebrating this time the 30 years of cooperation between Israel and India on business and diplomacy. So I'm not a diplomat, but still, I like to mention that there is close cooperation between Israel and India, and I'm very happy to be part of it as well. So to the point, I think that setting a semiconductor in India is having few critical things that need to be taken in consideration, and most of them are taken care right now, and I think they are in a very, I would say part of them are very advanced stages, and part of them need more. But first thing, and we heard about it a lot also this morning and in the last months, is the government support. So government support to initiate and push top-down this initiative is super critical because it's, first of all, it's how it started everywhere in the world, right? Every country that started semiconductors started with government support because it has so much of a capital and so long of a return of investment to build the market, to start running ecosystem and having everything in place. So government must be active role on that. And we've seen right now that with the policy that announced in December and the program that initiated in the ministry, and the government is really focusing this time on doing that. The other thing, the second point, from my view, is the Indian partner. So Tower is an Israeli company and international cannot do anything without strong Indian partner because there's a lot of things that, with all due respect, that I'm here so many times, I know almost nothing about India and need somebody that live in India, understand the culture, have the connection with the government, with the regulations, with all the different roles that they need in order to initiate this semiconductor manufacturing. There's many, so it must have a strong India partner, business partner, virtual capital partner, somebody that supporting this activity. The third one is the technology partner. Technology partner, as my friend from IMEC say, and we all know, it's critical. And it is recommended, not that India cannot develop it by itself, but you cannot invent the wheel right now, and it takes a lot of time and a lot of efforts. And when it's available on the shelf, and somebody, Tower or like Tower, again, I'm not selling Tower right now, but Tower like Tower can license technology to India for their demand, that is the best to do, in order to accelerate the time to market, as we say. The fourth point is the supply chain and or ecosystem. And two of those words, buzzwords, people are talking about them so much. And I think there is a long-term and short-term in this ecosystem and supply chain. And when we talk about fab establishment, there's something different that you need. The land and the water and the power and the waste water and all the facility ready. And for that, again, you need strong support from government, from local government, state government, where you are going to put the fab to understand the regulation and to get all this infrastructure. And when you get into production or ready to production, the supply chain or the ecosystem is different, because then you need all the material, gases, chemicals, specialty gases, test wafers, sputter targets, slurry for CMP, a lot, hundreds of different materials that are supplies, including the machine, the equipment, spare parts for the machine, services for the machine, and a lot of things that this fab need in order to be operational in a good mode. The next one is the point of know-how. So again, there is a lot of know-how how to run manufacturing fab. Okay, engineering system, manufacturing system, and you need this fab to be the, I would not say best in class, but at least in the outstanding industry standard, so people will have incentive to manufacture in this fab. Otherwise, this fab, if it not be in the world standard, why should any customer do the design and manufacture in this fab? So all the know-how how to do that and how to make it outstanding and best in class in the industry standard, this is again, you need someone that have the knowledge and the capability to give the address. And last but not least, and people talk about it a lot, is the resources. So I don't agree that it's need to be started from zero. There are so many Indian talents in every semiconductor company in the world, manufacturing or not manufacturing. There are hundreds of talents. Most of them, or few of them, are sitting on the top level of the companies, and they are, I assume, they are really ready to come back home, come back to India, in case there is jobs and there is semiconductor manufacturing in the country, so they can serve instead of doing it outside to come back and do that. And I know that from my experience in your facility, Director, that the people that we try to bring, we hire a lot of people from Singapore, from out of India, and they come back, and they're happy to come back, and they're very experienced. And hand to hand, all the program that people are talking here about connection to the academia and doing the training program, etc., this is, of course, is a very high priority.
You finished?
Yes, thanks.
Yeah. Thank you. It is, because it is, as I told initially, he has been responsible for developing many fabs, not first in India, and then in China and Japan also he goes. So with the current geopolitics, you have emphasized on supply chain. So the global supply chain challenges, what do you feel, what are they right now, and what it means for the timeline in which we are thinking of putting a 300 fab?
Wonderful question. You know that today the world not really is very long, right? Everybody know now that if you're asking a scanner from ASML, they will give you a lead time of a year and a half or so. And you're talking to Applied Materials also. The lead time of equipment is between, I would say, best case, 8 months, 6 months to a year and a half. So this is a very, very long, that's one example of the equipment. That's the bad news. The good news is that we did not start construction yet, the fab in India. And this by itself is going to take about a year and a half to 2 years. So if we're going to initiate the fab in India and hand-to-hand be smart enough to start and issue POs for the critical lead time items like tools and other material, that will fit the schedule, it will not affect the schedule. And I think you're asking general question about the schedule, so from my experience, to build such a fab from after government approval and everything in place, from groundbreaking until you start making products after construction and tool and installation and technology, verification and qualification, it can take minimum 4 years. Okay, so that's a long journey, and the supply should be taken into consideration as well, as I explained.
Thank you, Eres. We are already, I think, running late. So I'll now request Mr. Rajkumar from IGSS Ventures to give his viewpoint on our central theme.
Thanks, Surinder. Can you hear me loud and clear? Can you hear me?
Yeah, we can hear you very clearly.
Okay, great. Okay, firstly, namaskar. okay, and a good evening to all. Okay, and since the main theme is how to have a robust and sustainable semiconductor manufacturing ecosystem in India, I would like to touch on some of the fundamentals. Okay, so I was fortunate enough to have close to 3 decades of semiconductor fab, especially semiconductor foundry pioneering background. Okay, and India is late. Okay, let me be frank. India is late by 35 years or more, depending on which semiconductor segment you're looking at. But there's one key advantage if you're late. There's many disadvantages, but there's one key advantage if you're late. And that advantage is to learn from the mistakes and the positives of other semiconductor nations that started before India. And there are many valuable lessons that India can learn from there, which can be a very strategic value to India if we know how to use this wisely. Firstly, for example, the budget is $10 billion. I think it's a reasonable budget to start off with, okay? But it is not a budget that can compete with some of the nations, semiconductor nations in the world, okay? China, for example, in the last 30 years could have easily invested $500 billion in semiconductor. US, the pioneer in semiconductor IC chip design, even today is spending 40, 50, 70 billion dollars. So India's 10 billion is a decent number, right? So then we need to know how to optimize this dollar much better than the previous semiconductor nations. If we can optimize $1 in India in semiconductor investment equivalent to at least $2 or even more, because this is what I meant, that we need to learn from the mistakes and the positives of other nations, right? Then the $10 billion which comes from the government, and assuming another $10 billion comes from the private sector, okay, that 20 billion can be equivalent to 40, if not 100. That is the differentiation, right? So when we talk about optimizing the dollar, okay, and how to optimize semiconductor journey in India, okay, to the max, then first thing we need to look at is which technology space we play. So I'm going to confine myself to manufacturing in this case, so semiconductor fabs, and that is going to be the group that's going to take the biggest capex and investments. So broadly speaking, there's two groups in semiconductor technologies. Okay, the digital technologies, or better known as bleeding edge technologies, which can cost $20 billion or more per fab. Okay, so just take note, $20 billion or more is 2 times the total budget that we have in India. And then we have another segment of technologies which is known as more than more technologies, which doesn't follow the Moore's law, right? That has a lesser total project cost to start a fab. And today globally, okay, I think the data in 2021, the total semiconductor TAM is about $600 billion, $630, $650 billion. Close to 45% of that is still based on non-digital technologies. So India, with $10 billion and starting late, etc., one key strategy here can we focus initially on the more than more technologies, where we can get the biggest buck for it, right? And when I say that, okay, I'm referring to say, yeah, we can have 28 nanometer all the way to, say, 0.18, where there's still very important products and requirements. What goes into your heart, for example, pacemaker is old technology. What goes into the EV cars, there's a lot of old technologies. What even goes into the mobile phone has analog mixed signal, power management, high voltage chips, and etc. etc. Nothing wrong with digital, but if it's my own money, okay, will I take that gamble in the beginning, putting up $20, $25 billion in the very first fab at this stage? Likely not, right? But we can look at 14 nanometer and even maybe 7 nanometer in phase 2, phase 3, and etc. We can, right? But we got to study it correctly. Another thing that is important is there's close to about 300 fabs today, globally, 200, 300 mm. There's still some 150 mm fabs. I'm referring myself to silicon fabs, consisting of IDM fabs and pure foundry fabs. It is very important at this stage when we start fabs, we need to have vital differentiation. If you do not have vital differentiations, why would they come to India? So why I use the word they? It is initially for the first 5 to 10 years a global business. India's ecosystem. We have heard many knowledgeable speakers saying that India has very large design capabilities, etc. Very true. But there's a difference between partial design capabilities and full fabulous capabilities. And full fabulous capabilities in India is still at the early stage. The positive part is the raw talent is tremendous, and if they are enabled in the next 5 to 15, 20 years, this can be very successful fabulous entities. But we cannot wait. We cannot wait for 10, 15 years to fill up this fab in India, right? So that is very important for the future of these fabs in India, but initially this fab got to be world-class, which in my term will be tier 1 foundry fabs, right? Which is truly world-class, which I believe one of my panelists was just referring to that using another term. It has to be world-class, tier 1 foundry methodologies. So you need to have an entity that has that capabilities, that experience, and more importantly, willing to impart that knowledge to India. That is very important, right? The next point that many have said, and I'm going to also say that, okay, that semiconductor investment is, especially for greenfield fabs, is a very expensive investment. So throughout the world, and we spent 2 years in discussions with MIT and Niti Aayog and many others to convince that Indian government has to come in aggressively to support this industry, especially in the beginning. Okay, we looked at examples in Taiwan, in Singapore, in Malaysia, and China, obviously, even in US, right? After 60 years being the #1 semiconductor nation, they're still pumping in $50 to $70 billion in 2022 onwards, right? So government of India is going to be very important, and I think the policy, I agree the policy is a good start, a very good start, okay? And what is important is to launch the semiconductor project, the semiconductor fabs timely. Okay, I'm not sure how many in the audience knows that India's journey or interest in semiconductors started even way before 2008, right? So there's more than 14 years that's passed by, and semiconductor industry basically runs at a fast lane, right? It's very dynamic. We have lost many opportunities in the last 10 years, especially with M&As and etc. So launching it timely is very important to gain the global industry's attention, but some of them are relatively wary. Okay, it's great that India has come up with a policy. It is great that we have Semicon today. It is very important that we get into execution, right? And yes, do it right and select correctly. In that light, okay, I would like to just take the last few minutes to say what I believe is very important when we say that we need to learn from the mistakes and positives of other nations, right? So decision makers need to understand the difference between a satellite fab that is brought to India or any other country, for example, versus a concept of HQ-centric fab that is more focused on creating a win-win with India and also the global industry. There's a big difference, right? So if you look at Taiwan, more than 38 years ago, a group of IDM semiconductor experts came to Taiwan and eventually started off TSMC, right? And they had a good partner in Philips, which later became an XP. If you look at China, you had American Taiwanese, I believe, okay, who went to China, okay, with people and together with the Chinese government, they funded them and etc., and that created SMIC, right? In both Taiwan and SMIC, the flag bearers of semiconductor technologies and foundries in Taiwan is TSMC, in China it is SMIC. Take China, for example. There's many other fabs in China which are satellite fabs. Intel has a satellite fab in China. I use the term satellite just to show the difference. TSMC have satellite fabs in China, which are still 200 mm or doing old 300 mm technologies. It is SMIC that is driving the roadmap in China. Same thing in Taiwan. We have many other IDMs having fabs in Taiwan, but it means the success of the industry in the given nation. Don't take this wrongly. It doesn't mean you do not need globalized support, global collaboration, etc. I'm a firm believer in global collaborations, right? And we do that a lot in my previous life and even in IGSS ventures, even more in IGSS ventures. We have partnerships with IMEC, we have partnerships with local universities, research institutes, we have partnerships with global universities. So you need to have global collaboration because it's a global business. But India needs to also have localized entities or adopted entities who are willing to create win-win with the government of India and Indian entities. That's very important. If it's going to be solely dependent on foreign entities, many nations who use that formula do not succeed. Okay?
Thank you, Raj.
Yeah. In the interest of time, you would like me to stop here?
Yeah. It would have been much better had you been physically here, so we would have had the more opportunity to talk to you. Raj, I just want to, you have said that learning from mistakes, okay? So you have pointed, you are saying that budget optimization, technology mix, right technology mix, you are saying, technology optimization, okay? See, we, as I have areas also regarding supply chain and seeing the current problem, what will be your viewpoint for setting up quickly few 300 fabs? Would you suggest going for the totally new equipment, refurbished equipments, or acquiring certain, see, that is also an optimization which probably has been suggested at many places. Acquiring a fab anywhere available right now because of the geopolitical conditions. So what will be your opinion, see, in this kind of global scenario? So what optimization you suggest?
Okay, there are many, but in the interest of time, since you mentioned refurbished equipment, right? Okay, we took 2 years to convince Indian government that they need to support refurbished equipment, okay? Even in Singapore, which was a pioneer in semiconductor foundry fabs. We started foundry fabs in Singapore in 1986. Taiwan started in 1985. So in those years, there's only 2 foundry nations, right? Today, there are many, right? So we started using refurbished tools in Singapore, even when I was working for Temasek or later on for Global Foundries Mubadala, which are some of the richest national investment entities. I was using refurbished tools wherever I can, right? It doesn't mean you don't use brand new tools. You've got to use a combination depending on the technologies you're working on. So refurbished tools is a must because it reduces capex costs, right? So keep this in mind, right? If we are starting a fab, say in the next 2 years, we can't wait for 4 years. In the next 2 years, the fab is operational, right? It is going to compete with fabs in Taiwan, China, Singapore, US, Europe on similar technology nodes, which were started 10, 15, 20 years ago, right? So how are we going to be cost competitive? So one way is refurbished tools. Second way is every dollar we spend, we optimize it because the other nations in their early years made a lot of mistakes. We can't repeat that mistakes, right? So yes, refurbished tools is the way to go, right? Having strategic partnerships with the key OEMs is a must. So for 28 nanometer, you can still get majority refurbished tools, but today refurbished market is also in hot demand, right? So it's going to be a combination of refurbished tools and brand new tools, right? But that's just one aspect of it, huh? Okay, you got to know how to have your technology strategies, how you combine, okay, certain emerging niche technologies with mainstream technologies so you can have better financials, less competition, right? If you're going to create a Me Too like 35 years later, you're just increasing the challenges of making this fab successful. But if you still can come 35 years later and be a leader in certain emerging technologies, that's the way to go. And India has a lot of talent. Okay, there's the second largest engineering resources in the world. It has the youngest youth population in the world, and it has a very attractive domestic market in the future, right? Which by putting in these semiconductor ecosystems and making the right decisions across fabs, foundry fabs, across design houses, there's also a world of difference between having world-class partial design services and having a complete design capability to come up with products, right? And India has the raw talent, but it's not there yet in terms of having 20, 50 proven, fabulous domestic companies. And here I think we got to also play both the Indian card and the global card. It's okay to adopt, okay, world-class designers who are willing to come to India to start up the company. Why not?
Thank you, Raj. Thank you. I think Erez wanted to have
Yeah,
a
just
quick reaction.
one comment about the tool refurbishment. So tool refurbishment is a good solution. The problem is that it's timely and market condition. You know, today there is zero refurbishment tools available in the market, both for 300 millimeter and 200 millimeter. So I don't know when this fab will come and need the tools. Maybe the condition will be better, and then we can use refurbished tool. This is the condition, so we should keep that in mind.
Thank you, Erez. So now I welcome Mr. Rajesh Nair, and I really appreciate he is awake in this late hours, rather early morning, I say. So I really appreciate your commitment. Sir, I like to have now your views on our central theme. Please go ahead. Thank you.
Sure. Can you hear me okay?
Yes.
Okay. Yeah. Firstly, thank you, and it's a pleasure to participate in this panel. I know we're running a bit late, so the advantage is most of the salient points have been made, so I can maybe just emphasize or add a couple of points. So in terms of supply chain, right, we had with COVID a black swan event. We had people starting to work from home, so lots of bandwidth requirement. They were starting to shop from home, starting to get entertainment from home. So that built a lot of demand. And then along with 5G and also vehicle electrification, the demands have gone very, very high. Okay, so, and then people, I think, have realized that having semiconductor manufacturing just in one or two countries is not healthy. And also they have understood that having some resiliency in countries that you can depend on, some of it in your own countries, is critical. So I think that is going to play in India's favor. Okay, there's a $2.2 trillion electronics market, and below that is about $550 billion of semiconductors or semiconductor products, and then underpinned by $90 billion of foundry, okay, give or take. Okay, this is where Erez, myself, and then also Rajkumar and Ajit used to be, and I believe still are to some extent. So this is the ecosystem. When assembly lines in automotive plants, mobile plants started running dry, people understand now the value of having resilient semiconductor supply chains. Okay, so that is actually going to play in India's favor. Now, in terms of, we talked about supply chain of fabs, but in turn, fabs need an enormous supply chain and ecosystem. You cannot, you have some tool down, you cannot have spares coming in from Singapore or Taiwan all the time, right? You need to have all these vendors, equipment guys with their own spare systems locally, and also have trained equipment suppliers who can repair and maintain these tools. So that should be considered a very critical part of that ecosystem development. So that were the couple of points I would make on supply chain. On developing and retaining talent, I think most of the points were made. As was mentioned by Barun and Ajit especially, that we have a massive talent problem. With the millennials, we want to make semiconductors cool again. A lot of us are gray-haired people, as Barun mentioned, and the next generation, we need to tap into that talent because they're going to take us to the next level, right? And with a trillion-dollar semiconductor industry. So make semiconductors cool again. And what do they care about should be very important, right? Diversity and inclusion, equity, interesting and challenging problems to solve, green manufacturing. Those kind of things have to be highlighted by the industry. Okay, so that is important. And then in terms of talent, of course, This is also where partnerships with companies like Global Foundries and IITs, etc., to build that talent would be quite useful. And actually, GF is doing that. We have 700 people in India. They're not IT and finance people, okay? They develop our design kits, they do demo designs, they do models, they also do some fab activities. As you know, a lot of fab activities can be done remotely since these are all automated fabs. So this all can be done. And also labor arbitrage is not as critical, you know, in semi-industry compared to maybe other industries. You know, you pay for talent wherever it is. Okay, we have people from 90 countries in Global Foundries. So a good device or integration engineer, you know, well paid is more than, you know, 4 or 5 mediocre device or integration engineers. So paying for talent is almost like, you know, IPL, you know, you pay for the big hitters. So that should be critical. Now, in terms of policies and regulatory support, you know, Global Foundries didn't say we're going to build a fab right away, right? But we are playing a long game. We are certainly growing our skills in India and growing the talent pool. In terms of what else can be done, I would say, you know, think of this as a sustained partnership. You know, you look at Rajkumar's look in Singapore, you know, the EDB model where they will assign someone to you for a few years, then they do rotate, just like Indian civil service. But they're assigned to you, maybe they're assigned to 1 or 2 other companies, and they really understand your business, where they can help, how they can make connections, etc. So it should be considered a very close partnership rather than a standoff relationship. That's one point I would make. Another place that you could help is, of course, building the customer base. Now, it's great that India is now a very big auto manufacturer and a handset manufacturer, but also building designs coming out of India and nurturing that is should not be minimized as part of the ecosystem development, and also nurturing corporate partnership, you know, for companies like Global, and I think Erez mentioned Tower also. You know, we like to partner to be more prominent in the Indian market. The third point on the topic of policies is, I think Barun touched on this, you know, all these places with significant semiconductor presence, they have a local lab or fab, and often it came out of that, including Taiwan, of course, with the ITRI, but IME in Europe, Sematech in the US, etc. So that should be also considered. This is a very innovative industry. You know, large chunk of the engineers are actually doing R&D work and development work. So this is a very critical part of the ecosystem. Last point I would make is, you know, in terms of lessons learned, and Rajkumar could add more. But, you know, try to build a hub where 5 or 6 fabs can be located so that the equipment folks, the manpower, etc., is a lot more fungible rather than having, you know, one fab each in 7 or 8 different cities all over the country. Okay, and this model hasn't worked in a few other countries. So, you know, be cognizant of that and have enough power and land and water, etc., where many fabs can come into one location and becomes a hub. Actually, very successfully in Bangalore, for example, in the IT space, but we need something similar in the semiconductor manufacturing space. So I'll pause here in the interest of time.
Thank you, Mr. Nair, for your valuable suggestions. I think the panelist has given their wonderful views. However, I'll again persist with one last question on the theme. See, I still will like to invite your suggestions on, like Ajit sir said, that the world took almost 5 to 6 decades to reach the level where they are right now. And we are starting. So we need not, and Mr. Raj has also touched on this, that we should learn from the mistakes, as well as you said, that we should learn from the experience of others. So how we can, again, I'll say, shorten this gap and move quickly in setting up a very robust and resilient, I'll say, semiconductor manufacturing system in India. Any last quick suggestions any panelist or all panelists can have?
I think you have the answer here. All the people that just talk here, so much experience and have so much to say and so much to contribute and happy to help. So I think the best you can do is using the world support in order to accelerate and make it outstanding, best-in-class manufacturing as soon as possible. So just get, my friend in the panel, you have all the answers here. So just do it.
Any quick comment?
I think that's a critical thing, I think, to move forward, because if you're behind by 4 decades, the best thing is to make educated moves forward rather than, you don't want to get caught in this analysis paralysis type situation. I think that's the thing. But it also doesn't mean that you want to ignore the reality. So I think partnering, as IMEC has been a neutral technology provider all over the world to everybody, and I think in general, we are happy to help grow the Indian ecosystem at all levels, right from the R&D side as well as to any manufacturing platform that needs its support. But I think, and I also think it should not be a singular event. It has to be 2 or 3 groups or entities clustered in one place, as Eris said, because the supply chain has to be localized. The supply chain in terms of equipment and material suppliers is extremely critical for the success of the fab ecosystem. Okay? And this is something, as Raj correctly pointed out, cannot be distributed. It has to be localized. I would argue that there is option for 1, might be 2 at the most. I would say initially might be only 1 place where they can be localized, and it has to be properly facilitated in terms of energy, power, water, etc. These are extremely critical because this is the most sophisticated manufacturing platform humans have ever come up with. Okay? You have to keep that in mind. There is nothing more sophisticated. One of the good things about it, it has a very positive side effect because of its extremely demanding requirements on power and water and everything else. It has helped to improve the overall ecosystem across entire nations. Okay, so that is something to keep in mind. So this is a driver. It pulls everybody else along with it. So the side effect is huge. In fact, that is something to keep in mind. Even and I think it's important to move forward. The longer you take, once you've made the decision, I would think it'll be wrong to sit on it for the next 5 years debating what you should do, because you're going to be in this industry. Things are too dynamic. It's not just about nodes. It's about products being dynamic. Okay, they will change dramatically in the next 3 years or 5 years. I think so. It's important that these, like I said, there should be a fab being built every year for the next 10 to 15 years.
Thank you, Baran. So I think we'll conclude this session. I think the last point I want to say is that with the strong government intent and of course the government support, which probably I'll like to repeat the Honorable Prime Minister words which he has said, that I'll talk to you in terms of the microelectronic itself. So he said that the government is going to be an AND gate, which is really very encouraging and very encouraging for all of us. So with that strong government support and intent, and of course, as has been pointed out by a panelist, a good collaboration from all of you experienced stakeholders, probably I think the small step we are taking will certainly very soon become a giant leap in the semiconductor manufacturing for India. Thank you. Thank you all for the patience.
Thank you, Shri Surinder Singh and all the esteemed panelists. And of course, we had a very fruitful, I'm pretty sure the panelists will be available offline, and any questions are there, you can always address it to them. Once we set the stage, we'll be starting the next session straight away, which is another panel discussion on the new chip on the block. We have for the session the moderator, Mr. Ganapathy Subramaniam from Celesta, Mr. Parag Nayak from Sankhya Labs, Mr. Girish Rajendran, Mr. Pradeep Vajram, Mr. Kamal Jain, and Neil Kala from Incore Semiconductors. And this session will be just like the previous for about an hour, and pretty interesting session post-lunch we have been having, and it's very gratifying to note that there's a tremendous amount of participation from you all. So I would request all of you to keep it going and then make it more interesting and more interactive. Before the panelists come over, very quickly, a couple of lines about our moderator for this particular session. Ganapathy Subramaniam is partner in Celesta Capital. He was the founder of Cosmic Circuits, and Cadence later on acquired Cosmic. He's also the chairman of Serial Systems and executive chairman of Idea Forge. Has won several awards in his career and was also awarded the Distinguished Alumni of NIT Trichy. So I would, ladies and gentlemen, please give a round of applause, and I would request Mr. Ganapathy Subramaniam to kindly come over. I would also request the other panelists to kindly come over. Mr. Parag, Mr. Girish, Mr. Pradeep, Mr. Kamal, and Mr. Neil. In the interest of time, yes, I would not take much time on this as we are already running behind schedule. Yeah, Mr. Ganapathy, it's all yours for the next 1 hour. Yeah.
Thank you very much. So, Ajit of SEMI and also the previous speakers mentioned that the semiconductor market is $500 or $550 billion. In this $500 to $550 billion, there are two ways to look at it, right? One way is you look at how this $550 billion is divided in analog, MOS memory, or the processor chips, etc. Or the other way to look at is how much of this $550 billion comes in chip design, the foundry, or the ATMP, or the equipments that do the wafer manufacturing. So it's very clear the largest portion of this $550 billion is chip design, right? So the largest portion of this semiconductor market is chip design, and also equally important to understand the highest value in that is chip design. So chip design comes with the largest market share and the highest value. So, and look at India. In India, we have abundant design skill, right? Our IC design skill is next to none. For example, let me re-emphasize, maybe the audience know this already, the best of RF engineers who are designing the RF chips are today, if I look at the talent of both in the MNC and the fabless startups, we have the best of the RF design engineers. We have the best of high-speed analog design engineers. Some of the ICs produced in India by the multinationals today are used in the high-end base stations, right? And the best of processor designers are in India today. The AI scientists and engineers are in India. We have MOS memory designers. And we have also abundant EDA engineers. So we have the complete gamut of IC design, and thankfully it is highest value. And therefore, I think it's very important for us in India to take leapfrog and dominate this fabless design in the coming decade. And just to again re-emphasize, there are already fabless companies in India which have shipped 50 million ICs, and also there is a fabless design company which is headquartered in India of all the engineering, touching $100 million revenue this year. So apart from the MNCs, we have a significant progress in the startup side also. So with this, I think I should invite and introduce my panel. And I want to introduce with the communication system as a background. So if you look at any communication system, we start with a real world interface, right? The first thing is RF. So my first panelist member I want to introduce is Girish. Girish is an RF designer, and I know for sure he's one of the topmost RF IC designer in the country. So he was an awardee of MIT TR35. Billions of ICs have shipped using Girish's work, both in Texas Instruments and Qualcomm. And yes, he's a founder CEO of a company called Steradian Semiconductor, which brings vision to the autonomous cars. Hi, Girish. So after RF, what happens? So we have got the communication system. First is RF. Once we get the bits from the RF, next we need a physical layer. So physical layer is all about DSPs. Parag is my next panelist, who is the one who created the first fabless company in India in physical layer by defining a DSP. And as far as I remember, he is the first one to get funded, the first fabless semi to get funded by a recognized venture capital like Intel Capital. He raised around 7 million from Intel Capital in 2011 and another 3 million probably from GM. As an investor, we always like entrepreneurs with tenacity. That's something which we really look forward. And Parag is an example of tenacity. During the 10 years or 15 years of his career in Sankya Labs, he has seen the market changing, but he stuck to the software-defined radio and built a very valuable company, and the company got bought over by Tejas Networks a couple of months back. So after the PHY layer, in a communication chip, we have the RF coming to the physical layer, and then we need a processor. So there comes our young entrepreneur, Neil, who is the founder CTO of RISC-V IP company. And he is a PhD from IIT Chennai and from academia directly into the founding team of Encore Semiconductor, which is the first RISC-V fabless IP company from India. So after the processor, as in VC for me, we can't fund any companies if they don't do AI. So AI is must. So my next panelist is Pramod. Pramod comes with tons of experience in semiconductor. He has got nearly 30 plus years of experience. He built a couple of services companies in Spike. In fact, Qualcomm started its journey in India with acquisition of Spike. Then he did SmartPlay. And then he is currently the CEO and executive chair of Alpha ICs, which is an AI company. And finally, once you have the entire chip, we need the SoCs, and we need to build semiconductor system, or we need to build an embedded system with all the software suite. And there comes Kamal, who is the VP engineering of Blaze, which is an AI compute company with all the software engine into the picture. So with this, we have an excellent panel. This panel itself is an example of what can be done in India, right? So we have right from RF all the way to systems with software suite. So with this, I will ask the panelist. Let me also explain how the panel is planned for the next 30-40 minutes, right? I think we are running late, but we will try and do it within 45 minutes. So if you look at any startup, there are few phases in a startup. It starts from ideation, where you kind of think of starting a company with a couple of founders doing your weekend meetings, and then you form a company, then you end up working on funding, and once you get the funding, you work on scaling. Once you got the scale, you focus on your business and customers, and finally, VCs would not fund if there is no exit. The VC engine runs on exits. So these are the 5 phases of a startup, and there are unique challenges for fabless semi for India, and unique advantages also. So we would the way in which we would do is, first I want to have some generic comments from an experienced entrepreneurs who have seen it all, from the initial stage to the exit, on some generic comments on the product status of in the Indian fabless, and then go towards each of the stage and discuss in detail about the challenges of it. So with this, let me go and join them, or I stand here. Start my first question to you. Can you hear me? Yeah. Pradeep, my first question to you. You are a 30 years veteran in this industry. You started your journey with 2 services companies before becoming a CEO of a product company. So please share the experiences and the journey of India from services to products, and how do you see it?
Sure. I think before I start that, Gani said that he's going to introduce us in a different, the first one and second one. And he didn't tell us the criteria, why he's going to introduce and the way he's going to introduce us. He thought, why don't you make a guess? I thought about it, and the criteria was who has the most beautiful hair. I thought I was next to, Kamal. I was so happy. But anyway, I'll take your lining on the electronic side. So I've been in the industry for 30 plus years. I've started in early 19s. When I started in my first company is US-India corridor services company called Spike. When we started, those days people didn't even understand ASICs. They didn't even understand the chip design activity. There was a couple of TI was there with 100 plus. And mostly they were doing library work. From there, and fast forward 30 plus years, what we see now, in 30 plus years, our journey was fantastic. If you look at India is the 3rd largest design talent in the world. And you have a very great culture of startup culture, followed by the VC system. In addition to that, if you look at our consumption for semiconductor consumption, is going exponentially. By 2030, it's about $110 billion. All of these are critical when you look at from fabless semiconductor point of view. In addition to that, I think one of the best things that happened is the current government support for fostering the semiconductor ecosystem, not only the design plus manufacturing and the fab. I think this is the fantastic thing that has happened the last 30 plus years. I could not imagine the better time for especially semiconductor professionals who are connected with India. I think this is, as a part of that ecosystem, I'm very excited is what's happening. There is a tremendous opportunity for young companies to come and start in India, and that's how I see the whole journey.
Super. So as Ajit from SEMI mentioned, we can have a fab, but the fab needs to be loaded. So the fabless companies should be started way ahead of the fab, and we should have many of them. And as soon as the fab is running, we have these fabless companies loading these fabs. So Parag, you are one of the first to raise money in a fabless semi, and you've gone through the entire experience in the last 15 years. Can you share?
Yeah, thanks, Gani. I think while we are on the topic of communication systems, I think Gani is not violating Nyquist. He's taken one with the least hair and one with the most one. So, like Pradeep rightly said, I think the last 25, 30 years, I like to look at it as, kind of debunking certain myths. In the 90s when we started our careers, there is this doubt that whether we could actually build embedded software from, TCS and Infosys went public in the mid-90s. People really knew then we could build financial IT software. Then came embedded software, and the year that we started in 2006, 2007, there was still doubt that whether we could actually build chips in India, conceive. In fact, when we started, there was a lot of, derision in some sense, because most VCs in India thought we were both foolish and brave to start a fabless semiconductor company in 2007. There's hardly, let alone an angel investment, community, there is hardly any VC communities there. 15 years later, now we actually have, at least 5 years, there are 10 more others, I think, that have actually built this, built semiconductor companies. And one thing that the couple of lessons that we have learned, a lot of times, especially on fundraising, it's a lot about psychology more than technology. It's while building technology is very difficult, as engineers, we live in the linear world. The transistor is biased and we are linear. In the linear world, you have an idea, you build a chip, and you sell it, and you go IPO in 4 years. Once you build a chip, what we realized is it's at least an order or two order of magnitude is more difficult to sell it, especially when you're a small company. Things like operations, bad things like operations, sales, and those things come into play. And that was one of the big challenges that we had to overcome. And as we go along, we'll discuss some of those challenges.
So we'll discuss about the VC ecosystem. Certainly the VC ecosystem has moderately improved. I wouldn't say it's still improved a lot in funding the fabless semi in India. But I do see a huge change in the new VC companies coming to fund deep tech companies in India. And especially, I see a huge interest in space now and EV space now, etc. So let's start with the 5 phases of a startup, right? I mean, we start with this ideation phase where you bunch of guys meet in a hotel and keep talking about building a company. And Girish, and one of the challenges, one of the challenges in India is, the risk capital available for a fabless semi was very low when Parag started and continues to be low even today. So the risk capital is low. At the same time, we have to get these engineers from, the MNCs like Intel, Broadcom, Qualcomm, which pays like tons of money. So starting any company is a challenge, but starting a fabless company is even difficult because of the lack of abundant risk capital. In a way, it is also linked to not many successful entrepreneurs in the fabless space from here. But Girish, you had a very successful career in TI and Qualcomm. Your IP was used, or the designs you have done is used in and seen a market of billions of units, including TI and Qualcomm. Why did you come out? What gave you confidence to come out and you will be successful? And you are doing in fact, is one of this world-class company doing a CMOS. I don't know how many of you understand that in the EV space, currently, even including Tesla, uses LiDAR, and you need a optical camera and you need a LiDAR. And both are important enough to give this autonomous vehicle a sense of vision. He is creating CMOS radars, which will make it very lowest cost and make sure that the autonomous vehicles will have a clear vision, and it'll be down to the mid-range cars or the low-end cars. So it's a very ambitious plan, not only just the RF chip, but with all the DSP, etc. So Girish, go ahead.
Thanks, Kenny. See, it starts as an unbridled urge to build a new product on our own. Now, to address a market that we anticipate to evolve in the next 5 to 10 years. Okay? That's the starting point. Now, this is entirely different from defining the next generation of an existing product, where the product market fit is already known, product is defined, right? You define the next generation. This is completely different. It's a completely different, experience, excitement. And what you get to do in a corporate is the second part. Okay? You can define the next generation of an existing product, where the product market fit is already proven. And this was our driving point. Okay? That is what drives, what was a driving point for us, and that is what helped us even hire people, right, to bring in more talent to the company. Now, that's the starting part, and then we need to do a reality check. Okay? The second part is we did a reality check. We reached out to a few CTOs, explained the product concept, and the next step is, their discussions, that kind of brings out the viability of your idea. Right? That is when, you decide to get on this journey.
And also your leadership is quite complete, that you have a couple of guys in RF, couple of guys in DSP and software. And probably you want to say that, did you envision to bring these leaders with the end product in mind?
Yes, to have a team with varying skill set, right? That is very critical. At least you need to have one person who is well connected with the university ecosystem, because without such a good university connect and hiring pipeline, you are not going to grow a company nor build a good company. Second is a business network. Okay? That is maybe one place most of us lacks. Most of the companies that starts in India in fabless space lacks. Right? And of course, maybe once we go into the challenges, I can add a few points there as well.
Neil, you want to add something?
Yeah.
Hello. So most of my inputs are, from a very budding entrepreneur that just came out of academia and joined a startup. So when it comes to the ideation phase, I like to think of it as two parts. One is the tech idea and the biz idea, right? The tech idea, like any other idea, would like to, would has a higher potential or higher survival rate if it stems from something personal, something you can closely relate to, right? And you really need to believe in it. For me, that was, risk 5, or that was something that didn't exist at that point for me to do PhDs in certain areas, right? So you start playing around, and that's where, academia plays the most important role, or schemes like, SMDP from government, which basically give institutes, not only IITs and NITs, but, a lot of other institutes, or Tier 3 or Tier 2 institutes, with the tools, cutting edge tools, that students can actually play around with the idea. Right? You come up with an idea of a processor or an open source processor, and you really want to beat it around, right? You want to try different things, and you want to see how far can that idea really go. And academia today in India is equipped for you to go and try those things out, right? So soon, it turned out not just my problem, but it turned out to be a lab problem and then a department problem. And we played around, we built up a team. We saw a lot of people finding interest in it, and before India's dream of a 64-bit silicon was, a RISC-V silicon was reality, right? And that I feel was a turning point. That's when we were convinced, we have something really bigger than what we set out to do. The second part is the biz part. That's where you want to go around and scratch those gray hairs around you and the experts and veterans. How do you make money out of something that's open source? How do you take this idea and make it commercial? What's the definition of a minimal viable product? While you're doing all of that, the most important part is going to be the founding team, right? You want to have people on board which can contradict you, which can oppose you, but at the end, the mission remains holy, right? You want the founding team to have the same mission, but each of you should have the ability to do it in your own way. And that's what really brings value into a startup, right? Finally, for me, I think, a little bit of personal motivation, a lot of push from my co-founders and my guru, Professor Kamakoti, and a little bit of ignorance of what the real challenges of a startup are. I think that's all it took for me to take the jump. Thanks.
You want to add about Blaze?
Yeah, so first of all, thank you for inviting me over here. And Gani asked me to share a story of Blaze. The idea is not to promote Blaze, by the way. It is to share and give a glimpse of how a startup journey, and in this case, Blaze, has been. And it's not always rosy. There's a lot of struggle goes behind. So I just wanted to talk about the story of Blaze. It has been a 12-year story. 4 guys from Intel, they left their highly paid jobs, very successful. Dinakar, Satyaki, K, and Val. Dinakar and Satyaki are from Hyderabad. And Dinakar is our CEO, Satyaki is CTO, K is Chief Scientist and VP Engineering, and Val is our software architects. And their dream was, the collective dream, was to work on their own graphic processors. And they got some seed money from their family to buy a server, few laptops, initial expenses, and they started that in a garage. And then they started looking for funding. 2 years, and I will call it struggle, because that's the reality. 2 years they struggled to get funding. And they used to visit every day to investors for 3-4 hours, together in a car, and there they used to discuss about the product, came up with a lot of ideas. And 2 years later, Dado Banato is a well-known figure in Silicon Valley. He decided to fund Blaze, and that's when Blaze started their journey in India. With 10 engineers, used to be called ThinkEye earlier, for the last 2 years it's called Blaze. With 10 engineers in an incubation setup, with a lot of good ideas. Those engineers used to, sit together, share ideas, discuss, came up with a lot of ideas to improve the chip. And finally, there was a chip which was ready in terms of the design. Obviously, the fab is very expensive, so initially you had to work on the design side. And that chip was ready, and what they realized, the market in the graphics was actually in saturation. So in the hindsight, they realized that they should probably have had a business development guy or a team to feed them, which way the market is moving. So basically they had the very powerful chip in hand, but not enough market available. Luckily, in 2014 or so, neural networks and computer vision market emerged. And Blaze, for Blaze it was a good news. In fact, even better news than the graphics market. And so Blaze was ready to show the power of this chip in the industry. They also needed software because your chip would not work without proper software. So they had to do from the scratch a lot of good ideas, even to improve the hardware. And then the chip was ready and start giving competition to the biggies. Couple of more years, after initial, funding, you basically burn all your money soon. So there was all discussion with initial investor. Dado was very helpful. Other investors were very helpful. So Denso and Daimler came together to work with Blaze. So Daimler, I guess everybody knows. Denso is a well-known figure in the automotive domain. And we gave our first board. So basically in 2016, we got the first chip ready. No, it was a physical chip. And then we gave our first board to Daimler. And our first paying customer was Denso. We worked with them, and they supported, and then, Denso became our investor for Series B. So that's a beautiful thing. If your customer become your investor, that's a testimony of, how good your product is or how good the team is. And I think after that, Blaze didn't look back. We had Series C funding, Series D funding. So far, we have actually more than $130 million of funding. But let me also talk about the product, what we build actually. So what we have is a graph streaming processor. It's a proprietary architecture. It's an AI processor, for edge inference thing. And today we saw 60-70% of data is going to come from outside the data center, right? So edge inferencing is very important. This is the first graph native processor. So you heard today from Jim that processing graph is very, very important, and GSP is the first graph native processor. It's a fully programmable. It gives a lot of flexibility. The way it processes graphs actually does not require access to too much of external memory. What it means is the latency is very low, efficiency is very high, it's a low power requirement. But as I said, the hardware is not sufficient. The software side, we have a SDK which is called Picasso, which optimizes the application for the hardware. But along with that, what we also have is the AI Studio. This is the first no-code AI application development framework in the world. So what it means is you don't need data scientists or AI ML experts. As long as you know your domain, you want to develop an AI application, this framework would help you to build the application, choose the models, fine-tune, train, and then deploy on the hardware. So these are, the world-class products which came out of this team. I'm also proud to say most of the engineering work happened out of Hyderabad office. So we have completely that processor team in Hyderabad. The SDK team is in Hyderabad. And I think this is a testimony of the skill set, the talent that we talked about.
So,
thank you.
See, as a VC, I look at fabulous companies or deep technology companies from almost every country which is doing deep tech work. One of the challenges I see in India is that's what he probably reiterated also. So he took some path, he had to take a different path because he didn't have a business guy in the team. as a founding team, still in India is started by technical people. You know, the best of the technical experts in India come out of the MNCs and start these product companies. I think as a fabless company, we need to start thinking of including a business development person or a business person way ahead in the cycle. And I see that by the way, I see it in China, right? And we have invested in companies in China where there will be one founding member from Korea, one member from Taiwan, and together they give the right business inputs to the team. So this is one place, just like the fabless companies in the US have large operations in India, the Indian team should not hesitate to go and hire this business guys from whether it is China, Korea, Taiwan, or US. This is something I hope will happen more and more in the future. So now we talked about, I also want panelists to be sharp with their time. You know, we are probably having another 25 minutes max. So we talked about the ideation phase where you started the company, but the next important phase is convincing a VC. And Parag said that it's a psychology also. So I want the young entrepreneur Girish to say how he faced the funding, because the risk capital is still not in abundance in India compared to US, definitely not compared even to Israel. So we have a challenge in funding these fabless companies. So how did you do this, Girish?
So, yeah, Kamal mentioned that Blaze, when they started, spent 2 years without any funding. It reminds me our story. We started in 2016. The first funding we got was after 2.5 years. And during that time, we spent our own money to build a chip. So, of course, funding is a challenge. And the challenge is, we lack the history of fabless semi to inspire confidence in VCs. We lack that history. And this has to be built. And why is it so, right? So if you look at any advanced semiconductor device, the end customer is not in India. Okay, maybe for an old product, an established product, agree, there are end customers, manufacturers, system companies in India, but not for advanced semiconductor products. Okay, end customers are not in India. Now, if your end customer is not in India, it's extremely hard to create a pool of founders who can define new products that fits the market sitting out of India. Now, there are two ways to address. Maybe once we go into what are the suggestions we can go into, but this is a primary challenge. Without a history in fabless semi, it will be a challenge. Okay? So as we create a bigger pool of founders who are successful, a bigger pool of VCs who have seen the exit, of course, things will improve.
To be honest, I don't buy the logic. While I agree with that there is a problem of we don't have a market in India. It's an accurate argument. But look at Israel. Israel doesn't have a local market, but they have successfully produced many fabless companies. So I think there is something more in creating fabless successful company. Lack of market, I completely agree, is an important problem. And China did it in their own way. China created local companies with local market and then went abroad, right? And then went global. We don't have that luxury in India today, right? We don't have electronics company consuming the chips that is done by us. But at the same time, there is an Israel model which has successfully created successful fabless companies, and their local market is almost nothing. So Pradeep, you want to add?
Yeah, I think I agree with you. I think local market will help, but not necessary. And the example of Israel is a very good one. What we have seen, the typical problem we face, the challenge is, number one, fabless semiconductor investment is very patient capital is required. It's a long drawn process. That's number one. So today what we have in Indian ecosystem, the companies, if you look at other startup ecosystem, which are not a typical semiconductor, e-commerce or SaaS companies, they are going in a year or 2 years, $1 billion companies. When the investors have a market, when comparing a semiconductor, which takes a long process and it's deep pockets, and the choices are, from the investors' point of view, it's become a challenge for semiconductor companies. In spite of that, I would say there are a handful of VCs. India is there, 314 is there, Rebright and Startup Speed. They've been helping deep technology companies such as us. I think we definitely need more of those to be successful. And the only way we can do that is by having a success story. I think once one success story is there, I'm sure many of the VCs would change and how they invest in semiconductor companies.
Yeah, I think Gani, part of the problem is also because your business model is technology, right? So how does one evaluate technology as a business model? Either you are deep tech, you know the technologies. For example, in our case, we had been talking about programmable DSPs and programmable L1 15 years back, 15 years back, which is playing out now. Now, a VC most often in India don't have that operational experience to go through that, right? The second class of people who only invest is when they trust you, when they have blind trust in you. So in our case, we raised money from, one of the first fabless semiconductors companies in India. You would have expected, a whole bunch of Sequoias and all these guys to invest. But we had, I fondly call them the NH4 angels. NH4 is the highway connecting Bangalore to Pune. All small villages and towns around these companies, around this road, actually invested in us because they really believed that we'll spend their money wisely. So those are the only two kind of investors that you will actually get it. And what happens is the angels can't scale to the next level, right? That's another challenge. The other problem is, I don't completely agree with you. We don't have an ecosystem, right? Since we don't have an ecosystem, and as part of the ecosystem, while we have great talent, right? I think we have waxed eloquent about how we are the largest supplier of people for semiconductor industries, but we don't have a buyer. Once you have a buyer a buyer mindset is a bit different. A technology buyer mindset is very different from a normal buyer, right? A new technology, sufficiently new technology always needs to be pulled out. It's 70%, 80% ready, but how do you take that 70%, 80% to 100%? So the buyer has to be very tolerant and has to see through the clutter and see through that. And that is not existent, and that creates a challenge. And I agree with Pradeep that some exits will help, the overall incentive to do a fabless semiconductor company is not there. All of us started companies, I'm sure, because we are passionate about it, right? Not because we are going to become billionaires in it. Sometimes it hurts to see, all nephews and nieces of ours going and selling chicken and selling underwear sorry to use that word, on the internet and make billions of dollars. Then if you're incentivizing the next millennials, somebody talked about it, to buy and sell on the internet, they're going to do that. So somebody has to take that initial risk, and that's where the government probably has to step in and probably create a fund and then have a few success stories, and then you will probably get a bigger ecosystem.
I've been an entrepreneur and a VC, and my observation is Indian fabless companies should start thinking about a founding member with business right from the start, because we are addressing a global market. It's not an India market.
Absolutely.
Just like Israelis, let's have a great business guy to articulate clear business, and that should help the VCs to some extent. And the second, I also feel that lack of risk capital is the biggest obstacle for creating world-class fabless companies. I'm certain if a company of Sterity and Semiconductors with the expertise like Girish and his team brings in Israel, it gets funded. It gets funded very easily because the risk capital is there. And we need to get more risk capital into the country. We see some seed investors, some amount of mid-tier investors, but we really lack large venture capitals coming and backing the fabless companies. And the fabless companies, as I said, should also go and include business guys globally to convince the VCs.
So one last point, Gani, sorry, I couldn't resist this. I think part of the problem is also we are not able to articulate our USPs, right? Like, somebody, to be fair to the internet commerce guys, it's very easy. It's very easy to, reduce it to 2-3 numbers and bring a valuation. Now, how do I tell somebody that, I'm going to build a programmable L1 that's going to, this unique heterogeneous multi-core domain-specific architecture that's going to revolutionize the world? It doesn't work. So that's the problem that we have.
But deep tech investors in general is tough. That's a problem universally. If you look at US also, they have the same problem in deep tech side, but there are, as rightly said by the panel, there are sufficient entrepreneurs who have made successful companies who solve that gap to some extent.
Just one small example from my very early days before Incor was even registered. We were talking to a couple of VCs, and the VC liked the idea. He liked the pitch that was going on, and he said, I'll put in the money, but only if you bring in a brick brother who understands the tech, right? So he liked probably the way we pitched it, but he definitely didn't understand what is going on, right? And that sort of resonates with what Parag was saying, that either we are articulating too much or we're not articulating enough, but there is a need for someone to look for some big brother, and the big brother issues are different.
Yeah, I agree. So we talked about the ideation, which is formation of the team. We talked about funding. The next is actually scaling, right? I mean, how do you really scale? Scaling is just not adding talent. It's securing partnerships with, for example, I think for Indian fabless companies to get the latest PDK from TSMC will be a challenge, right? To get a largest ATMP partner to work with you is a challenge. So you have multiple partnership issues, etc. But that's a very large topic. In the interest of time, to be very honest, I'm going to skip that scaling portion of it. And then I'll come back a little later if there is time. But the other aspect which I see is an obstacle which is already articulated by the panel is customers. As an Indian fabless company, you are solving see, there are two kinds of companies in my mind. One is like the China model, where they create an equivalent of a Texas Instruments part or a ADA part, and they create a clone of it. They have all the electronic manufacturers there to buy those products, and they very quickly become successful, and then they don't stop there. They continue their innovation engine and try to do, some companies at least become global companies, while many probably stagnate because of that model. Right? Let's say that we call it as a China model. But I'm not saying that it's limiting, but all I'm saying is they take advantage of the local market. The other market is the Israelis, the US, which is a totally deep tech, innovative, and it's a global market. And Indian fabless companies sitting here, at least in my mind, belongs to the Israeli model and the US model, where we are doing technology for global market, which means our customers are not next door. We have an ecosystem problem, right? So can the panelists spend some time? How do they address? And let me start with Pradeep. Can you tell me how do you address for your alpha ICs? Because all your customers, I believe, will be outside of India.
Yeah, so obviously the money plays a very important role when you have limited funding. You have to use your money very wisely. What we have done in cases where you can get your customer as your VC, that's the best thing that can happen. And in case of Blaze, I think that was one of the best things that can. If you can do that, the only other way you need to do is establish the partnerships. In our case, what we have done is the CBC is a distributor, one of the largest distributors in Japan. We can't really afford to have sales teams in Japan or in US. That's really a very expensive proposition for us. So in Japan, of course, CBC also invested in us in the last round. So we have to strike the deal with them to represent us in Japan market. They're doing a fantastic job for us. I don't think we could ever dream of doing something like that with our own money. That will be expensive. In the areas where we can't invest, obviously the burden falls under the founding members. So I've actually traveled to US quite a bit just for the sake, to connect with the customers, to connect with our ecosystem and see what best we can do. There's no two ways about it. And alternatively, you get a founding member, business connections as a founding member, that's another way. So it's, in our case, we have established the partnerships.
Do you have an office today outside of India?
Yes, we have a US office. Yes, absolutely, we have that. In Japan, CBC is our key partner. They've represent us in AI conferences. They go after the customers in Japan. It's tremendous help for us, especially as a startup company. It's amazing.
Girish, do you want to say how did you do the business of your company?
Yeah, reaching out to customers, since we do not have a business center outside of India, it ends up as founders traveling and meeting the customers, right? That's the way we build business. And as some of the customers invest in us, right? That is what looks like, I notice invariably that has happened, because they have a lot more confidence than the VCs to invest in fabless semi from India. So that kind of helps you have the investment money as well as the business links open up through them.
Okay. Parag,
yeah, Yeah, so we've done multiple things. I mean, like Pradeep said, we've had sales offices in the US, in Taiwan, partnerships in Taiwan, reps in Taiwan, Japan, and other places. But we also experimented with business models, right? So a lot of times we've got into partnerships with potential competition to have joint IP development. In fact, in our case, we've tried every gamut, every trick in the book to stay alive for 10, 12 years, and that's what you try to do, right? We've evolved business models, joint partnerships, and then also try to do fab-light models, more than fabless, fab-light. In our case, since we don't, it's very expensive to keep a physical design team and the tools everywhere. So we, off late, this is VCM model, right? So we had a lot of basic design partners who take our netlist and give us a chip out. Things like that we've done, and these have been all over the world, not just in India.
Yeah. So because of the lack of large capital, I think partnership and associates may be the way out. Since it's an important topic, Kamal, can you also add how Blaze is doing this?
Yeah, so I think we have basically representation in almost all countries. We did invest in like having office in Japan, Taiwan, Korea, Europe, US. But I think a lot of burden, as I think Pradeep said, comes to the executive team. They can connect to the business, but getting business, a lot of people, engineering resources have to spend a lot of time, understanding the need, giving them something different that, we don't have today. So I think it definitely takes away a lot of resources, not just from the sales or business team, but also from the engineering team.
Yeah. I think I sort of agree with most of the points that my panel members have put up, right? So those are also things that we are trying to explore as setting up offices or setting up partners that, either on the West or the East in order to expand. But the kind of partnerships that you want to build as in a very early stage startup, you want to think why India, right? Whether your customer is local or foreign, your partners should have the ability to sell the idea of you want to do something in India, right? And those are the partners, because when you're in as early stage as Encode is today, right, 2 or 3 years into it, there are tons of things that it takes to get the first MVP out, right? The minimal viable product. You're going to do logic design, logic verification, physical design. You want partners which can complement your skills, right? You want partners who can, reduce the risk of your product. They can reduce the time it takes to, go to your product, and most importantly, add value to you, right? If you're able to convince your partners that, this is what it takes and this is what we can do very well, you can then go off, offshore, you can go to, whether it's the West or the East or even local. Once you answer why India, that you have a, some sort of a chip ODM model along with your partners, it's a one-stop shop where your IP and your partner's IP can actually talk to each other, right? It's not just the CXOs talking to each other, it's actually your technologies talking to each other. Those are the kind of partnerships you want to focus on. Those are the kind of models you want to explore, other than, the sales channel. I think, everyone's elaborated, and those are things that we'll have to do based on the current situation. But, alternate partnership models beyond sales is also something that we should be exploring.
Yeah. So one last point, Gani. I think it's important that one of the founding team does it, because nobody can sell as passionately as, as a founder. And I also don't believe that good salesperson. I mean,
you can do now if it is of the same topic.
Sorry, my question was about design-linked incentive. There's a policy for that, right? All of you are eligible to get those design incentives. Is that not enough capital, including the VC capital, for you to then be able to hire the BD offshore, say in USA or wherever your market is, which is what, by the way, Ganpati, you are bringing up a very good point. They do it, but they have enough capital to hire people in USA. And what I'm hearing here is, we also want to hire, but we don't have enough capital. So I'm just trying to get back to the risk capital. Is that not adequate?
So, I mean, I don't understand the full totality of the design-linked scheme, but I still think that number will be far less number. See, for example, you've done so many fabulous companies with your investment. To build a successful company, you need in tens of millions of dollars, right? And you say, I want to start a center in Taiwan, Korea, and also US. The capital requirement is a lot more. I think the design linked, if I understand right, is largely related to producing the chip, not probably with respect to the support of sales, etc. But I may be wrong.
Yeah, Gani, I think.
You're absolutely right.
Oh, sorry. Okay. It's basic.
No, so Ganpati, let's assume for a minute either you haven't understood it or maybe it's not clear enough. The design-linked incentive part is supposed to do exactly what you are saying is difficult to do, which is to help bootstrap a fabulous company or a design company, whichever way you want to characterize it, and allow them to go to a stage where they can bring in viable commercial capital. Now, currently it's $2 million. It would be interesting to hear from you, your point of view about whether that should be 5 million, 10 million, instead of saying that just is not part of the equation. Because if we start with this basic premise that there is scarcity of risk capital, and the government has recognized that and put out in the policy saying, we will bring in this capital, and the amount is 15 crores or 2 million as the case may be. Maybe then the response from you should be, look, let's move the threshold up from 2 million to 5 or 5 to 10, and then take the company to be at a stage where it has a critical mass to raise commercial capital.
Yeah. Okay, So just to
Interested to
answer, let me answer quickly few things, right? One is, you are absolutely right. First is, a startup should have a certain capital to produce a proof of concept to attract a customer also. So that certainly in this range, but by the way, fabulous is like all kinds of fabulous are there. There's an analog fabulous which requires small money. There's a processor fabulous which requires tons of money. So this risk capital, how much is required to provide the proof of concept varies depending upon the type of companies. But that discussion we will do it in later. But let's say I want to get a good business guy in US, for example, to build my business. That's a $500,000 annual budget.
Minimum, yeah.
As a startup, can I afford a $500,000 budget? That's the question I have, right? So the way to do this, which I'm seeing in other startups is, so if I'm starting a fabulous company, and if I know my customers are in Korea, Taiwan, or in the US, before starting the company itself, I should be thinking who are my founding team members. And I should get these guys in those regions. And once you get these guys in those regions, because they are founding team members, the expense goes down. So there's multiple ways to solve it. And I think if you have to progress like an Israel company or a US company, the risk capital definitely has to improve. Definitely there is a scheme from government which is helping, but we also have to have the venture capital system to come up to fund these companies.
Sorry to belabor this point. We really want to help, okay? But we're trying to understand.
Yeah. So right now, as I see it...
Hold on. The issue is, for business development, whether it's $250,000 or $500,000 you need in US, I agree with you. But initially, the startup capital, which is what the government is providing some incentive for, whether it's 2 million, 5 million, I agree, it's a function of what kind of startup you are in. And we can have that discussion, and maybe we can change the policy to even tweak it by definition of the type of product, okay? But I still maintain that once you have built the prototype, which is what the government is assisting to, then you should be able to not only get the customer, you should be able to get venture capital or whatever other capital from other people. If you're not getting that, there's a problem. Either you built the wrong product or whatever else is wrong with the company, I don't understand, right? So that is one thing. And second is the business development initially is the task of the founding team. Yeah. The CTO and the CEO are everything. वो झाड़ू भी लगाते हैं और जाके वो सामान भी बेचते हैं, right? You have to do all of that. So I'm still at a loss to know why do you need more money at that stage?
Okay, I will answer this and then give it to the other panelists who are also very interested to answer the same question. Very pertinent question, right? First is, let's take an example of what has been told by one of the panelists. So to build a product, to sell a product to a VC community, a CEO and CTO is a great marketing, a guy who can articulate the technology well to get funding. No questions on that. But what should be the product? You need to have solid business insights. For example, if I'm building an analog power product, I need to have somebody who has been selling this to Foxconn or Apple or some of these big companies to give the right input to me on what type of the chip I need to design. And that comes from business intelligence. So if I lack that business intelligence, just like the example he quoted, I will lose a valuable time cycle. So it's very important. I sincerely think we should have a business guy with deep connecting to customers right at the start of the company.
So just to add to what Gani said, what happens is, what you say is true for merchant silicon. So when you're building very custom silicon, right, the data sheets of these are guarded like national secrets. You can't just get them. And you have to have the right, especially if you're playing in the consumer silicon, which we played initially, you have to get all the interfaces right. The number of pins in the chip, right? If you miss there, it's a matter of 15-20 cents and you lost the business. So that's the challenge. Sir, coming back to your question, right now, from the way I understand the scheme and then the way we've interpreted it, it's more like a reimbursement scheme. So you get reimbursed 15%. So you have to spend the 100% to get the 15%. So that's a chicken and egg there. So the money is not given upfront, right? So that becomes a problem.
Yeah, there may be that in the wording, but the principle is very clear that we want to invest in startups, provide that capital as bootstrap capital so that it goes to a certain critical stage in the growth of the company. And then the company is at that stage, if it is successful, it raises private capital, risk capital or not. So I would be happy to hear your views on this, on the threshold number, if there's any rewriting that needs to be done.
Yeah.
But clearly in the 76,000 crores, there is provision for almost more than $100 to $200 million to just invest in the design and innovation ecosystem, just so that you know.
Per company, it's $2 million, and it's we'll again discuss offline on this.
Yeah, let's take this offline. But I want to go to the because the panelists, they are signaling me to end this session.
I have one
second.
important
the
missing customer.
Just 1 second. Yeah. So Vinod made 2 points, right? One is about why do we need business? We answered that. The second question is a very pertinent point. The government should help me to bootstrap. That's all. After that, I should self-sustain. The engine should be running by itself. Then only it's a successful model where it will run by itself. Because constantly I cannot expect bonuses or the grants. The VC ecosystem, you are absolutely right. Once I have the proof of concept and if I've defined it right, the VC ecosystem should be mature enough to start funding these companies. Today, it's a honest truth that we lack a fabulous semi-VC ecosystem in India, which people like me, successful entrepreneurs like him, should focus on and parallelly work with the government and start this engine also. So it's very important the VC ecosystem in India should become mature enough to identify the startups and start funding. We'll take one question and then I need to end the panel.
It's actually sort of little half-a-minute motivational stuff. You see, I'm the chairman of the India Cellular and Electronic Association. So I make a statement, hand on my heart, that this fabulous design is the most valuable investment the nation can make. Now the missing customer. I completely disagree with you about the Israeli model. India is going to have global domestic champion companies in every sector. Smartphones, IT hardware, laptops, hearable, wearables. That is something which Rajiv ji has not unraveled yet. So that will be a very strong support to you. You have to be in the middle of that ecosystem. You have to ensure that when a lava has reached a level, he should not be, using chipsets outside of that, or at least, there is a headroom for you to enter. So there is a very large opportunity. Out of this 300 billion, at least 50 billion will come from Indian champion companies.
It will, it should.
So that is a very good 10 billion, kind of headroom available for you. So the customer is not missing. You've not seen him yet.
Yeah. So, and again, sorry, we are running out of time.
We are running out of time because, I think otherwise he's going to put me out now. But anyway, so it's a very interactive panel, good questions, and we had a good interaction also. So I want to thank all the audience and panelists for an effective conversation. Okay. Thank you.
I would like to thank all the panelists. Well, after a total physical panel discussion, we'll have a total virtual discussion, and thereafter it will be a hybrid, so virtual plus physical. But now this particular session is on the fireside chat on emerging designs, so driving the semiconductor demand. We have Professor Kamakoti, the director of IIT Madras, Chennai, and is indeed the R&D leader in processor design as India's chief RISC-V architect. And along with him, we have Professor Dave Patterson, Pardee Professor of Computer Science Emeritus at Berkeley. And Professor Dave is regarded as the father of computer architecture, and he, along with Professor John Hennessy of Stanford, wrote the most definitive book on computer architecture, and is also the inventor of RISC-V processor architecture. And now, for the next half an hour or so, this will be the fireside chat on this particular subject of emerging designs driving the semiconductor demand. And let's have the videos, please.
Dear friends, we have with us Professor Dave Patterson. Professor Patterson needs no introduction. He is one who made computer architecture and who wrote computer architecture. Every serious student of computer architecture globally must have studied at least one of his books. Thank you very much, Professor Patterson, for agreeing to be part of SemiCon 2022, India's flagship international semiconductor electronics meet. Now the topic for thank you. The topic for today's discussion is emerging designs driving the semiconductor demand. So, as an initial discussion, in your decades of deep association with semiconductor electronics, we would benefit from your views on the changing landscape of electronic designs over decades, say in the 1990s to 2000, 2001 to 10, and 2011 to this. We would be very happy to listen to your views on it.
Okay, well, certainly the biggest change is the ending of Moore's Law. It was just, for basically my whole career since I was a grad student, Moore's Law, up until basically about 2010, Moore's Law helped, right? We could have twice as many transistors every year or two for decades. And so I always kind of marveled that how fortunate I was to be in the computer industry, where we have this amazingly fast-changing substrate to build computers out of, as opposed to, suppose we'd been in the television industry or something like that. It's very slow progress, how different it must feel. And for those who weren't active at that time, computers were improving so fast that people would throw away, at that time, it wasn't laptops, it'd be desktop computers, but that were perfect, there's nothing wrong with them, but that they were just 18 months old and they were jealous of their friend's computer because it was so much faster and they get their work done. So you had to buy, you wanted to get rid of that one. So the hardware was just being, the churn was tremendous. And now you imagine with a laptop, almost, I mean, I think I replaced my laptop when it breaks. I don't think of it as speed as being a differentiator in laptops. So it was just an amazing time that that's happened. That was certainly by far the biggest change. And so as Moore's Law started running out of steam, we had to come up with other things we could do rather than just having the world's, a uniprocessor, single processor computer that was twice as fast every 18 months, which was fantastic for software people. They would just add more features to their software and just wait for the hardware to make it go fast, so they didn't have to rethink their application. It was just a kind of monofilm have it just what they wanted. So that changed in the 2005, 2010, where the cores themselves couldn't go faster, but we could put a lot more cores on the chip. And so that was the switch from, single processor, single core to multi-core. And it wasn't done because we had a breakthrough in programming technology that made that easy to use. It was done because we didn't know what else to do in the hardware design. So I'd say in the next transition is probably 10-ish years later, where we're kind of running out of things to do with cores. How many applications take advantage of many cores? And so we've shifted to this new stage of domain-specific architectures, that if you really want to have a giant gain in cost performance, that the way to do that is to design something that only does one domain really well. It's exceptional at that domain, but it doesn't have to do everything like general purpose microprocessors. So what that means is domain-specific architectures will help narrow pieces of the computing industry, where before, with Moore's Law, it was like the tide that lifted all boats. Everybody's programs got faster every 18 months, which was really fantastic, but we can't do that anymore, so it's going to take big changes for software and applications and expectations of people. Many programmers still believe Moore's Law, it must be true because it held for 40 years. It can't possibly be ending. You architects are wrong. Go back and give me a fast-changing processor, but that's not an option. There's nothing to do about that.
Sure. Thank you. So you have been a very strong supporter of domain-specific architectures. What do you think would be the major domains that would come up here in the near future?
Well, the ones that, there's kind of, I think the two exciting pieces of the computing industry are kind of at the polar opposites, right? It's the cloud, and that's where I'm at Google. That's where I do a lot of work, is in the cloud. And the other one is at the edge, is where smartphones and embedded devices. Those are the two exciting spots there. And you can do domain-specific architectures in both pieces. And interestingly, both pieces care a lot about energy. Energy is really important for both the cloud and these battery-operated edge devices. And so there's benefits in the cloud of using the tremendous energy that's in a data center more efficiently, so get more cost performance by more performance per watt. And on the edge, because you typically are driven by battery life, you want to get the best value of battery life. So it makes sense to do specialization in both areas. Kind of interestingly, the domain-specific architecture is done earlier in the edge. So the modern cell phone with the systems on the chip has a wide variety of what we call intellectual property, or IP blocks. All kinds of gadgets are on there because they compete on when you buy a new smartphone, why are you buying it? Well, how much better is the camera? How much better does it play videos and things like that? And a way that they make better cameras and play better videos or play better music is to use custom blocks on that. So kind of the edge is ahead of the data center in terms of domain-specific architectures, but since we have no choice in the cloud, we're seeing domain-specific architecture starting to go there. You asked about what areas. The one that everybody talks about today is machine learning, specifically deep neural networking within machine learning. And so Google's been building hardware to accelerate deep neural networking part of machine learning for almost a decade, where we put custom chips and their domain-specific architectures for machine learning, and as well as many people, including Google and its Pixel 6 phone, have dedicated domain-specific architectures for machine learning in there. So that's the one that everybody knows about, and the reason it's been so popular is because this application of machine learning is relatively new, kind of also just about 10 years old, where it's been around forever, but it started having real significant gains about 10 years ago, which meant that there wasn't this huge legacy stack of software. It was kind of brand new, and it's also, the machine learning code isn't that big. It tends to be modest number of lines in these high-level languages like TensorFlow or PyTorch. So it's not lots of lines of code. It's kind of greenfield. It's not brownfield. It's not like legacy code. And there's all this excitement about machine learning, and it's very compute intensive, so we need special processors. So that's kind of the poster child for domain-specific architectures. And I think it's been a major success. Going back further in history, we didn't think of it as a, it wasn't graphics processors, GPUs. They've been around for a longer time. Now, it wasn't that CPUs weren't getting any faster. It was that you could make graphics processing, pretty pictures, so much faster with dedicated hardware that made sense to do. So graphics processors are a historical precedent of things being done. And what's happened more recently with the graphics processors, because they have a lot of compute power, particularly floating point operations and not very much silicon area, they first got kind of migrated from graphics into high performance computing, and then to the great fortune of the graphics processor companies, about 10 years ago, people found it was kind of the best silicon to doing machine learning, which was very floating point intensive. And so to their great fortune, people have also been using GPUs for machine learning. But those are the two kind of most successful examples of domain-specific architectures.
So we come to one of our favorite topics, RISC-V. I'm very happy to tell you that India has started a digital RISC-V initiative, Digital India RISC-V initiative. We call it DIRP. It was announced a day before by the Honorable Minister. So we have been a great fan of RISC-V, and we've been implementing RISC-V here. So we just want to understand what was the prime motivation for the RISC-V effort which you led up, and specifically trying to make the ISA open source and also on a PSD type of license. So it will be very interesting to listen to that. Yes.
Yeah, I'll try and tell you the story. So it was certainly, my name is associated with it. I helped, but primarily Krista Asanovich is the main faculty member involved, and then two graduate students who I guess Krista and I supervised at the time, Andrew Waterman and Yunsup Lee. Those three deserve more of the credit. I think what happened is I told them a story that in the 1980s we did 3 generations of RISC projects, and I wished I'd called them, I guess we did 4 generations. I wished I'd called them RISC 1, RISC 2, RISC 3, RISC 4 in retrospect. That would have been a better marketing thing. And I said that, told them that story, and so when they revived RISC architectures and tried to do a brand new, really great RISC architecture in the 2010, so like 30 years later, they said, well, let's call it RISC-V, right? It'll be built on that Berkeley legacy, and so I think it's called RISC-V. I'm getting a larger share than I deserve. But in 2010, we were starting a big major research project. It was funded by many companies, including Intel, around the parallel computing, around the shift from what I told you about, from single processors to multiprocessors. We had no choice to do it, and yet the software wasn't ready, and we were doing a research lab on it. Well, part of that was to do computer architecture work, because we knew in 2010 that we're going to want to get into domain-specific accelerators. We knew that was going to be the future. So we were going to do architecture work, but we wanted to enhance it with domain-specific accelerators. So that was the plan. So we looked at the existing instruction sets, and the 2 obvious ones were Intel's and AMD's x86 architecture and the ARM architecture. Those are the 2 obvious ones. Well, they're not very elegant architectures. They're popular, but they're not elegant. They're often very complicated. Lots of stuff that they don't need that's been included for historical reasons over time. But setting aside the aesthetics, even because they're very popular, so that would make sense for us to work on them. But we weren't allowed to. Proprietary, they're owned by Intel or AMD, or they're owned by ARM. And even at the time, the companies were very sensitive about anybody outside trying to use their architecture. Even though Intel sponsored our research, they wouldn't have let us do it. So we were forced to do something new, and I think we also thought those other architectures weren't a great foundation. So we decided, Krista and Andrew in Yunsep decided, well, let's do a brand new clean slate architecture. Let's not be left any baggage over. Now, kind of the Berkeley tradition is to build things and share them. It goes back to, as you said, the Berkeley software distribution, BSD Unix. It even goes beyond that. If you know electronic CAD, there's the SPICE program that was, back when programs were in punch cards. Berkeley's been distributing software. That's been our tradition, feeling that we could have bigger impact if we gave it away, and then, than if we started a company to sell it. That's kind of the Berkeley tradition. So we thought in 2010, naturally enough, we would make it open source. And what our target audience was, we thought, was people like us, is if we were going to put all this effort into a brand new clean instruction set architecture, well, this would be a great foundation not only for our research, but for, at Stanford and MIT and all other universities. That's what we were thinking. So we made it open source. So as it turned out, almost no universities were interested in it. So we worked on it for 3 or 4 years. It got a lot better. We were using it in our classes and courses. But other universities, they wanted to have the real thing. They wanted to either work with ARM or Intel because it was commercially viable, and this was just this Berkeley thing. Well, then I think it was you, specifically, and then some other companies said, well, we would really like to have an open instruction set that anybody could use around the world. That would be, for a lot of reasons, that would be attractive, and just not for our research, but for commercial reasons. You don't want to be vulnerable to somebody buying the instruction set, or and changing the instruction set, or getting new owners, or having the flexibility to expand it, which we were going to need. So I think your group was one of the first to reach out to us and ask about, because you could go to our courses and read our papers and see about it. You started asking questions about it, and then a couple of other companies. And when we asked, why are you concerned about our internal architecture? You explained that there was this kind of worldwide need for an open instruction set, and RISC-V was a very good foundation. Then we thought, wow, that's a great idea. So then we wrote, I think, Kristen and I wrote a paper that I think the title, Instruction Sets Want to Be Free, the Case for RISC-V. And that actually, as we know now, caught on. That made the arguments of the advantage that you didn't have to have proprietary instruction sets. There's been benefits in the software side to having open standards. Why not go into that in hardware? And that argument caught on. And then we tried to, imitating like the Berkeley Unix and the Linux foundations, set up a foundation to get it going and try and make it happen. What can we do to increase the chances that we really could have an open architecture that everybody could use? And that's the origin story of RISC-V.
Sure. It was fantastic, and I think we all enjoyed doing this project, and especially when the first silicon booted and we booted Linux on that, then we really understood how powerful this has become, and the extensibility, as you say, has been extremely phenomenally useful for customization to different needs. Thank you very much. Thank you, Christy, and thank you, Dave, for this.
Right. What it turned out was, because we thought it was possible to expand the instruction sets if we were careful.
Yes.
And what the conventional wisdom was for Intel and for ARM is they insisted not on kind of compiler compatibility, but what we call binary compatibility. And what they were worried about was fragmentation, that some customers would have some, and so that would be, so they prohibited it. It was just, the past had been binary incompatibility was the death of microprocessors. And so we, not only were we open, we, encouraged people to customize. So it was a very contrarian view of how instruction should be done. And here we are, I guess 12 years later. And people, like you said, the customization is very popular today.
Yes. So very interestingly, we also did, just for the fun of it, a decoder for the x86. The area consumed by the decoder was close to our 5-stage pipeline entire processor. So, so that was the very interesting observation.
On that line is because there's a bunch of RISC processors. A few people have, x86 is very unusual, and that's really hard to do. But a lot of the RISC processors are similar. So people have built instruction decoders that can handle multiple instruction steps, presumably ARM or MIPS or besides the RISC-V one. And that's because there's the similarities in the general RISC designs, that's not impossible, right? That's something that people can do, and I think some people are doing right now.
Yes. So India has now announced a $10 billion semiconductor mission to encourage, chips to be done and to strive the semiconductor industry in India. And as you know, India has the largest consumer market. So what, in your opinion, could be the steps India as a country could take up to make this mission successful?
Well, so kind of starting at the bottom, the easiest case to make for RISC-V is in Internet of Things or embedded devices, low-cost devices. They are power sensitive. There's arguments about RISC-V being better in that space because of code density and the simplicity of the architecture and the subsetability that's very attractive for embedded. The fact that it's free, so that could bring the cost down. And the customization. A spot where customization really works well is when you have a dedicated application and you care about either cost or battery power or something like that. So it's just a perfect match. So that's a natural place. So I think the next step above that, in talking to you in the past, I think would be automotive. I think you have a automotive industry in India that is targeted for the India market. You have more than 1 billion people, so that's a large market. And increasingly, the bill of materials of automobiles has a huge fraction of the semiconductors. And we've certainly seen right now, at least right now in the United States, the unavailability of chips is limiting the production of cars and has raised the price of cars, even used cars, by tens of thousands of dollars, just because, supply and demand. They can't supply enough cars and the reason they can't do that is they don't have enough chips to do that. Now, Tesla, which has a very innovative software stack, and they're able to adapt. They're willing to rewrite their software to use different chips. So they've been able to be they could use, not like, General Motors have to get the right chip. Oh, this is the wrong chip. Well, let's just adapt our software to use it. So they've been more successful. But I think it could be a strategic advantage for a country to have its own chip supply for its automotive industry. And this could be helpful around the world. And I think RISC-V would be a good match. And what's nice about that, it's a step up in that the processors can be more powerful than they could be. They could use more power. That there may be, I think when I saw a survey of use of chips in the car, there were like 40 different applications from as little as, tail light control up until, engine control. And there's huge ranges of performance you need between them. So I think that would be a great fit for India. We've talked a little bit about the cloud, but the cloud's kind of at the high end. The cloud is, to build a good cloud data center, it's 50,000 servers, megawatts of things, and there's a lot of software that you have to be ported to RISC-V. I think certainly embedded, and I believe the automotive, the software lift will be less. And that would be a great way to get started. If you're doing great with embedded and then you're able to migrate to automotive over the next few years, you'd be in really good shape. And then, you could think that would also give some time for the software to mature for the data center. And if you wanted to get into the data center after that, after a few years, that would make it, maybe RISC-V in the data center will seem much more plausible, more believable in 3 or 4 years.
On the tool front, Google is now talking about a completely open source CAD flow, and there is a Google eFabless that is coming up. What is, in your opinion, would be like RISC-V has created a change in the computer way we look at computer architectures? Will this create an impact, and what would be how it will be useful to these startups, right? So
Yeah, I think that's, yeah. So back when, when we did the first generation of RISC-V things, we were using academic software. We were using open source software for most of what we did. Now that was, fewer
time.
Clock rates weren't as aggressive, and of course it was much larger geometries, so the electrical engineering challenges weren't as great. But we did everything with open source software. So I'm a big fan. This is the Google work is being led by Tim Ansel, so I'm a fan of open source ECAD. I don't know if we know how viable it is compared to commercial CAD products, but I think it's a start. It at least lets students be able to, anywhere in the world, to try it. And there's nothing quite as exciting. I think when I got started in computer science, it was taking the first programming course, and you see software come alive. And that, once I did that, like, okay, this is what I want to do for the rest of my life. I think you can get that same kind of excitement by building a processor. You build a computer. So you design a computer yourself, the chip comes back, you plug it in, it runs software. You can get that same, wow, I could build cheap. So both of these are inspiring opportunities. And I think what Tim Ansel is helping pioneer is one of the key roadblocks, which is where you can't afford the $10 million ECAD software that the companies can. So how are we going to do this? So he's kind of resuscitating the open source ECAD software to make this more viable, which makes it more accessible to a lot of people and should be fantastic in the classroom. So I'm a big fan. This is going to take a while to do, but I think if we get started using it and could see how well it works, I think we could also imagine, in the past, universities are pretty good at software. So if we could see what was missing in Tim's work and what we need to add, we could do that. And then there's this, I mentioned before about machine learning. There's this exciting opportunity that maybe some of the things that has very complicated software to do that the ECAD industry is doing, using a great deal of millions of lines of code. Maybe some of this work could be done with machine learning. And with machine learning, the model is it's small, like I said before, small numbers of lines of code and lots of data goes through it. So if that's true, if what the missing pieces of software of ECAD, we could replace the millions of lines of code with machine learning. And as long as that's good enough, it doesn't have to be perfect. If it's good enough, that could be a huge boom for increasing the number of design. So I think this is another exciting area there. I think people at Google have a paper about place and route in nature, and that's well documented. Bill Dally, my friend who's the chief scientist at NVIDIA, he just gave a talk, and he talked about uses of machine learning and other pieces of design, I think, in customizing the ASIC cells and stuff like that. So we're starting to see some evidence of machine learning being used to help build computers, and presumably if we can use machine learning for those pieces, that will make it both cheaper and easier to do so that more people can do it. So it's another exciting direction that's happening right now.
Right. So in this direction, one of the important things that come up, like how you started the clean slate RISC-V, I think there is also a clean slate development of the tools, because the traditional CAD tools have a legacy issue, right? They need to be supportive of this. And I think this clean slate approach can exploit modern architectures and modern techniques like machine learning.
The other thing is, and this is my point with my friends in ECAD, is they don't work that well. The very expensive CAD programs, there's not that many customers for it. So they charge a lot of money for not very many customers, but they don't, because there's not that many customers, they don't have to get all the bugs out. If you're giving them millions of dollars, they will send a software engineer over there to help your company use it, and they'll explain how to use it, and they'll fix the bugs and stuff like that. But even if you got it for free as a university, you can't get that kind of support. So it's even big places like Berkeley and MIT can get access to that software. It can be a very frustrating experience because it's not intended, it's not as well polished as a lot of the software you're used to. So, the advantage of its open source software, you can fix the bugs yourself, and you can interact with people. There's more people you can interact with. And I think the standards would be higher of how it will work, or at least you wouldn't have to be begging one of these companies to please answer your question. So I think there's, you have to be careful what you wish for, right? Oh, I wish I had this $10 million ECAD software. Well, that's not the easiest stuff to use, and if you got the software without the support, that could be a very frustrating experience. So I think this, if we get, universities building ECAD software in the or just people building open source in the domain, that could actually be a quality improvement of what's going on. Maybe we won't be able to use this to design, the latest high-end Intel or ARM microprocessor, but there's, a whole lot of chips that aren't at that stage that would be very useful to do, and that students could do in the classroom, that small companies could do for their novel ideas. So again, a very exciting time to be working in architecture right now.
Sure. So thank you very much, Professor Patterson, for your time, and it is very exciting. And certainly we would like to have you in India at some point of time once things.
Never safe to travel again. That'll be something I'll think about. But I really enjoyed visiting, and I hope you have a great conference.
Thank you. Thank you very much. Thank you very much.
All right. Goodbye.
Bye.
Thank you, Professor Kamkoti, and of course, Professor Dave Patterson. We now come to the final session of today, which is about a panel discussion on growth drivers for semiconductors. At the outset, I would like to call upon the moderator for this session, Mr. Rajan Wagadia, the Vice President and President of Qualcomm India Private Limited. Well, ladies and gentlemen, this is the final session, and we need to energize ourselves by putting our hands together. I'm sure you're going to do that. Mrs. Jaya Jagdish, the country head and CVP Silicon Engineering of AMD India Private Limited. Welcome to you, ma'am. Mr. Virat Bhatia, who is going to join us on the virtual mode, Managing Director of Apple India. Mr. Sanjay Naik, CEO and Managing Director of Tejas Networks. Mr. Sanjay Gupta, Vice President and India Managing Director, NXP Semiconductors. Amit Jain, ED and Group CTO of Unominda, he is going to join us on the virtual mode. And finally, we have Mr. Srinivas Satya, Country President and Managing Director of Applied Materials, India. Hearty welcome to all of you. And before Mr. Rajan takes over, he oversees the entire regional sales and business organization for the all go-to market activities under the Qualcomm Technologies and Qualcomm Technologies licensing businesses. After joining Qualcomm in 2011, he has played a key role in driving the long-term evolution, LTE, growth for India. Well, Mr. Rajan, it's all yours. And yes, take us through this session for the next 1 hour or so. It's on. Yeah.
Thank you. Thank you so much. Good evening, and it's pretty exciting to be a part of this very first Semicon India conference. So thank you so much. Today we've got some lovely panelists. That's also exciting because somehow I don't think it was planned, but it turned out that the design of the panelists and where they come from actually represents the whole semiconductor industry in some sense. So even if it's a coincidence, if it's designed, I want to thank who designed it, whoever designed it. But we have experts from across the industries, across the whole value chain of semiconductors. And this has been a topic of a lot of conversation. And we all who are in this world love to get this attention if it comes for the right reasons. But unfortunately, last 2 years, it came out for the wrong reasons. The shortages actually all of a sudden made us visible. All who would not talk to us started talking to us and said, again, the discussions weren't very pleasant. And sometimes we wonder why this happened, right? So my hypothesis, I'm sure people can write books on it. As Qualcomm, we have seen this across the world. Not very fortunate. But I see a lot of positives from that situation which came up. I'll come to that. The pandemic was one thing which triggered a lot of demand. Demand for devices, demand for connectivity. And these all devices consume a lot of semiconductors. So there I think it was straightforward. People knew that devices have semiconductors, so that was easy. Auto. From public transport, people preferred personal transport. And then, world over, and especially we fortunate in India, the government has been pushing climate-friendly EV push. All of that actually has more semiconductors. So auto became the other reason. And then, of course, in the homes, the home became almost an enterprise. The home became the school, the home became the office. Everybody was in the home. And what was representative of an office became home. I remember when I look at my Wi-Fi connectivity at home and I look at the number of devices that are connected, it moved from somewhere less than 10 to 26 today. And then I would say, what are these 26 devices? Sometimes I wonder that I hope nobody else is lodged into my Wi-Fi. But then you see that no, there are generally 26 devices, and in US the count is more than 50. So everything that is connected is semiconductor. And then we have 5G, one of the most dramatic and I would say a very tectonic shift in the G. In the G world, when you go from 2 to 3 to 4 to 5G, 5G actually moved a lot of things because from being very vertical, it became horizontal. And as devices or phones, of more 5G phones got sold, little did we understand that these 5G phones have more semiconductors than 4G phones. As per a report, there are 20% more semiconductors which go in a 5G phone than a 4G phone. And then more 5G you sell, there is still a stress on the industry, semiconductor industry. And in the 5G phone, the reason you use more semiconductors is because it has more RF chains. And the RF chains utilize components which are on the legacy nodes. Now there are two, in our world there are two nodes. One is called legacy, which are typically 28 nanometers and above. And there are leading nodes which are, let's say, 10, 8, 6, 5. And all the adjacent components, the RF chain components, typically are in the legacy nodes, which are the old nodes. And the capacity, global capacity of semiconductors on legacy nodes is not that much. It's all on the leading nodes. So a lot of stress got created because of that. Then again, if you look at the connectivity, everything is getting connected. The moment you see a connectivity, there is a semiconductor there. Just to give the perspectives of where the world is headed and where we as India are, the semiconductor market is likely to be at around 1.1 million to 1.3 billion, 1.1 to 1.3 trillion by 2030. We are moving far faster than that. From 600 billion, it's going to 1.1. India is going from sub 40 to 110. The pace at which we are going to grow is more than the world. And that's the very reason we are all here. I see this as a massive opportunity. And one thing which we have to see, why we see as a massive opportunity, is also because this is a very inclusive time for the industry. In the past, a 4G world, which was there, it was more specific to telecom. Now, when you look at it, the two biggest semiconductor consumption in the market had been compute and storage, number one, and then it was basically wireless connectivity. Now, if you see, by 2030, it is going to be automotive and industrial. That is additionally coming onto this. So, as the market grows, the opportunities are good. India actually is at the right moment to figure out what can we create as our niche or what can we play as a role here. So I have got my panelists here and I'm going to take any further time. Being a moderator, I can't speak more than what I'm allowed here now. So it's going to be their views. I'm just going to be moderating and I would start with the first question. We have got two panelists on the call, so you can see them, and 4 of us are there in front of us. My first question is, what do you believe has been the key driver in the growth of semiconductor in your domain? And when I say domain, today we agreed unanimously that we're going to represent not our companies as much, but represent the industry, because I haven't seen such a diverse selection. So each one of them comes from a very unique industry. So if they represent, and so it's okay if you want to talk about your company, I'm fine with that. But if you want to talk about your whole domain or your industry, that will help. So Sanjay, if you could tell us a little bit about what you believe are the key drivers. Oh, sorry. We have two Sanjay, so okay. Yes, Sanjay.
And we are sitting next to each other. Okay. No, thank you, Rajan. Just a little bit of context from where I come. I represent the telecom equipment industry, the OEMs. Tejas Networks, the company that I founded and I lead today, is probably India's largest, design and made in India equipment for the world. We used to be primarily a wireline company till about 2 years back. And then over the last 2 years, we have now built up a completely indigenous 4G RAN, which will be upgradable to 5G. So now we pretty much cover the entire spectrum of the telecom value chain. So coming back to the answer in terms of what's the demand driver for the industry here. So few things are happening in India. As you rightly said, over the last 2 years in particular, there's been a significant acceleration to what I would say is home broadband or enterprise broadband. That basically means that a lot more fiberization is happening. Homes are getting a lot more bandwidth than they ever got before. So you have a need for the modems or the ONTs at the home. Then you have the head ends, the OLTs, and then the transmission equipment, and then the whole chain. So there's a data which is growing, is in turn creating a large demand for equipment which is feeding into the data which comes out of different forms. That's one driver, which is FTTX, more connectorization of cell sites by towers. Another thing, for instance, which is going to happen and already happening is that the 5G rollout and FTTX combined together, if you take as a growth driver for the telecom equipment segment, the next 5 years are going to be very, very big for India, because less than 33% of the cell towers in the country, whether they are 4G, 3G, 2G, whatever, have fiberized. So you have still got another 50% to go. Secondly, you're going to have a lot more 5G sites. We haven't even started 5G, so you have probably another 10x of densification. Our FTTX penetration home broadband is still less than 10%. So you got another 50, 60% there. You add all this up together, it's a tremendous demand. And possibly if I look at different geographies in the world, the peak of investment has already crossed. So China is already 70% wired broadband connectivity. A lot of 5G rollouts have happened. So if I look at it from a semiconductor demand perspective, India potentially over the next 5 years on an aggregate basis, just on the telecom equipment industry for the stuff that we all know about, is going to be one of the largest consumers of semiconductors in the world. And hence it becomes so much more relevant that we do something about it versus leaving it to status quo, which has been the case for the last 20 years of our telecom growth. So that's broadly, I would say, would be the demand drivers. I would not take more time and actually let other people speak right now.
I think you brought this good point about this market is growing. And I'll later come back to you on what role can we play, not just for the market in India, but global. But that's another, I'll park that question. I'll come back to that again later. Sanjay, would you want to share some of your views as to what have been the drivers?
Sure, thank you. So like Sanjay, I will also put the context, my domain rather than any specific automotive or industrial or consumer, for which NXP as a company supplies chips to pretty much every sphere for embedded solutions. Technology would be my domain as a growth driver. And within technology, I will put a simple analogy that, we believe is easiest to understand, and we actually teach it to our young engineers. So the way we are progressing in technology world, it's simply we are trying to create a replica of humans. The way we think any smart device, whether it is a smart watch or it is autonomous vehicle, eventually we are trying to create a replica of a human, and human brain is probably the most sophisticated creation of God, probably over evolution of 5,000 years. And the way to dissect technology framework into that, we say sense, think, connect, and act. So these are the four frameworks. And when you say sense, every sensor today that we use, whether it is a radar, LiDAR, camera, or if you go to any consumer device, you have a gravitational sensor, you have the inertial sensors, and a number of other sensors. These are the sensors which God has given to us, And if we are driving a car, these sensors are actually enabling the driving. So imagine we are trying to build a technology for a driverless car. And if it has to work as good as a human or better than human. So these electronic sensors have to be better than human sensors. So which means we are talking about the imaging radar, we are talking about the radar development, the camera sophistication along with hardware and software. That is what the biggest growth driver that will drive automotive industry, for example, into a car electronics or IoT industry, wherever the application is for a touch and feel. The second is think. Every decision that human does, we think through our brain, and to replicate that, we are trying to develop these sophisticated machine learning and AI-driven algorithms, and trying to put them into this superpower GPUs and microcontrollers, and that's what we are trying to do with a very high intelligence, so that machines can take decisions, and not only they can take decisions, they can take smarter decisions without being tiring, without being getting sleepy, or without under the influence of any alcohol. That is the second one. The third one is connect. Everything that we do, we connect with each other, we connect with the people around us, and the connectivity technologies are the third biggest growth driver. We can talk about the short-range connectivity technologies from Bluetooth, NFC, or we can talk about the long-range ones, with Wi-Fi 6 or the 6G and all other technologies which are greatly coming in. And the last one, finally humans act after all that, and they act with sophistication, with the power consumption, and the equivalent is how we devise electronics, which is extremely low power, which has the right capacity to work for 10-year, 15-year battery life, and which is not polluting the environment. And that's where a lot of electronics and the power electronics that comes, which is driving the industry in energy meters, in electric vehicles and so on. So I will just summarize that Sense, Think, Connect, Act are the 4 technology growth drivers, which are agnostic to any specific industry, and they will remain so for next multiple decades for times to come.
Yeah, and that brings, you touched a point called AI, and I think that's another opportunity for India, AI, and when we see the role India can play, because I see this, the industry, semiconductor industry is moving at a pace. It's like a fast train. And there is a point at which when we start, we will go and intersect. We believe that AI is that place where India will intersect the global world on AI and AI-led semiconductors. Just to give you an idea, any simple phone, once upon a time, did not have, in the main chipset that we make, we didn't have a section or a position for AI. Today, we have a part of our chip which actually takes care of AI, and that is becoming one of the big, I would say, player or a big contributor to edge intelligence. But if we have Virat, I'm not sure. But Virat, can you hear us? Okay, so we lost 2 of our panelists, Virat and Amit. Are you there? I think now we can't see them, so all right. Okay, but well, while they come up, I'm just wanting to throw this question at you in case if you, both of you, Srinivas, you or Jack, would want to talk about this. If you want to talk about the growth drivers, in case, yes, if you have any views.
Yeah, we are seeing a hyper growth in the industry. I mean, the demand is huge, and there is a huge wave of development that's happening. When the internet came about, little did we imagine it's going to lead to so much more innovation, right? And today we see the impact of that innovation. That was one big wave. And we see the next wave happening with AI and ML, which has the potential to really change our world. So this is really the driver, the requirement for the processing power, for chip designs, testing the boundaries of our designs today. So that is what is driving some of the demand that's out there.
That's interesting. Shini, you?
Nothing more.
Okay, great. Fantastic. I think we'll go to this very famous topic of the shortage. And there are various views about the shortage, and I gave you one spin of it, why we thought the shortage. I can go for a few hours because we have tried to dissect that problem of where the shortage came from so that hopefully it will not return. But one thing is sure, what we saw in the last 2 years or we are living now is something we haven't seen in the last probably 36 years of the existence of Qualcomm. So it is a very odd event. This does happen, but the severity this time has hit everybody very hard. On that topic, Srini, the question is, as you come from that background of equipment and raw material, which is a very important ingredient for semiconductors, how in your view, what could we have done to avoid, was there something we could have done to avoid this situation? So you got some voice assistant. Okay. What could we have done to avoid this? Is there something we could have done?
Thank you, Rajan, for the question. Good evening, everybody. So I'm Srinivas from Applied Materials. I represent a very different part of the whole value chain than the rest of the panelists here. So Applied Materials and our peers, we provide the equipment that is used to make the semiconductor chips. So it's been a lot of, we've been in the limelight in the last 12 months or 18 months because of this shortage. A lot of our customers are coming to us to say, why don't you send us the equipment faster so that we can make the chips? Believe it or not, we are not able to make our equipment faster, partly because we don't have enough chips that go into it, right? So this is like the cobbler's son going without shoes to some extent. But this is not a phenomena which is just unique to this particular time. The supply-demand imbalances has been there in our industry many a times. It is just that it is much more exaggerated, much more acute this time. So it's a good time to ask ourselves, are there any fundamental lessons on why this imbalance has happened and what can we do about it, right? Unfortunately, the product life cycles and the capacity expansion plans in our industry are pretty long, right? You can't on a dime turn your capacity and ramp it up. From the time you make a decision to getting the higher capacity, it's 18 months or even longer in some cases. So this fundamental mismatch between the demand signals and the capacity will remain. What is it that we can do? I think we have to learn to live with the unpredictability, right? Ideally, it's great if we have a perfect projections for the next 3 years and you can match all your capital investments and so on. But I don't think that will be the case. We are living in a pretty unpredictable world per se. So how do you avoid those things? I think fundamentally the technology itself, even how we put together the equipment, how can we modularize things? How can we have a better and more resilient supply chain that feeds into making our equipment? How can we have better partnership between some of these product life cycles that the chip fabless folks and the IDMs are pursuing, and the equipment dependencies that go with those technology nodes? We have to have a deeper level of partnership across the value chain. That's the only way, I think, where systemically we can hope to have better match between, fluctuating demand signals and marrying it up with the right kind of supply going forward. So that will require a much closer partnerships. That's also important because I think the product life cycles are getting shorter and shorter, right? A lot more introductions. It's not just one major product release every Christmas from some of the large device makers like Virat on the panel. As those are becoming faster, even this connection between the equipment manufacturers and the technology and the innovation we provide and the chip manufacturers and how they use the equipment, that has to strengthen much more going forward.
I think that's brilliant. So one thing we noticed, and I remember this incident where somebody asked me as a question that I'm going to ask you, he used to work for a equipment manufacturer, and he said, can you imagine what is the size of a lithography machine? And the question was asked in a way that I thought, oh yeah, it has to be something big, otherwise why would he ask me? And I said, oh, the room I sit in, I stay in Bombay, and the rooms of Bombay are pretty small, but that's the imagination I had to run. I said, this as big as the room I'm sitting in. He said, probably 10 times bigger than that. So sometimes people don't understand that, and including us, these machines, when they say they have lead times of 18 months or 24 months, because there's no way we can say, okay, increase the capacity overnight. No. The lead times of the machine are 18 months or 24 months, and if the equipment manufacturer who makes semiconductor, he himself doesn't get the semiconductor, then that's probably a situation we might not want to get in again. But Jaya, on to you on the talent, because a very important ingredient of the semiconductor industry, which sometimes get missed out totally, I would rather not say sometimes, most times. How would you look at that angle in view of this sort of shortages?
Sure. While the focus is on strengthening the entire ecosystem, it's really what starts is the engineering resources. If we don't have that, the whole pipeline will stall. So it's really important. There is a talent war that's going on out there. I mean, there's huge attrition. This is globally, not just an India statement. Globally, there's a talent war. And we need a lot more people. As the demand for chips is going higher, we need people who can design these chips. And how do we get that? These are not ordinary, students that we can just hire. This is skilled labor. We need to build that. We need to invest into building that. In India, we do have a lot of engineering graduates who graduate, but they're not really 100% ready for the industry. It almost feels like they'll have to go through a finishing school to be skilled with what they really need to work on. So it's really important for us to strengthen this system. I mean, once the graduates come out of college, maybe the academia itself can be influenced to become more conducive to what the industry needs. And also, as they come out of colleges, maybe we can have the technical institutes. We do have quite a few today, but the demand is so much, we need to do more of this. So we have to have training institutes to train them on these specific, and these designs are only getting complex, more and more complex. The skill sets that were relevant 10 years ago are no longer relevant. So we need to not just induct more skilled engineers into the pipe, but also start upgrading the skills of the current engineers who are in the system. So both of these aspects are very, very critical for us to maintain or even look at catering to the hypergrowth.
I think that's well, Jay, you talked about this is on the design side of skilling. Something that came up was that a particular foundry had shut down after some investment, and I wouldn't name the country, I wouldn't name the foundry, the fab, sorry. And the reason specifically behind, after an investment of around $6 billion, the foundry shut down is primarily about the required technical skills to run the foundry. It may sound easy, but it is not. So not just the skilling of the design part of the skilling is super complex, and that's what Jaya referred to. I'm trying to say that even as you go to the fab, because the semiconductor, technically, if you can divide it in three parts. You are talking about the design and the skilling and all the design, which is a big part of it. Then is the fab, and there is the OSAT or ATMP. So the maximum skill is required in the first and the second part, and that skilling is very important. Sanjay, I'll come back to you. In terms of what can India do if there's something, I know it's a tough and a very big question, and you can choose to, I'll take this. So what would you choose, what would you really say in terms of the policy? Is there something that we could have done? Or, I know we are just initiating, and the pace at which we as India are moving on the semiconductor policy is amazing, right? All the policies. In the last 3 years, I haven't seen so much change. And in the whole, the power or the push or the energy that is there in the system. But Sanjay, you would like to comment on the policy side?
No, I think, first of all, the slew of policies which have come together are fantastic, because it's not one or the other. So I think the PLI for stimulating manufacturing, then design-led incentives for actually stimulating the design aspect, now the semiconductor policy to actually do the manufacturing, and all these three as a troika are required. And of course, before this, there was the preference to Make in India policy, which was the demand creation, right? So all the four legs of the policies are in place, and I think it's very thoughtful of the government to think of the big picture and put all the engines to work together. Having said that, I think, again, in the context of the conversation that we are having right now, which is the semiconductor shortage. So what can be done now, right? I mean, and because all the policies which are there, they will take some time to come into action and give us the results. We've already been living in this semiconductor shortage crisis for almost now 2 years, if I'm not mistaken. I mean, almost to 2 years, right? One thing I think which India should do, in my mind, as a country and as a government, is that we need to flex our muscles in terms of our home market demand a little bit more than we have done in the past. What specifically that means is if I hear the semiconductor guys in terms of the machines or the capacity or the production, if I look at the next 15-month view, the capacity in the world is limited. It's X, right? The distribution of that capacity is dynamic. If you see what Europe and US did last year, and Sanjay can vouch for that from his point of view, is that a lot of the semiconductors for the auto industries were diverted or allocated, if I were to say, to certain countries who basically raise their voice and flex their muscle stronger. So I think India as a global power, with the kind of home market advantage we have, with the kind of 5-year, next 10 years projections that we have in our economy, I think there's a reason that the country should step up to the plate and say that we need a larger allocation of semiconductors from the current capacity to Indian demand, whether it is for local manufacturing, for local design, or for whatever. And I think I'm pretty sure that the global players who are a part of the ecosystem with whom we are a part of the overall value chain would value that partnership that India will bring to the table, and accept that you never get something unless you ask. So I think the time to ask is now.
I think that's a pretty radical view, but absolutely true. Okay, we have got Virat and Amit back. We had lost them, probably semiconductor shortage again there. But we've got Virat. Virat, could you, and the question to you was, what do you believe could be the key drivers of growth for the semiconductor industry? Your view, and then probably Amit, you could just take the same question and you give your views too. Can you unmute Amit, please? Oh, sorry. Yeah, Virat.
Can you hear me?
Yeah, we can hear you. We can.
Okay, thanks. You'll have to pardon me. I have a very bad, violent cough on, so if I cough in between, I apologize in advance. I'm sorry the link dropped. So if I could just take this down to some of the basics in terms of numbers, because this is all about, we're going to get down to maths when we start talking about demand. So if the Honorable Prime Minister set ourselves a $5 trillion economy objective, let's start there. The two crucial pieces to that is a $1 trillion digital economy and $1 trillion of exports. The $1 trillion of exports will require at least $120 billion of electronics exports. And if you put everything that has got some sort of a semiconductor in it, it could be upwards of 200. So 20% of the $1 trillion exports is going to come from products that will have semiconductors. So that's one pillar on which the $5 trillion is based. The other is the digital economy, which by itself is supposed to be $1 trillion. And 300 billion of that is just electronics manufacturing. So these are the big numbers that own up to the 120 to the trillion, the 300 to the trillion, all of which sort of climb up to the $5 trillion economy. So that's just straight numbers. But in addition to that, if you look at the $1 trillion economy and the numbers that we are looking at, the electronics sector of 300 billion is actually exceptionally well qualified in terms of what it will do, where the numbers will come from. So for example, mobile phones are expected to hit about 126 billion over the next 5 years. It's currently about 36, 37. IT hardware is about 25 billion. Consumer electronics, 23. The other big one is industrial electronics at about 25. Auto, about 23, could be higher on it, and sort of probably correct me on that. LED lighting is 16, electronic components is about 18. So all of this constitutes about 300 billion, which is part of the vision document which the Honorable Minister asked the industry to put together along with the government. So there is a very specific document available which actually breaks this down year by year over the 5-year period, segment by segment where the climate. So I think it's pretty clear that the entire semiconductor policy and the incentive scheme dovetails into this larger picture. And this math is fairly simple to see. I think MeitY doesn't need to be convinced by anybody. They have done this exercise many times over in their head. So I think the government's on the same page. The industry did the math on this. So obviously ICA, Pankaj is I think in the audience, they have led this initiative exceedingly well. So they've done this. So whether it's digitalization or it's electronics or it's exports, these three are the big pillars on which the demand will come from. I'll just say one last thing, which is we need to be careful about talking about the domestic market again and again. Actually, the largest market that we have is about 5 or 6% in mobile. In IT hardware, we're about 2 or 3%, of which 70–80% is still imported. So actually, exports will have to be a significant part of what we're doing, which means we will need to be exceptionally competitive. Because even if we double the domestic market, we're still going to be about 10% on the mobile side, and about 4% or 5% on the IT side, and that's not going to be simple. So we have to target global markets, which means competitiveness is really important, which is where the big demand will come from. And then we go to the point that Sanjay spoke about. If you have those numbers, then clearly you're able to negotiate. Actually, don't need to negotiate. If you're the country that's using those numbers, somebody will queue up and say, this is what your quota looks like. I'll stop here. Turn to Amit.
Yeah, thanks. So I think I can speak more from the auto perspective, and really from an auto perspective, modern cars are nothing but computers on wheels. We've seen the electronic content per car grow rapidly over the last 10 years. It's nearly doubled. I mean, it used to be somewhere around 15 to 20% of electronics per car nearly 10 years ago. And right now it's hitting somewhere around 40+%, right? And if you really look at the number of ECUs, a car used to have, again in the number of 50 or 60 ECUs, and cars today have in the upwards of 150 ECUs. So I mean, like clearly doubled over time. What's driving this growth in automotive? So if you really look at it, there's these 4 basic macro trends that's driving the automotive industry. And you can speak about CASE, and CASE really stands for autonomous, for electrification, for connectivity, and for electrification. And if you really look at all these 4, all these 4 macro trends, they are all got basic electronic components. They are driven by hardware and software. So clearly, in terms of semiconductor industry as such, is a prime focus areas for all tier 1s, and auto OEMs, because that's what's going to bring in new features in the car. That's going to bring in, really the next gen mobility. The smart mobility and also clean and efficient mobility with electrification. So I think that's what's driving semiconductor growth, at least in the auto sector.
So 2 data points on auto, which, and I think you can validate it more, Amit, but as per a report I was reading from McKinsey, it says that the semiconductor content that is there in the car today is likely to double up by 2030. So we can only imagine that how much more of semiconductor is going to go into the car. And funnily, I think there are so many sensors in the car nowadays that you can't do anything. Once upon a time, we remember that you could have opened the hood and tried fiddling around with the car. You can't even do anything like that. You don't even know, because when a car stopped in the middle of the road, the only thing when I called up the service center, he says, your sensors have failed. I said, yeah, but they failed in the middle of the road. And they said, oh, we have to tow you. I said, yeah, if I don't die, tow me. So I think it's getting more complex. There are tons of sensors, and as we go to autonomous cars, there are going to be LiDARs and radars and all sort of cameras. What that results into as a cascading effect is the data that it collects per car is multiple of GBs one particular day per car. When you collect some multiple of GBs, upwards of 8 to 10 GB a day, every car, you have to store it. You have to store it. You have to analyze it. That shows how much complexity is required at the compute end at the storage end. So where we are headed is only a perspective of, it's not just the semiconductor content in the car which is going to fuel the semiconductor world, but it's also what happens when it goes to get stored or analyzed. To you, again, Amit, while you're there on that same thread, a question is on the supply chain resilience. So what do you think, as in India, we could have done to create a better resilience in some sense so that we wouldn't go through this again? And that's a visual thinking, and I hope it doesn't come again. And it came after 30 years for me, so I hope it comes after another 30 years when I'm gone. But what do you think is what your industry could do to see that this doesn't happen again?
Well, we're still searching for the right answers, but I can give you my perspective there. I think I do not know of a tier one in the electronic space and an OEM today that does not have a war room for this today, of what can be done, what needs to be done for tomorrow, and what needs to be done for the future. Clearly what we've seen is we definitely need more transparency, around the value chain. We never bothered from where these chips were actually coming, and the OEM never bothered to know that, till a couple of years back. But clearly I think there's more need for transparency that we are working on now. I think number two is, from a short-term perspective, there are some tactical steps, I think better forecasting, seeing if we can do some long-term planning, in these aspects, because if you really look at automotive, the, legacy has been all, chip, everything has to be just in time, lower inventories and all those aspects, and that has to change, and that's clearly what we're seeing is now that there's this full need for trying to get more visibility as well as more planning clearly. But from a long-term perspective, what we're seeing is this whole life cycle of automotive. It takes us 4 years to design a car, bring it out, and the selection of many of these semiconductors are done in year 1, the car launches in year 3, and then needs to live for 10 years. So it's you're making a commitment there when you're selecting a semiconductor for the next 14, 15 years. And you need to ensure supply chain exists for those 15 years. It's not as simple as kind of, going and changing a component, 2 years, 3 years hence. But we're still trying to see if we can build more modularity on many of these designs, trying to see if alternate designs can be proven when we design the ECU itself, seeing if we can have more options, proven bookshelf designs of certain circuits that we can swap, if a crisis, if we're headed towards a crisis or much before we're headed towards crisis, or have, 2 alternate designs or 2 alternate platforms that we can switch, between. And all this requires a lot of proving, a lot of, design reliability and robustness checks, because you're dealing with a lot of safety critical aspects. Most sensors, like you said, and it's connected to your airbags, and then you have ABS, and you've got AD, you've got a lot of safety critical ECUs in the car, and you can't really change any of these overnight. So trying to prove bookshelf designs at the time when we first build the ECU, trying to make sure that we have some things that we can swap. These are some long-term, I guess, design actions that we're working on. But short-term, it's more about planning, forecasting, visibility. That's where we're really headed.
I think Virat talked about the supply chain in his part of the world. It's very different and with different challenges than what you have, Amit, in your world, which is on automotive, where I remember that the supply chain folks wouldn't have imagined when you're talking about JIT and Kanbans of the world, and all of a sudden you have to have a lead time. So when we went first to the customers and said we have a 52-week lead time, the stare and the glare, even on videos, was good enough to say that what would have happened if we were not in a pandemic, right? And we were in front of them, they would have bashed us. So that is where the world is. But on the same point on design, because you have that infrastructure design capability you've been doing for many years, what is it that we could have done differently in the infrastructure side of the world, Sanjay?
Now, I think again, to basically handle the crisis better, you talked about just in time. So the infrastructure industry was working with a 16-week lead time, you know. So it wasn't just in time, but it was 16-week. Realistically speaking, as you rightly pointed out, I think in our own life cycle, last 35 years that I've been, 40 years involved in this industry, this is a once-in-a-lifetime event. With the wisdom of hindsight, everybody should have planned better, but then things wouldn't have happened. Realistically speaking, the only lesson I think we can take away from this situation is that there is no substitute for better planning and forecasting, which helps the entire chain, starting from the hiring of designers to planning the capacity of the machines, to the fabs, to the chips and so on. That has to be done. Secondly, what is also important is that the customers or the consumers have to plan much better, by the way. I remember last year in January, to one of the leading operators in the telco in the country, to the head of their supply chain, I said that, things are going to be bad, please plan for the whole year. He laughed at me. He says, you're the only guy, I deal with all the multinational companies in the world. Nobody has come and told me that, things are going to be bad. I said, well, you'll thank me a while later. And he did indeed thank me. And he said, you were the first guy who raised the red flag. So realistically, the whole chain has to plan better. The rollouts cannot happen overnight. And that's really where I would say there is a big concern, because for India as a country, because the next 2, 3, 4 years, if we have to continue accelerating our digital journey, we do need a lot more connectivity. We do need a lot more devices. We do need a lot more mobile phones, tablets, IT equipment, everything. And I don't see a game plan where in the next 18 months, magically the capacities will get to the point that we need to. And that is exactly the reason my comment was that can India afford to slow down for the next 18 months just because, okay, things happened in the past? I think it's time to do something about it.
Okay, I'm going to, because of the time, I'm just looking at the time. I think I have quite a few questions. I'm going to club 2 questions, and I'm going to come to you, Jaya, and then Shini, if you can take the same questions. They are about, what do you think? Now, in any adversity lies an opportunity. And I would say, how can we make India? And I know it's not going to happen overnight, but one thing which is very clear, this very event happening is a showcase of the realization that there is something which has to be done, and we are all here to do that, right? As industry stakeholders, as government, they are all there. So the question to you, Jaya, is what do we do to make India an integral part? Because we are a global economy, how do you make it an integral part of the larger story? And is there any policy intervention you believe we should look at?
So it's really refreshing to see the focus from the government. This is something that we are seeing, it's unprecedented, and it's extremely inspiring and motivating. India, again, I'm going to focus on the talent availability. India has the potential to become the talent hub for the entire world. The manpower that we have, if we can create partnerships, which I think is already happening to a large extent, between the industry and the government and the academia, I think there's a lot of things that we can do, and it can be very powerful. We can actually provide the shortfall of resources. We can address that in India. So it requires a lot more partnerships, and the focus on the government has on the semiconductor industry growth is great. This needs to continue. More investments need to be done, and the AI/ML space will just grow this demand even more. So we need to be ready for that and plan accordingly.
Maybe I'll add a few things to this. Fundamentally, my belief is while the current shortages that are there in multiple parts of the semiconductor chain is at the top of our mind, maybe in all our day jobs, we are spending a lot of time dealing with those. We can't just think about that being the driving force for what India should be trying to do. We should, India, and I think the minister mentioned this morning as well, right, with his 20-year vision of it. India should have a longer-term perspective on what is the best way that India can play a role and strengthen its position in the overall semiconductor system. So one message from me is have the longer-term view. Don't just think of this as a solution for the current topic, which is on top of all our minds. Second thing I'll say, and I'll use a slide as a reference from one of the keynote talks this morning when Dr. Randhir Thakur from Intel gave his talk. He showed a slide which had 6 rectangles across the value chain, and he highlighted the first 2, which was chip design and something else, and then the integration at the system side. There were 4 or 5 pieces in the middle: equipment, materials, manufacturing, assembly, which were not highlighted. I was hoping actually that he would come out and say which area he thinks we should be focusing on. But maybe there is no one perfect answer. I think India, with its unique capabilities, the talent, also being realistic on where we can enter the game. Probably, each part has its own challenges. So we should really, and I'm sure all of you in your own capacities are doing this, really think about which part of that chain where we could at least enter to start with, get really good at it, and then think about expanding to the left or right of it. And I'm sure there are multiple views on it, but I really think we need to be cognizant that we shouldn't go try doing all the pieces in one go. Any of the other regions, I don't think, have done it in that fashion. Maybe I could be mistaken. But certainly given the capital intensities involved, the talent issues, Jaya already referred to it a little bit. We should be cognizant, pick something, and then be really good at it and make our mark.
So I think you addressed one point, but if you, and this is great because you talked about the multiple boxes. If we see the policy which has been created, actually it addresses not probably 5 because one of the boxes was split into few, but 3 of the key ones. That's exactly where it starts. So I would say it's a great start. I think we have short time, so I'm going to skip one question, but I'm going to do the last one, which is probably a favorite of mine. And choose to change the dates if you want, but I have 2 dates in mind, 2030, 2047. They have a meaning. 2030 has a meaning, it's 10 years almost from now. And 2047 is primarily, we know why. If you had to visualize India, and this is open for, and I would love if all the 4 of you can give an answer to that. What would you see India 2030, India 2047 in context to what we are talking today? All of you, 6 of you.
Okay, maybe I can take a crack first. So I think by 2030, I mean, we should really go by the 80-20 rule, So pick and choose the battle that you want to fight to have the maximum impact. So clearly, I think system design, we pick all the products that we're going to consume in our large domestic market. If we can design and manufacture 80% of those products, I think it's a good start in 10 years. Semiconductors, if we can do even 80% of the chips that matter for India in India, it's a good start. In the manufacturing, if we can capture some geometries where your volumes would be done and could be done in India, it's a good start. And I think we can really aspire to be Atmanirbhar in a 80-20 way, because being beyond that, being a part of the global supply chain, it'll be very difficult. So I think it's good to prioritize which are the most important things. We have human capital as our biggest asset. Leverage that and really capture the 80% which really matters. And I think if we can stay laser focused on that, I'm sure we'll be able to accomplish that in the next 10 years and of course by 2047.
Thank you. If you could be a bit brief, because we will probably try to take questions if you can. But Sanjay, what do you think 2030, 2047?
So my view is, like we have become the recognized power in IT and software in the whole world. This is a very natural extension that will go to semiconductors design. And while design we keep talking about, we are designing for the world. The reality is that if we want to be Atmanirbhar in true sense, and every single design that we are talking about goes to, Indian companies, companies like Tejas and all, right? We will have to have a lot of Indian semiconductor companies that would have been born by that time. And the way I was going through the stats on maybe non-semiconductor startups, the way, every few months or few weeks, a new unicorn is getting born. I'm sure in 10, 20 years, that will be a norm for semiconductors because, I would say the San Jose, if you say Silicon Valley, it's probably a couple of decades ahead of India. So by next 2 decades, we will be a Silicon Valley equivalent with a thriving innovation culture and thriving semiconductor companies as a natural extension. So that would be my prediction.
I'll answer in a much more near term. Even 2030 looks quite distant to me. I think we don't talk much about display manufacturing, LCD manufacturing, which is, I think of it as a slightly easier and a quicker technology per se than the silicon manufacturing. We have domestic consumption for it. We have domestic decision making for it. There's no reason why India can't start with that. I'm not saying we can't do silicon or don't try silicon, but I think those are the lower hanging fruits. ATMP packaging, though again, that's getting increasingly complex as well. There's a lot of technology differentiation there. That's an area where we don't need to chase something, this whole heterogeneous integration in those areas. It's a good opportunity for India to even start there so that, you can be leading the pack to some extent. Those things, even 2030, we don't need to wait that far. Much before that, we should be able to do it. So, your prediction?
Well, I think I've already shared my views on how India can be the hub for the talent. And one point I want to make is, this is a long haul. There's no near-term solution to solve these problems. So we need to invest now. We need to have that vision that we need to work on. We start now, we'll see the results a few years later. The design cycles or the preparing the resources for the design is going to take time. So the investments and improvements, initiatives have to happen now for us to see the result in a few years.
Amit, if you could go.
Yeah, so I think I do agree on the display thing. I mean, in cars going forward, you're going to be seeing larger and larger displays, and it's going to be one of the key, factors of growth in automotive. And in short term, I see that as a great step if we could get into display manufacturing. Would be a huge benefit to the automotive sector. I would answer more of the 2047 question. From a vision perspective, at least I see if we can have at least, say, 70% of the electronic components, from an Indian source and not needing to import it, that would be fantastic if we could do that.
Lovely. I think if we have time up on our end, at least the panelists, I'm not sure that we have time for questions, but 2030, 2047 to us means that by, at least I don't want to see one more shortage during that time. By 2047, if we are sitting on the same and doing semicon, we'll have to do the math, which version was it, but probably we would have a definitive footprint on the global scenario, guaranteed. The way we are moving, the way we have architected, we are there. In 2030 will be visible. By 2030, 47 probably we will play a larger role. And as we evolve, whether it is the design, which looks to be more likely, the fab, the OSAT, the materials, there is a place for India. And it is inevitable with what the government is doing, with what all, these conversations wouldn't have happened 2 years back. And if they're happening now, it looks like there are more questions than answers, but this is how it starts. So it's a wonderful time, and thank you, panelists. Yeah, we can try taking, if you have 2 questions. Yeah, sure.
I have a question.
Yeah.
Thank you. It's very heartening listening to each one of you in terms of what are the growth drivers and discussing about 2030 and 2047. But it's also extremely wonderful to see a woman leader in an industry where you hardly see women reaching to the top.
Absolutely.
So Jaya, on that note, you are one leader who also spoke about talent and how we are at a great advantage from an India standpoint. So given that, I would also like you to touch upon how you, as a leader, since you understood the growth pangs, as well as how you managed to move through the ladder and reach where you have arrived, and you're an inspiration and a role model for several. How do you build the women leadership within AMD and also in the larger ecosystem? Because today the world is also looking at talent, not just with respect to growing talent, but also diversity, which also means women at large.
Thank you. Thanks for your question.
That's a great question. Thank you, Kiran. Inclusion and diversity is not just something nice to have, it's a requirement. We can't leave out 50% of our population and try to build something as big as this. So women, one thing that I have noticed, at the entry level, there are at least about 30% women who come out of engineering colleges and enter the industry, which is a decent percentage. But as we move up the ladder, mid-management is hardly 5%, and upper management, it's 1 or 2%. It's very lonely out there. So what causes this kind of depletion? It's really the demands of the industry. And women being the emotional, more emotional than men, we find it very hard to give up something family-wise. We feel guilty. So it's easier to give up your career, your aspirations. So that's what many women tend to do. What I try to do is, when I talk to women or when I give talks, it's not a sin to be aspirational with your career. It's a serious investment that you have done, like many other men. You need to keep up with that. Family will walk with you if you are passionate. So don't give up your passion and don't give up your long-term aspirations for short-term challenges. Honestly, most of the challenges that we as women face, most of it is in our minds because we have this guilty conscience that keeps pricking us. Oh, am I doing the right thing? No, I shouldn't be focusing on work. I should be spending more time with my kids. Lot of conflicts, right? So that's where that kind of emphasis and creating more and more role models for women to see, yes, this is doable and this is achievable is what is needed. And that grit and determination to pursue something that is of interest to you and not make it like an optional or a secondary thing. I think that is what is really needed. And you have to follow your passion like anyone else, and you are entitled to it. So that's the thing that needs to, I think the awareness is definitely there. It's much better than, when I started in the industry, but more work needs to be done. And the good part is now we have role models, like many women in the industry.
Thank you so much. Thank you.
On the display, Satya, a lot of work is being done on display. Probably you are not aware of it. Display.
He's telling you.
It's not a question, I'm just making a statement. We have 5 very large display assembly plants which have come in, which will assemble about 125 million displays this year. By next 2 years, we'll be assembling about 500 million displays. And this scheme is a composite scheme for display fabs also. And display is a very high focus for us because of geopolitical reasons. You know how one country has captured most of the markets with predatory pricing. But now they've increased pricing by 60-70%. And there is a center of excellence, which is at IIT Chennai, which has got probably the highest grant, which has world beaters as a part of that center of excellence. So we are trying to leapfrog in the OLED technology also. So something is being done, but we'll be glad to hear more from all of you.
Thank you, Pankaj. Thank you. Thank you, everybody. Thanks for this session. Thank you, panelists.
Thank you very much, Mr. Rajan, Ms. Jai Jagdish, Mr. Virat, Sanjay Nayak, Mr. Sanjay Gupta, Amit Chain, and Srinivas Satya. Well, ladies and gentlemen, with this we come to the conclusion of the deliberations of day one. Tomorrow, the deliberations would start at around 9:15. So all of you, kindly be here by between 8:45 to 9 so that we should start the session tomorrow morning on time. Until then, all of you, please take care and head back to your respective destinations safely and securely. And namaskara.